Buenos días, Natalia, ¿nos escucha ahí?
Hola, sí, los escucho bien.
Sí, le escuchamos muy bien.
A ver si puedo. Ahora sí puedo encender la cámara.
Perfecto. Está muy bien su audio. ¿Tiene alguna
Va,
presentación?
sí,
¿Podemos hacer una prueba, por favor?
sí. Dame un segundo que la estaba justo abriendo. Ahí ya deberían verla, ¿no?
Sí, excelente. ¿Tiene algún video?
No,
Muy bien. Se ve bastante bien la presentación, su video y el audio está perfecto.
vale, genial. Gracias,
Bienvenida, muchas gracias.
gracias a ustedes.
Hola, hola, buenos días. Los invitamos a pasar al auditorio para poder ir dando inicio al foro, por favor.
Coming to the auditorium so that we can begin with this forum, please.
Está la secretaria de campo, María Eugenia, ahí hay que darle reconocimiento especial. No, solamente no nos acompaña, a veces la verdad. Ajá, por eso a ella, digamos, si la mencionamos, sí. ¿Solo a ella? Sí, déjame, entonces María Eugenia, aquí. Sí. No, es que se pueden. Yo creo que lo que sí haría es y ya me echo las tres, los que ya están aquí presentes, me echo las tres biografías. ¿Creen que iniciamos como cuando ya manteniéndonos, ya estamos aquí, el programa ya viene, entonces si quieres, pues si los tenemos a los tres, porque no sé tampoco dónde está Diego.
Buenos días, los invitamos nuevamente a ir tomando asiento.
Morning, and once again, we would
Les
like
sugerimos irse
you
concentrando en
to
la parte
please take your
central
seats,
del
and as a
del auditorio,
suggestion,
si gustan.
please sit down at the center of this auditorium. Thank you.
Está dentro del guión. Parte de ella.
¿Sí? Les damos la más cordial bienvenida a este primer foro sobre recarbonización de los suelos agrícolas y descarbonización de los sistemas agroalimentarios. Un pequeño trabalenguas agrolingüístico, pero que vamos a estar practicando, analizando y con suerte resolviendo durante estos próximos 2 días. Agradecemos principalmente la presencia de el distinguido público que tenemos de manera presencial acompañándonos en este auditorio. Profesionistas, expertos, investigadores, productores, un selecto grupo de personalidades distinguidas que están aquí presentes en el auditorio con todos nosotros. Y agradecemos especialmente la presencia de la señora María Eugenia Rojano Valdés, secretaria del Campo del Estado de México, y del señor Everardo Lovera. Y del señor Everardo Lovera, director general del INCAMEX. Gracias a todos por estar aquí, por acompañarnos, por su tiempo y por su interés. Permítanme mencionarles algunos avisos rápidos que siempre son necesarios en la logística de este tipo de foro. Por favor, les pedimos encarecidamente que mantengan sus teléfonos celulares en silencio. Pueden abandonar el auditorio en cualquier momento que necesiten tomar alguna llamada, pero por respeto a todos los ponentes que vamos a tener durante el día, les pedimos mantener los teléfonos en silencio. Contamos, como habrán visto también para ustedes, con un servicio de coffee break del que pueden hacer uso en cualquier momento y especialmente en los merecidos recesos que también tendremos durante la jornada. Y recuerden hacer uso, si así lo desean, de las diademas que tenemos a la entrada del auditorio
throughout the day, and we will have headsets for the interpretation service Spanish English, since some of the presentations will be given in English. With regards to the questions and the logistics for today. And we would also like to thank not only the participants, but also all the people who have been supporting us and are connected through Zoom. In previous days to the event, over 750 people registered themselves, and hopefully they will be accompanying us through Zoom and also through the broadcasting in social media. Thank you so much for you connected through e-services. We have some important household announcements. As we told you, this event has the simultaneous interpretation service for those of you who are connected through Zoom. You can select the language of your preference in the lower bar menu. This forum will be recorded and the recordings will be available a few days later. After we finish this forum, we will let you know once the recording is edited and ready for you to have access to it. I would also like to tell you quite briefly about the structure of this forum. As you can see in the program that you have, in the agenda, and for those of you who are in the auditorium, we gave you the agenda on your way in. We have different blocks by subject matter, and we will follow the order of these subjects, and we will be able to listen to experts coming from different countries. In these 2 days, we will have keynote speeches followed by panels that will be talking about the same subject dealt with by the keynote speech in such a way that we can have a more comprehensive outlook of each subject. In turn, we will also have some panels of very specific subjects, because sometimes problems are quite complex, and therefore we will try to drill into each subject as much as possible. Each panel will be followed by a Q&A session. And here, it's important to notice the logistics of the Q&A sessions. For those of you who are inside the auditorium, while you hear the different speakers, please write down your questions in the notepad that was given to you in your way in. Our colleagues will go around the room and will pick up those questions, and we will have to select some of them. This is unavoidable. We cannot read them all. And in the case of those of you who are connected through Zoom, please use the chat in order to post your questions. We also have a team checking those questions and selecting them so that we can give them to our moderators and to be able to answer as many questions as possible in the limited time we have in. And on the other hand, we would like to remind you, and especially our moderators, that since this event is hybrid and we will have people connected from different regions in the world, it is extremely necessary to respect the time assigned to each participation. And with no further ado, after giving all these household announcements, which are so very necessary, I would like to ask you to please relax yourselves, be comfortable, and let's pay attention to everything that we will be hearing about in these 2 days, because we are about to begin. Now, I would like to ask the presence in this stage of Dr. Bram Roberts, Diego Montenegro, and Engineer Pedro Diaz Jerónimo. Please come to the stage.
Es un gusto y un honor
It is a
realmente
pleasure and it is truly an honor for me to introduce these three executives from the three institutions that they have organized this forum and these works. They will officially inaugurate this event. I know that for many of you, for both at the auditorium as well as those of you who are connected through Zoom, these three gentlemen do not need any introduction, but for those of you who have not yet met them, I would like to briefly introduce each one of them. Dr. Bram Govertz is the very kind host to this event, and he is receiving us at his house, at home, in his facilities. He is Director General of CIMMYT. He has a PhD in bioscience engineering and soil science. He has a master's in soil and tropical agriculture conservation. He has a BCH in bioscience engineering from Catholic University Leuven from Belgium. He has also received several accolades throughout his career, such as the Prize for Cooperation to the Development from the Belgian federal government in 2003, Norman Borlaug's Research and Application Prize at field level in 2014, Tecnoagro Prize given by an organization of 2,500 Mexican agricultors in 2019, and he is fellow to the American Society of Agronomy. He, besides leading CIMMYT, Professor Govert teaches at Cornell University. With him, we have Dr. Diego Montenegro, who obviously represents proudly ICA in Mexico. Diego Montenegro is representative of the Inter-American Institute for Agricultural Cooperation in Mexico. He was a Minister of Agriculture in Bolivia. He is an international consultant to several cooperation agencies. He's Director of Management and Regional Integration of ICA. He has represented ICA in Costa Rica and Venezuela. He has a PhD in public policies, and he has a master's in agribusiness. And to complete this inaugural panel, we have Engineer Pedro Díaz Jerónimo.
Esto es una pequeña sorpresa dentro del programa, ¿verdad? Van a ver que
this is a small surprise in this agenda. You know, this kind of unforeseen events will be happening throughout these 2 days. So, Engineer Díaz Jerónimo is an agronomist engineer. He is a specialist in agricultural economics by Chapingo University. He has a master's in economy for development with expertise in economy, environment, and politics by Wageningen University in the Netherlands. He has several specialty courses in project management for the agri-food industry. He has worked with FIRA in the last years, providing financing for projects that will be helping to foster sustainable agriculture and agricultural innovation and development. He has been leading in rural FND and other agricultural centered organizations. With no further ado, please, gentlemen, you have the floor. Thank you very much. And before we begin, I would like to welcome you all. Thank you, and big welcome to CIMMYT. Both the title and the stage have several symbols that are quite important. I will talk about them later on. I would like to thank you for participating with those. Both ICA and CIMMYT are Wallace centers, where we were created by Mr. Henry Wallace, who was vice president to that organization back then in the USA. And so we are brothers. We have been siblings for a long time. I don't want to use sister or brother, but rather siblings, institutions. Thank you very much for the cooperation work that we have been doing with ICA. I was with your general director a few days ago at Iowa. I would like to say that FIRA is one of the most prestigious organizations, financially speaking, some of the most important financial institutions helping the fields, agricultural fields in Mexico. Thank you so much as well, Mr. Diaz Jerónimo, because you have been supporting lots of projects in terms of sustainability and promoting agricultural conservation. I was yesterday with Mr. Elizondo, Director General of this institution. He apologizes for not being with us today. And a few minutes ago, I greeted Maria Eugenia, Secretary to the Fields in the state of Mexico, and we talked about the importance of diversifying our crops. And this is one of the first symbols that we have at CIMMYT. Those of you who know CIMMYT for a couple of years ago, like Everardo Lovera, know that in here we were not planting sorghum, millet, sunflower, etc. Only wheat and maize were planted. But several years ago, we started talking about the importance of crops rotation, and hopefully you were able to witness these efforts in terms of diversifying our crops in our fields. You also saw many butterflies flying all over the fields, and this is because besides other crops, we have introduced some stripes of flowers that are attracting beneficial flora and fauna into the fields. Patricia, she's with us, and she's representing the sustainability side of Syngenta company. And on the other hand, she is vice president of the CNA Sustainability Organization, with whom we have been working also hand in hand. And these stripes of flowers were ideas that came from them, and we were able to make them tangible thanks to the cooperation of our keynote speech. Yes, he is a keynote speaker, Simon. And before I continue, I would like to apologize to you because I cannot be with you throughout the forum. Those of you who know me know very well that a big part of me would like to stay here because I would like to hear these very interesting talks. But when you are a Director General, you learn very quickly that you don't have anything to do with your agenda at all. They tell you what to do and where to go. So today we have a very stringent agenda, and as you understand, we have to make important phone calls since the news were given to us at 6 a.m. So I will have to leave as the time determines it, because I have to make several phone calls. So welcome to this forum's Recarbonization of Agricultural Soils and Decarbonization of Agri-Food Systems. I don't know who gave this title, but you wanted to be quite comprehensive, right? You wanted to embrace everything. So let's talk about the decarbonization of soils, because we know that these are important pits of carbon reserves. But for them to be used as carbon reserves, we have to decarbonize agri-food systems, because if we exhaust the soils, they cannot provide us with carbon nutrients. So on the one hand, if we have these reserves, but we are exploiting our soils, at the end, the agricultural sector will be contributing to pollution. Doesn't matter how much carbon we inject into our soils. If, on the other hand, we are overexploiting the use of pesticides and also the excessive use of energy for irrigation purposes, and excessive use of transportation to take our products throughout the world. So we cannot be a responsible sector, a sector that is part of the solution for the climate change, if we do not do both things: recarbonizing our soils and decarbonizing the systems. Carbon is the unit of measure that we're using, but obviously we are also talking about nitrogen-based fertilizers. If we allow
Estoy un poco
those
cansado, no dormí mucho.
nitrogen releasing fertilizers to release the
pero todo lo medimos en carbono.
byproducts into air emissions, we will have even a greater impact than producing directly CO2. So obviously we need a transformation. We need a change instead of just thinking on production, on yields, which was an approach 50 years ago, to a different approach based upon resilience. So having efficient yields, efficient production, having now resilience being introduced into this equation of production, high production levels. Resiliency, when you are a child, that you are so flexible, resilient in terms of managing rainfall conditions. First, we had a very dry season, then we had a good rainfall season, and all of a sudden it is gone again. We have to be resilient enough in order to respond promptly to those climate changes conditions which change so abruptly. Of course, in this case, we have to create redundancy. What happens? In good years, we may be doing things twice because we will invest in the soil, we will apply crop rotation, we will diversify crops, and this requires a lot of thinking. Maybe we could have done things in a simple way in a good year without thinking so much. However, in bad years, doing those tasks will help us save our crops at bad times. We will also talk about very good agricultural practices. They are champions in this subject here with us present, and we will also need the support of financial institutions such as FIRA. They have been leading these efforts at the state and at the regional level. I remember a project that was made together with the state government of Tlaxcala. Gloria, you were with us in that battlefield, remember? I don't remember very well if we were working plot by plot. I don't remember the exact title of that project, but it had the same idea, working with the growers, with agriculture for the conservation of our soils, being responsible in our agricultural practices with keynote indicators. We were talking more about the process, not so much measuring the carbon being released from those systems, not because we did not want it, but because we did not have that knowledge back then. Now this group will have to change that focus. We will not only concentrate in the process, but considering also regenerative agriculture, saying, if you take care of your system, this will be the results: less use of water, less release of greenhouse gas production, and this will give you credits, carbon credits. So this is the change that we need. As we say in English, we have to aim towards a change for the benefit, providing a prescription to the growers so that they can be empowered based upon knowledge to make the right decisions, and that impact is what we will certify and measure. In 2023, some pieces for data. Carbon releases coming from fossil energy production represented 37.4 billion tons, and the carbon reserves in our soils and forests are uptaking half of those emissions. So this means that we have to do two things: decarbonizing the system and recarbonizing the soils, because it's not enough what we can uptake and we are releasing too much. You know, sometimes with these things that are very complicated turn to be out quite simple indeed. I was checking the conferences last night in preparation for this introduction. There are several international speakers. We have over 600 people registered online. You will have presentations of a very high level indeed. What happens after this seminar will depend on you. So in this regard, I would like you to consider this seminar not as another conversation per se, but let it be the beginning of actions that will have to be replicated later on our team, and I will ask your teams as well to prepare a series of workshops based upon the results that come out from this seminar, okay? So that you can say, this is what I did after participating in this seminar. Actually, I did this. So this is what I told our CIMIT team yesterday. I said decarbonization of the systems, agricultural systems, and recarbonization of our soils has to be part of the agenda going for the improvement of our agricultural practices versus the climate change. Okay, so we will include it in our agenda. Thank you very much.
Gracias, Bram, por esas
Thank you,
palabras.
Bram, for these words. I think they prepared the framework to start this event. These three institutions, and many of you present here, have been working together for this forum to be successful and for being the beginning of fora of this nature, seeking towards the future concrete results and concrete actions. So we give you the warmest welcome. Good morning, good afternoon, good evening to those of you all over the world. Thank you so much for those participants who are present here. Yes, Bram, they told me that 700 people registered from different countries.
Quiero saludar de manera muy cordial a la
I would like to give also the warmest welcome to the Secretary to the field in the state of Mexico, to the Director of ICAMEX, to Patricia, our good friend representing CNA, and an important company that is linked to the agricultural and livestock sector of Mexico and the world. Thank you to all of you, dear participants, to this forum. It's a pleasure to see these three institutions, CIMIT, ICA, and FIRA, being together, working jointly in this subject that is crucial: recarbonization of agricultural soils and decarbonization of agri-food systems. Yes, at the beginning, as you did, it was difficult for me to understand the title and how can we deal with such a huge scope in one seminar. And in fact, we're talking about all the initiatives, all the ideas that are leading us to build up a new paradigm, a new way to do agriculture in Mexico and in the world. And I would like to emphasize the fact that we have to be optimistic. The things that we are doing, quite probably not at a mass scale yet. And this is part of our responsibility, definitely, to spread out the good things that we are doing all over the world, and specifically in Mexico in terms of good agricultural practices, good livestock practices that will help us reduce the greenhouse gas emissions, topics such as zero tillage or minimum tillage, crop rotation, like Bram mentioned, the use of bio inputs replacing agrichemicals, which have been used in the past in not such a responsible manner and in a massive way. The fuel consumption I came from Brazil today. I arrived very early in the morning. We were visiting Brazil along with a delegation checking on all the innovation made in that country regarding this topic, government projects that are proposing the use of bio inputs as well as sustainable production of biofuels in the agri-industry within what we call circular economy, bioeconomy, regenerative agriculture, with important alliances being formed among the public, the academic sector, the private productive sector, and international organizations. We believe that through those alliances, this cross-sectional work, we will achieve the results that we are expecting. Throughout this construction, throughout this optimistic vision, we would like to start working in this first forum so that we can become the speakers about the new way of practicing agriculture in the world and in Mexico. And we have many other institutions besides the three that are represented in this stage. Many other institutions share the same responsibility in forming, communicating about good agricultural practices, good livestock practices that will lead us to have a more sustainable farming that is fairer, is more balanced. So, as you said, Bram, we cannot stay at the study level, at the analytical level. We have to transform all the knowledge into practical solutions and actions. And as I said, this is just one effort of many others that are being conducted in our country and also at a global level. For instance, field demonstrations, knowledge transmission to the youth, to women working in agriculture, trying to eliminate those barriers that impair them to have access to funding, to technology, to knowledge and information. And I would like to give a special recognition to colleagues from many institutions, FIRA, ICA, CIMIT, that have worked very much this year. Ramiro Ortega, Isabel Peña, Jelvan Van Loon, Camino Aparicio, and many other people who have been working very, very hard for this forum to be successful. And once again, I give you the warmest welcome and wish you the best success in building up this new paradigm, this new vision, which has been built up from the Americas into the world. Thank you so much.
Bueno, de mi parte, agradecer a Bram Govers por la
invitación. I would
invitación.
like to thank Bram Govers for the invitation and also to have Dr. Montenegro here. It is a pleasure for us to be here in these facilities which have been working for so many years in pro of agriculture, especially for the benefit of maize and wheat. At the beginning, with intensive production models that used intensive inputs as well. And now switching to sustainable agricultural practices. Today, when I arrived at CIMIT, I had visited to these facilities twice, but I did not recall where it was. So I asked the gentleman at the reception desk, and he was preparing the flower pot that we have here. And, you know, he just cut those sunflowers from the field across the reception desk. They did not bring them from abroad, you know, or for plots nearby. They just cut them in front of the front desk. This is unbelievable, and this is really aiming to the main message we bring inputs from long distances, creating a huge carbon fingerprint. Carbon is part of the solution, but it's also part of the problem that we're facing nowadays. And indeed, it is our responsibility in the case of FIRA, dealing with all the value chain. But the most important part, or the source of everything, can be found in the hands of growers. So we have to provide them with mechanisms, policies, incentives, so these growers can do this conversion work in their productive practices. And this is not easy a task, not at all. I believe that the larger number of landowners are in a country or in a region, the better care will they take of the soil, because there will be many more eyes taking care of the soils. When we have one person, owner of 10,000 hectares, quite probably he will not know what is happening with so many hectares. They will not be as careful as those growers with only half an hectare, 1 or 2 hectares. They are there scouting every day their fields. They know very well every inch of it. And once again, we go back to the past. Our small growers, those families who own a piece of land, use very little those inputs that are producing those emissions coming from greenhouse gases. This is part of a paradigm. I remember that back in the 80s and in the 90s, we wanted to increase their yields through the intensive use of fertilizers, inorganic fertilizers, machinery, gravity or flooding irrigation, as we call it. And back then, what we were doing was really to have productive processes that were less sustainable. Our country has its peculiarities. We have very particular situations because of the land tenure. We have almost 30,000 ejidos or communal lands. Half of the national territory is divided into these ejidos or communal land. And this is one of the strengths that we should take advantage of in our country, so that we can switch towards that change in producing our food in a different way, instead of using intensively those inorganic inputs and making non-efficient use of natural resources. We should switch and go back to what we did in the past, being more sustainable. This is what FIRA does. For instance, we are helping to lower down the production costs. We have some very specific lists of production costs. You can even go into internet and find them. And for instance, for conventional agriculture in Sinaloa, in order to grow maize, this list of costs talk about, for instance, 600 kilograms of fertilizers, inorganic fertilizers, using 100,000 corn seeds per hectare, with some very specific cultural practices where we use 7 or 7,500 cubic meters per hectare in order to irrigate the maize fields. And we also compare those costs with agricultural practices that have as their aim to preserve the soils. And we make a comparison between both costs, but this is not just a matter of having goodwill. We have to provide incentives to our growers so that they can break away from that culture. For instance, through the Center of Technology Development in some specific regions, we can have demonstration days and to identify those farmers, those growers with sustainable practices to help us gather other growers so that we can communicate to them more sustainable practices. And this is part of the change of vision that we are needing. And we have three different costs. Once we have some practices already introduced, like for instance, pest control with beneficials.
El dejar ahí, hacer un paso menos de maquinaria. Luego otro un poco más
less our machinery, and then having another demonstration day where we can include other more sustainable practices, like for instance leaving the crop residues on the field, or talking about the best use of irrigation services and not using pesticides, but instead using chemicals, using beneficial organisms, and also non-tillage practices, minimum or zero tillage practices, little by little, you know, at the steps, because it's not easy to go from an intensive, non-sustainable agricultural practices model into a more sustainable system, because you have to get used to the new management techniques, having in mind some key performance indicators and keeping up the yields at the same level, because obviously if they lose yields, they will discard these novel practices. It doesn't matter if they are taking care of the environment, they need profits. They need profits to survive and also to pay for the credits that or the loans that they usually get to farm their fields. I'm talking about some of the topics that our Director General will talk about tomorrow, but FIRA has about 23 billion pesos currently funding sustainable projects in the country.
Hemos estado financiando, como les dije, toda la cadena.
And we have been funding the whole chain, as I said before. 15, 20 days ago, we had a meeting talking precisely about this topic, and there are lots of opportunities. For instance, in sugarcane fields, they already have some cogeneration plants. They use bagasse, sugarcane bagasse, for as fuel for their cogeneration plants. For instance, they use biochar as a soil enhancer in the surrounding fields and even in their own sugarcane fields. This is one project, one example only. We also, as consumers, are responsible for improving agriculture. For instance, as a consumer, you can go to a store and check the different bananas that are bought. Those of you who have spots, people do not buy them, and they are in fact the sweetest bananas. So as consumers, we also have to change habits, because any consumer preference in terms of agricultural products will have a huge impact on the growers. They will have to change the production model. They will have to introduce those new varieties. They are just getting used to a specific cultural practices when all of a sudden you're telling them, you know, what you're growing is no longer marketable because the consumers don't want it anymore. So once again, they have to switch all their cultural practices. This is a complex task. So our purchasing power as consumers do not give us the right to
malgastando recursos que son escasos, ¿no? Malgastando agua, malgastando y desperdiciando
promote
alimentos.
the poor use of natural resources that just waste water, waste natural resources. So
mañana en una conferencia que
FIRA represents the whole value chain, and tomorrow we will talk more about the work that we do in this regard. Thank you so much.
Agradecemos las palabras del doctor Govers, del doctor Montenegro y del ingeniero
Dr. Govers, Dr. Montenegro, Mr. Diaz, for your introductory words. Thank you very much.
Les dije que iba a ser un pequeño
I told you this was going to be like a tongue twister, but we can practice in this today. So let's begin with the main topic of our work for this first section. We will begin with this practice. I will introduce those people behind the scene that are our facilitators or moderators. On this occasion, I would like to ask Dr. Diego Pequeño and Dr. Simon Fonteyne to the stage. The moderator for this first block is Dr. Diego Pequeño. He is a wheat modeling scientist working in the sustainable agri-food systems here at CIMMYT. His work is on the simulation of impact scenarios to better guide breeding towards features and combinations, more effective features for world wheat production. He also works to decide the importance of an individual feature or the best combination under different climate change scenarios for different crop systems in key regions for wheat. He uses information clusters of high performance to execute crop model simulations in grids for current and future climate scenarios. With this history, who better than him to facilitate the first block? Please welcome them.
Bueno, muchas gracias por la introducción.
Well, thank you very much for this
buenos días a todos.
introduction. Good morning, good afternoon. Please be welcome to this first block of presentations. We will begin with a keynote speech, the first one of this webinar, and the title is Regenerative Agriculture, Concepts and Scientific Evidence of its Benefits for Carbon Sequestration in Agricultural Soils, presented by Dr. Simon Fonteyne, leader in agronomy and sustainable agri-food systems at CIMMYT. I will read his bio. Simon Fonteyne, he leads the agronomical research for Latin America for the program of Sustainable Agri-Food Systems at CIMMYT. He coordinates a network of researchers in Mexico, Guatemala, and Honduras that implement field trials in order to improve local production systems. He is author of several scientific publications on topics as conservation agriculture, soils health, irrigation, weeds management, and traditional agroecosystems. And please join me welcoming our distinguished speaker. Please, at the end, we will have a Q&A session so you can actively participate. So without further ado, I give the floor to Dr. Simon Fonteyne.
Gracias a todos por estar aquí.
And thank you all for joining us today.
Muy bien, muy buenos días.
Well, thank you and good morning.
Un poco raro dar una presentación así sentado.
It's a bit odd to be presenting like
Más fácil
this,
de hablar
sitting in a chair.
parado, ¿no?
I prefer to stand up. It's
Bueno,
easier for me.
Hoy voy a hablar sobre
Today,
agricultura
I will
regenerativa.
talk
Sabemos
about
que es un tema, pues, de
regenerative
moda, un
agriculture. We
tema
know
amplio
it is a
también,
trendy
y hoy
topic,
voy a
a
hablar un poco de
broad
cómo
topic
nosotros estamos
also, and
trabajando
I will
con esta
share how we
terminología, con
work
estas prácticas,
with
con
this
este sistema.
topic and
Pues saliendo
practices
desde la
and different
ciencia
systems,
hacia cómo
stemming
podemos
from
implementar en
science
campo con los
until how it
productores.
can be leveraged on the field with
Para
farmers.
empezar, pues un poco cómo
So,
interpretamos
to
nosotros
begin,
esta agricultura regenerativa.
what it is for us, regenerative
Es,
agriculture.
pues, esta diapositiva probablemente no es
This
nada nuevo para
slide
los que estamos aquí,
perhaps
pero
is
la
not
idea
new
sale
for
de
most of
pues,
us,
la
but
crisis en que estamos con la
this
planeta.
idea is to
Sabemos
present
pues
the
que el
crisis we
cambio
have in the
climático nos está
planet.
pegando muy
We
fuerte.
know that
Este año,
climate change
aunque
is
llovió, también está
hitting
dando
hard,
altas temperaturas,
and this has
em,
been
lluvias
uh,
desfasadas. Además
really
de eso,
hot
tenemos
year,
la caída de
dephased
la
rainfalls,
biodiversidad,
plus a
la
loss of
pérdida de muchas de las
biodiversity,
especies,
the
hasta los
loss
insectos,
of
los estamos
several
perdiendo.
species, even
Y
insects are
tenemos
being
la amplia
lost.
degradación del
And
suelo que
we
pone en
had soil degradation also
problemas pues nuestra producción de
that
alimentos hacia el futuro.
harms food production for
Y
the
en esto,
future.
pues el cambio climático en el tema de la
And
agricultura es muy
in all of
importante,
these, the climate
porque de
change and
un lado, la
agriculture
agricultura
is
es una de las
important. On
causas
one side,
importantes del
agriculture
cambio
is
climático.
one of
Junto con
is
el
an
uso de tierra, la
important
agricultura
uh,
es responsable
an
por un
important sector
25% de las
harmed by
emisiones de
climate
gases de efecto
change, but it
invernadero.
also it's an
Pero al otro lado,
important
también la agricultura es el principal afectado
emitter of
del cambio
greenhouse gases.
climático.
But on
Si
the
las
other side,
temperaturas
it's
están
also
demasiado altas,
harmed
si las
by
lluvias no
climate
vienen,
change.
si hay
If there
más
is no
tormentas,
rain,
pues
if
es la agricultura que
temperatures
va a
are
estar
high, if there are more storms,
sufriendo más que
then
todo el resto de
agriculture
los
will
sectores.
be suffering the impact
Entonces, pues
more
hay
than
muchos
any other
problemas
sector. So there are
en la
several
agricultura.
issues
Pero pues no
with
podemos
and
pensar
in
pues ya,
agriculture,
entonces
but
que ya
we
paramos,
cannot
dejamos la
think
agricultura y ya
of
nada más.
doing
Pues
nothing,
no,
let
la
alone
agricultura,
agriculture.
aparte de que
No,
nos
no.
alimente, también es parte de
Agriculture
la
is the
cultura, de
source for
nuestro
our
tejido
food.
social.
It's part
Y al
of
final
the
de
culture
cuentas,
of the
pues muchos de
social
que estamos
fabric.
aquí,
And at the end
pues
of
lo que
the
más
day,
nos gustaría estaría pues,
most of
estar
us
sembrando en
here,
nuestra
we would
parcela y
prefer
estar
to be
tranquilo en el
working
campo.
our
Entonces
land,
la
in our
agricultura
plots.
pues no
So
podría ser una
agriculture
solución también para todos esos problemas.
is
Necesitamos una agricultura que
also a
no
solution
solamente
for the
tiene efectos
problems,
negativos,
because
tenemos
we need an agriculture
agricultura
not only
que
with
pues en
negative
vez de hacer
effects,
daño,
but
regenera
also an agriculture that will
pues, la
help
planeta, básicamente, ¿no?
regenerate, well, basically the
De ella
planet.
sale la idea de
So this is where we
agricultura
got the
regenerativa. Sí
idea of
tenemos
a
ejemplos de que
regenerative
sí se puede
agriculture. We have
hacer mejor.
examples that we can do
Es un
better.
foto de nuestro
This is
ensayo a
a
largo plazo.
picture
Si
of our
quieren, en
long-term
la tarde lo
trial.
podemos
In
ir
the
a visitar.
afternoon, we
En
can
este
visit
ensayo,
this
a la
plot.
derecha,
On this
hemos
trial,
hecho
to your
30
right,
años de
we
la práctica convencional.
have presented
Monocultivos,
30
labranza,
years of the
degradación del suelo.
conventional practice,
Y
single
a la
crop
izquierda son
and
30
tillage on the
años
soil. And
de
to the
buenas
left, it's
prácticas.
30
Cero
years of
labranza,
good
dejar todos
practices,
los residuos
zero
para
tillage,
cubrir,
leave the
proteger, nutrir el
stubble to
suelo
cover,
y hacer una
protect, and
diversificación de
nourish the
cultivos.
soil, and
Y no solamente
practice
tenemos un
crop
mayor rendimiento. El año
diversification. Not
pasado,
only
600
our
kilos
yields are
en lo
higher,
comercial, 6
last year
toneladas en agricultura y conservación.
100
Pero
kilograms
esto
to the
también
right
va
and 6
junto
tons to the
con una
left.
reducción
But this
fuerte en
goes
emisiones.
along with a
Mientras que en
strong
la convencional
reduction
tenemos
on
emisiones
emissions, while in
positivas
the
de 1.2
conventional
toneladas de
trial,
CO2 por
we have
hectárea.
positive emissions
Con la
of
agricultura de
1.2
conservación capturamos
CO2
tanto
tons
carbono
per
que
hectare.
se ha
And
estimado a
with
una
the other, we
agricultura
capture so
que
much
captura
carbon
6
that
toneladas de CO2 por
we
año.
have calculated that it
Entonces,
sequestrates
pues sí se
6
puede hacer
tons carbon per
y
year.
el interés por
So
la agricultura
it can be
regenerativa ha
done.
aumentado
With this, we
exponencialmente en los
increase
últimos años. En esa
exponentially
gráfica
the
pueden ver
interest
cuántas
of
veces fue
regenerative agriculture.
mencionado
We can see in this
en
plot how many times
textos,
this was
literatura,
mentioned
etcétera.
in
En
the
los últimos años
literature
y
in the
vemos que
past
hay un
years,
interés
and we can
bastante fuerte
see that the
últimos años.
interest is pretty strong in previous years.
Pero allá el problema es
But
cómo
then we
vamos a
have the
definir
issue.
realmente esta
How
agricultura
are we
regenerativa.
truly
Está muy
going
bonito
to
el término,
define
pero si no
regenerative
significa
agriculture?
realmente
The
algo,
title is really
pues,
nice,
¿qué
but it
estamos
has to
haciendo, no?
have some
Entonces, hay
meaning
mucha
on
gente, muchas
what we are
organizaciones que han
doing. There are so
tratado
many
de
people, so many
definir agricultura
organizations
regenerativa
that have
con
tried to
un
define
conjunto
what
de
is
prácticas. Hay
regenerative
varios,
agriculture with a series
algunos
of
pueden
practices.
reconocer hasta sus
Some
marcos
of
lógicos
you
aquí.
might
Y depende
recognize
mucho
your
de
frameworks. It all
quién lo está
depends
definiendo,
on
pero en
who's
general va a ser
defining
agricultura,
it,
conservación,
but
entonces reducir
usually
labranza, cubrir
this
el suelo,
agriculture is
diversificar cultivos
conservation
y
plus
algunas otras prácticas
tillage and
que les
other
gustan a esta
practices
entidad.
that
Allá el
this
problema, luego,
entity
es cuáles
likes.
prácticas.
But
Nosotros
people might ask,
trabajamos
which are the
en
practices?
todas las
We
condiciones
work
desde el continente,
across
del mundo,
all the
básicamente. Entonces,
conditions
desde
of
el
the
desierto hasta
continent,
la
of all
selva
the work
tropical.
from the
Y pues
desert to
no
the
hay tantas prácticas
rainforest.
que se puedan
And
implementar
there
en
aren't so
todos los
many
diferentes
practices that
ecosistemas.
can be
Entonces,
implemented across every
podemos tener
ecosystem.
una
So
definición
we could
de
have
agricultura
a
regenerativa basada en un
definition
set
of
de prácticas.
regenerative agriculture
Eso
based on a
implica
set
quizás
of
que no lo
practices,
podemos implementar
implying
en
perhaps
todas
that
las
these
diferentes
cannot
condiciones.
be
Por ejemplo,
implemented
hay marcos
in every
lógicos que
condition. There
incluyen
are some
raíces
logic
vivas
frameworks
todo el año,
that
cultivos de cobertura.
include
Está muy bien. Pero aquí en
canopy
Texcoco
crops
tenemos
all
lluvia
year
de
long.
mayo
This is
hasta
okay, but
octubre.
here in
Entonces,
Texcoco,
pues
we
no
have rain
podemos tener
from
raíces
May
vivas
to
todo el año.
October,
Entonces,
so
no
we
podemos hacer
cannot have
agricultura
live
regenerativa.
roots all year. So
Esa
is it
sería
possible for us to have
implicación de
regenerative
definir
agriculture? That would be my
en
main
práctica.
question while
También al otro
defining
lado, no es
which
porque
practices.
estamos implementando una
Also,
práctica
it
que
is not
necesariamente
because we
vamos a
are
tener el
implementing
mismo
one
beneficio
practice that we
en
will
todos
have
todos
the
los
same
lugares. En
benefit
algunos lugares
everywhere.
puede ser
In
muy
some
bien tener cero
locations,
labranza,
it
en
can
otros
be
lugares puede ser
okay
no
to have
factible.
zero
Lo
tillage.
mismo
In other
en comprar
places, it
ganadería,
might
por
not
ejemplo.
be possible or
En
to
algunos lugares puede
incorporate
ser muy bueno,
livestock.
otros
In
lugares
some
puede generar
places, it
una
could
fuerte
be
compactación.
good.
Entonces no hay un
In
set de
other
prácticas que yo podría
locations, it could
recomendar
be a
así
source of
ampliamente que sería
compacting.
regenerativa
So there is
ah,
no a
siempre,
single
por
answer
definición.
for a practice to lead to
No soy
regenerative
solo yo que lo
agriculture
dice.
by
En
definition.
general,
And it is
la
not only me
definición
who
de
says this.
agricultura regenerativa, la
Usually,
mayoría
the
de las
definition of
organizaciones
regenerative
están
agriculture,
evolviendo hacia
most
una
organizations
definición
are
más basado en los resultados.
choosing a
Decimos
definition
regenerativa,
based on
pues, ¿qué
outcomes. We
significa esa
say
regeneración y
regenerative. So
cómo lo
what's
podemos medir para
the
estar
meaning of
cierto,
this
estar
regeneration,
diciendo
and
que
how
sí
can we
estamos
measure to
regenerando?
say that yes, we are
Esta definición es algo que
regenerating?
más o
This
menos
definition
cubre
is
muy bien
something that
lo que entendemos bajo agricultura
covers what
regenerativa.
we
Entonces,
understand for
agricultura
regenerative
regenerativa
agriculture.
es un enfoque
So it
agrícola
is
holístico
an
y basado en
holistic
resultados
agricultural
que genera
approach and is
productos
based
agrícolas
in
y al
outcomes
mismo tiempo tiene
that
un impacto
generates
neto positivo
agricultural
a
products
nivel
and at the
finca
same
y
time
paisaje,
has
en la
a
salud del suelo,
positive
la
net
biodiversidad,
impact
el
at the
clima,
level
los
of
recursos hídricos
exploitation and
y los medios de
landscape on
vida de los
health,
agricultores.
soil
Básicamente,
health, biodiversity,
bueno, esa
climate,
definición
water
no la inventamos
resources,
nosotros,
and
lo adapté, traduje del
farmers'
OP2B, es
livelihood.
una organización de muchas empresas a nivel
This is
mundial
not
que
my
están
answer. It
pensando
was
cómo
an
generar
adaptation
una definición de
from
agricultura
the
regenerativa,
definition of
pero básicamente
an
va hacia allá.
organization
Un
that
sistema de
was thinking
producción
about the
que es
same.
rentable para el productor, pero que también mejora la
Production
salud del
system,
suelo,
it's
la biodiversidad, el
important
clima,
for farmers,
ahorra agua
improving
y
the
mejora
life
la calidad de vida de los productores.
and the
Básicamente, no es nada
soil
nuevo,
health,
son cosas que
improving the
hemos
livelihood. This
trabajado
is
por
not
mucho tiempo,
something new.
pero aquí
We
el
have
enfoque
worked
también
with these
es buscar
concepts for some
no
time
nada más
now,
ser
but
sustentable,
now
pero
the
hacer
idea
algo
is
positivo y
trying to
también
be
poder
not only
medirlo para estar
sustainable,
seguro
but
de
also
que sí
to
hay una
have a
regeneración
positive
real.
outcome that can be measured in order to
Como ves, pues no es
decide
nada
if
nuevo,
in true we
eso
have regeneration. As I
esa
said,
gráfica lo hice en
this
los
is
años
not
2000,
something
mi
new. This
antepasado
is a
Fonteyne,
plot
básicamente ya
from
estábamos buscando estos
2000.
tipos de cosas
We
mediante prácticas
Back
sustentables.
then, we were
Hace
thinking
20
about
años, como lo
finding these
mencionó
sustainable
Bram en la
practices
introducción.
as Brahms presented in his introductory
Entonces,
words.
lo que necesitamos son buenos indicadores
So
de
what we need is
agricultura
good
regenerativa. No
indicators
nada
for
más podemos decir,
regenerative
estamos haciendo agricultura
agriculture. It's not
regenerativa,
only that we
entonces
said,
todo
oh,
bien.
we
No,
are practicing regenerative agriculture. No, that is not enough. We need to be data-driven. We need to be honest. Thinking how we can measure this regeneration in order to state that, in fact, we are regenerating. And if we measure that the impact is not good enough, we can modify our practices. And if we never measure, we will never know. So we need indicators on CO2 emissions, soil health, water use, all of these aspects that we have included in the definition. But there's a constraint, because if you have unlimited budget, well, you can try to measure everything, but our budgets are never unlimited, and we don't want to spend everything on it also. So we need to work in having good, scalable standard, good indicators to generate data to compare practices, and this is work to be done. It is work in progress. It is not done yet. So this was just to present a general idea of what we are working. And now I would like to present on how the agronomy team and all the colleagues that work in different hubs, in different CIMID locations, how are we working on this? As an introduction, I would like to share what I do. I am the agronomy lead here in CIMID for Latin America. On one side, we conduct scientific research in our experimental stations. As you can see on the screen, we have several trials on how to improve production systems, long-term trials, but also that trial on the different crops. When you see what coming here into the CIMID, it's how we can do that. Also, we do this under well-controlled conditions, but also we have our component of participation research where there are several collaborators. They have been working for more than 10 years with us, researching from Michoacán. They research on how to implement conservation agriculture, how to use different fertilizers, which other crops can be planted, adapted to the farmers' conditions in Michoacán, because not everything that is done here in Texcoco can be applicable in other locations. We can think about ideas, but we don't have a universal recipe for every location. So we need to have research with an impact. Here at CIMID, we want to be impactful. It is not about doing a trial or research and write the papers. No, everything is part of the hub model where research takes place, but also we work in the field with partners with the extension modules. We work on agronomy, but also market access, post-harvest training, every component that is needed in order to have a sustainable agri-food system. That's why the name of our program today.
A lot
of the research projects that date back from decades are based on conventional agriculture. There were some issues because we have seen that they have focused on more tillage, more inputs, more production, leading to loss of organic matter, erosion, compacting. So we have assessed these practices and we have presented the option of conservation agriculture with minimum soil movement, canopy crops, diversification of crops to have regenerative, sustainable, and resilient practices. This is an example of our outcomes. This is the long
en San Luis Potosí.
term
Y
of
allá también lleva
the
ya más
trial in San Luis
casi 30
Potosí by
años
Dr.
con este
Miguel
ensayo,
Ángel. He's
donde
been
vemos a
working on
la
this essay for
derecha,
more than 30 years. To the right,
izquierda, para ustedes. Para
well,
mí es derecha, está
to my right, to
a la
your
derecha.
left.
Bueno,
Yes,
lo que está
sorry.
inundado,
Well,
este es el sistema convencional. Allá el suelo está
on
completamente degradado.
to
Y
the
cuando
right,
riega,
we have
dura
the
4 días,
completely
sí, para que
degraded
esta agua
soil
infiltre.
under
Sin mucha pérdida,
conventional
poca
practice.
eficiencia.
You can see it is
Mientras que al
flooded.
otro lado,
It
con
takes up to
agricultura y
4
conservación,
days to
un
sink
suelo con
in,
materia orgánica
while
no
on the
solo tiene
left
captura,
side,
el agua de
agriculture of
riego en 4 horas
conservation,
está
we have
infiltrado.
good organic matter, and in a matter of
Luego el
4
resultado es así, pues
hours,
el
the
maíz
water
desciende en el suelo
has
degradado,
filtrated. You
pues
can
no crece
see
muy bien.
here
Y
the
el maíz
corn
en el suelo
or the maize in the degraded
pues bien
soil
cuidado,
is not
regenerado,
growing
sí,
properly,
se
while
desarrolla
in the
bastante
other
bien.
soil it looks pretty
Lo
good.
mismo vemos también
And the
aquí
same happens here in this
Texcoco,
picture,
es una foto de
here in
2009,
Texcoco.
cuando Bram
This is a
todavía era
picture
el
from
responsable de
2009
este ensayo.
when Bram was
Allá
the
había una sequía muy
responsible
fuerte
person on this
y
trial. They
pues vemos que
went
en lo convencional pasa lo mismo.
under a
El agua
drought
no
period,
infiltra en el
and
suelo,
here on
el
the
suelo está
conventional
compactado, poco
agriculture
fértil, las plantas
picture,
no
we
crecen.
can
Mientras si
see
tenemos buenas
eroded
prácticas,
soil,
si podemos
very
con la misma
poor
lluvia, fertilización,
and
híbrido,
short
fecha de siembra,
plants,
tener
while
mucho
in the
mejor
other side we can
comportamiento de las
have a
plantas.
better behavior of the crop.
Antes solamente pusimos
And
esta foto de 2009 en la
this,
presentación, pero
the previous
desafortunadamente hoy
picture
en día
was
pues
from
cada año puedes sacar una
2009,
foto
but
similar.
every
Este
year we
año
could
está un
have
poco mejor,
similar
pero
images. This year
ya
was a little
casi
better,
cada año hay una diferencia
and
bastante fuerte entre lo
almost every
convencional
year there is
y
a
la
strong
agricultura de
difference
conservación.
between the conventional
22 también
agriculture
bastante
plot and
mal.
the
Y el año
conservation
pasado fue el
agriculture
peor año que hemos
2022,
tenido,
and last year
con los
has been the
600 kilos nada
worst
más que
year
cosechamos
we had,
en lo
with only
convencional contra los
harvesting
6 toneladas
600 kilograms in
que
the conventional
cosechamos
plot
con la agricultura de
versus
conservación.
6 tons in the plot
Eso también
with
lo vemos
conservation
en las gráficas
agriculture.
de los
This
datos a
can
largo
be
plazo. Los de arriba son de aquí en Texcoco,
observed
uno con
here
maíz,
in the
otro con
long-term
trigo,
trial
donde
here
en
in
verde vemos las
Texcoco,
líneas
one trial
de
with
los
wheat,
rendimientos de
another
agricultura
with
y conservación son siempre mayores
maize. We can see
que
in
los
green
azul, que es la
the
práctica
results
convencional,
with
pero especialmente en los años
conservation
con mucha
agriculture, and
sequía,
in
mucho
red
calor, es
conventional.
donde
In
vemos
those
varias
years with the
toneladas de
higher
diferencia.
temperatures and
A
drought
través nada
is where
más
we see this
cambiando el
huge
manejo de suelo.
difference of
No
tonnage.
estamos
This
haciendo
only
alguna
change
gran
in
inversión
soil
en
management
fertilizantes,
without
tecnología,
huge
híbridos.
investments of
Y sí vemos que
fertilizers,
sí es importante también
technology,
pensar
hybrids.
en
No,
semillas.
so it is
Si vemos los
important
resultados
always to
del
think
ensayo de San
about
Luis
seeds.
Potosí, allá
We
vemos que
have the
siempre ha
results
habido
of the
también
San Luis
un mayor
Potosi's
rendimiento.
trial. We
Las
know
líneas
there
en
is
verde también son
greater
siempre mayor que las
yields.
líneas azul, que
Green
son labranza
dots
convencional.
are
Pero cuando
greater
cambió
than blue. Blue
a
was
un híbrido de
conventional
mayor
tillage,
potencial de
but when
rendimiento,
they
allá también
change
vemos
to a
que
hybrid
se
of a
despega
higher
la
yield
diferencia en
potential,
rendimiento.
we can see a
No
huge
hay tiempo para
difference in
preguntas.
yield data. I'm sorry, we don't have, it is not the time for
Okay.
Q&A yet.
Bien, entonces
Okay,
no solamente es manejo de suelo, también
so
vemos
this
que
is not
tenemos que
only
necesitar
soil
buenos materiales
management. We know
adaptados a las
we need
condiciones
to
para
have
que
good
también puedan
materials
aprovechar ese
adapted to
potencial de
conditions
rendimiento.
so we can leverage on their
Aquí
yield
también en este ensayo
potential.
hicimos un
Here on this
análisis de suelo
trial,
y
we
vemos que no
conducted soil
solamente
analysis,
tenemos
and we
mayor
saw
rendimiento, también
that not
tenemos
only
mayor
we
captura de
have greater
carbono
yield,
en
but better carbon
en este ensayo con
sequestration
agricultura
on this
conservación.
trial with
Entonces estamos
conservation
teniendo
agriculture.
mejores rendimientos,
So
pero al
we
mismo
have
tiempo
better
estamos
yields, and at the
recarbonizando
same
el
time,
suelo.
we are recarbonizing the soil.
Entonces, pues, es un poco general que
So
hacemos.
this
Ahora
is
voy a dar algunos ejemplos
this
sobre
was
los
a
diferentes
general
indicadores que
presentation
hemos
on what we
trabajado
do, and
para ver qué
I will
podemos hacer en
share the
campo
different
sobre esto.
indicators that we have worked
Para empezar,
in our
con la materia
practices.
orgánica del
First,
suelo,
with
ah,
organic matter
hace
from the
algunos
soil
años
a few years
nos
ago.
sumamos a un proyecto de Soil Health
We
Institute y
contributed
la
to
idea
a
era saber,
project,
pues,
soil
cómo
health
podemos saber qué es el
measurements.
mejor
The
indicador de
idea
salud del
was
suelo.
to, how could
Porque hay
we
muchos
find the
diferentes
best
indicadores y si
indicator of
dejas los
soil
científicos del
health?
suelo, pues
There are
siguen
so
inventando
many
nuevos indicadores,
indicators
pero nosotros
because
los tenemos que
soil
medir en campo.
experts
Entonces,
continue
pues
to
tenemos que saber qué
research,
medir,
but
¿no?
we need to
Por
measure
eso, en
them on the
120
field. So we
ensayos
need
a largo
to
plazo,
know
como
what
los
we
que
measure.
presenté,
From
hicieron una evaluación
120
de más de
long-term
150
trials,
diferentes variables
there
de la
was
salud
the
del suelo para
assessment
ver
of
pues, cuáles son los
150
mejores a medir.
variables of health,
La conclusión no es tan
soil health,
sorprendente,
to
pero
understand
sí es
which
bueno
was
tener
better
el dato,
to measure.
es que la
The
materia orgánica es el mejor
conclusion
indicador
was not
de los suelos
surprising,
fértiles.
but we
De un
knew,
lado,
and the
porque
result
está
was
relacionado
that
con
it is
todos los
organic
aspectos del
matter
suelo, la
because it is
estructura,
related
la cantidad
to
de
every
nutrientes, la
aspect of the
disponibilidad de
soil
nutrientes,
structure,
cuánta agua puede
nutrients,
almacenar,
quantity,
la densidad
availability, how
aparente, la
much water
biología,
it
todo
can
está
store, apparent
relacionado con la
density,
materia orgánica.
biology,
Entonces,
everything
pues medir
related
materia
with
orgánica nos
organic
da una
matter.
idea
So when we
sobre todos estos
measure organic
aspectos.
matter, it gives
Pero
us an
también
idea on
la
those
materia
aspects,
orgánica,
but
como
also
vimos
organic
anteriormente,
matter,
es
as
también más
seen earlier,
susceptible
is
a manejo que
susceptible
otros aspectos del suelo.
for
No
management
vamos a cambiar la
practices than
textura
other
del suelo, por
aspects of
ejemplo,
the soil.
pero sí
Like the
vamos a
texture
cambiar
will
la
not
materia orgánica.
change, but we
Entonces, la
can
materia orgánica también
change
es un buen indicador
organic matter.
a
So
medir
it
para
is a
ver si
good
estamos
indicator
realmente
to
generando
measure
cambios.
to see if actually we are
Así que también
generating
lo
change.
medimos en la
So
red de
we
plataformas de
measure
investigación, estos ensayos
in the
participativos que
different
tenemos.
research
Estos son los
platforms in
resultados de
our
un estudio
participation trials that we
de
have. These
20
are the
diferentes sitios de
results
México, donde también
of
medimos cómo
a
cambió el suelo
study of 20
con
different
agricultura y
sites of
conservación, y vimos
Mexico
también
where we
un
studied
aumento en la
how
materia
soil
orgánica,
change with
mejora estabilidad de
conservation
los
agriculture.
agregados, mayor
We have
rendimiento,
better
pero también una gran variabilidad entre los diferentes lugares. Pues, no es un
variability between
secreto
different
que México es un
locations. It
país
is
muy
not a
variable,
secret that
con mucha
Mexico
diferencia
is a
entre los
variable
diferentes
country with a lot
estados,
of
regiones.
differences
Entonces,
between the different
aunque vemos algunos
regions in the
efectos
different
generales
states.
como
Although
aumento de
we saw
materia
some
orgánica, también vimos que hay
general
mucha
defects
diferencia
as the increase of
entre los
organic
diferentes
matter,
sitios.
we saw there is some difference on the
Así
different
que
sites.
necesitamos mejores mecanismos
And
para poder saber pues, qué va a pasar
we
con los
need
cultivos, qué
some
va a pasar
mechanisms
con
to
el suelo. Así
determine what
que
will happen with
entremos en
different
un proyecto
crops and
con la
different
empresa
soils.
Teradot
So
para
we
ver si los datos que acabo
participated
de
in a
presentar
project
los
with
podemos usar
Teradot's
para hacer
company
modelos de
to see if
cultivo
the data
que
can be
nos
used
van
to
a estimar cómo va a
work
crecer
on crop
nuestro
models
cultivo, pero
to
también cuánto captura de carbono
to
podemos tener.
estimate how much
Y en
growth
estas
there will
gráficas pues, se
be and
muestra
how
que
much
había una buena
carbon
correlación
can be
entre los
sequestrated.
datos de
We
rendimiento reportados en los
calculated a good
experimentos y lo que
correlation of
deberían
this
haber
data
rendido según
and
suelo, clima, híbrido,
between the
fertilización, etc.
forecasted
Pero aún
yield
mejor es
and
la
all the
correlación
different
entre lo que
conditions. But
medimos
even
en
better
campo, la materia
was the
orgánica,
correlation
creo que
of
los
organic
modelos
matter
basados en los
measures on
datos
field versus
pueden estimar.
database models.
Bien. No solo es carbono, también
So
pues,
it
son
is
todos
not
los gases de
only
efecto invernadero.
carbon, but
En la
all the
producción de granos, ¿de
greenhouse
dónde vienen
gases. For
esas
grain
emisiones?
production,
Básicamente,
where do these
muy
emissions
importante es la
stem from?
componente de los
Well,
fertilizantes. Óxido
fertilizers is a
nitroso,
good
liberado por
component.
los
Nitrous
nitrogenados,
oxide
pero también pues, pozos
liberated
de
by
energía
nitrogen
para
fertilizers,
producirlos.
but also
Esquemas de
the
rastrojos pueden
source
ser
of
una
energy
fuente
for
muy
their
importante de
production.
emisiones, así
Also,
como el uso de energía, el diésel para
when
hacer
they
labranza,
burn the
pero también
stubble,
cada
they
vez más el
also
agua
emit, but
subterránea
also
está más
energy
profundo,
juice, but
entonces cada vez más nos va a
underground
costar más
water is
energía de
deeper,
sacarla.
so it will
La
require more
pérdida de materia
energy to
orgánica
obtain
con la
it.
erosión,
Loss
la
of
labranza
organic
también pues,
matter with
genera
erosion and
emisiones de
tillage
CO2.
practices also
Los
leads to
plaguicidas, pues no tanto,
CO2
porque son muy
emissions.
pocas
Pesticides,
cantidades
not so much because
por
their
hectárea que se
quantities
aplican, entonces
per
no está
hectare
relacionado
are not
mucho con
large
emisiones
enough,
de
so
gases
they
de
are
efecto
not
invernadero.
directly
Y hay sumideros, hay
related
mitigación
to
posible, pues si
greenhouse
podemos
gases. There
aumentar
are some
la materia
sinks,
orgánica del suelo,
there
el
is
carbono en el suelo,
mitigation.
pues
We
podemos
could increase
reducirlo.
carbon
Y eso lo vimos
sequestration
aquí en el
in the
diapositiva,
soil.
son
This
los
was
resultados en el estudio del
observed
CIMBESTAF,
here
donde
from this
en la
SIMBESTAF
mayoría de los
study,
tratamientos
where most of the
encontraron más o menos 1,5
treatments
toneladas de emisiones de CO2,
found
pero donde
approximately
tenemos
with
agricultura y
1.5
conservación con
tons
alta
of
captura de
CO2.
carbono
But when
y
there is
allá
conservation agriculture, the carbon
medimos
sequestrated was higher, and we were able to measure
captura de carbono neto de 6
net
toneladas por hectárea
net
por año.
6 tons per hectare per year of
De igual
carbon
manera, hemos
sequestration.
trabajado
Also,
en
we
el
have
proyecto con Eugenio
worked
con medir cuánto agua
in a
podemos ahorrar.
project to
Vemos
measure
que con
how
agricultura
much water we
conservación
can save.
tenemos mejor
Along with
estructura de
Heineken,
suelo, tenemos
with
menos
conservation
evaporación, el suelo se
agriculture, we
seca
have
más
less
lento,
evaporation.
así que
The soil
medimos que
takes
podemos
longer
ahorrar
to
un
dry, so we
17%
measure that we can save
el uso de agua
up
con
to
agricultura de conservación.
17% of
Y si
water use
combinamos
with
eso con riego
conservation
por goteo, un
agriculture. And if
40%
we
de ahorros.
combine this with dripping
También eso lo
irrigation,
medimos no
we can
solamente
save
en
up
un
to
experimento
40%.
en la
This
Universidad de
was
Guanajuato, también
measured
lo
at an
medimos en
trial
campos de
with the
productores
University of
comparando cómo es la
Guanajuato,
agricultura,
also with
la
farmers.
labranza en camas permanentes,
Compare
son los
these
puntos
with
verdes y ya también
permanent
vimos el mismo
beds.
ahorro de
These
agua de
are the green dots,
17%.
and we
En términos de uso de
again
fertilizantes,
observe
allá buscamos
17% of
optimizar
water
el uso.
savings in
Sabemos que
terms
pues, necesitamos fertilizantes para
of
producir. No fertilizar,
fertilizers.
pues vas
We
a
research
rendir
this.
una
We need
tonelada nada más,
fertilizers to
pero eso no es
produce. Without
suficiente si queremos
fertilizers, we
alimentar al
can
mundo.
only
Así que
obtain 1 ton
trabajamos
per hectare,
primeramente
but
con el
this
enfoque
is not enough.
de
So
los 4
we
R's, la
work
fertilidad
with the
integral,
approach
el
of 4
fuente correcto,
areas:
en el dosis
the
correcto, en
right
el momento
source, the
correcto
right
y
rate,
aplicado
the
en el
right time,
momento
and the
correcto.
right
Y por
place.
eso hacemos investigación
That
y
is why
prácticas
we have research
dependiendo del
and
cultivo,
practices
del lugar,
depending
de las
on the crop,
posibilidades
the
que
location,
haya
and the
disponible.
different
En la
possibilities
gráfica ven una
available.
mapa que
In the
estaba
plot, you can
una
see
tecnología que hemos
a
hecho
map,
mucho con
and this is
en zonas donde los
a
productores no pueden pagar
technology
cada
that
uno
we
su análisis de
use
suelo, pero sí
where
podemos hacer
farmers cannot
varios
pay
análisis de
for
suelo,
their
así
soil
interpolar y
analysis,
tener una
but
idea de
we
qué es el
can
estatus
have
de nutrientes
fewer
de
samples
esta
and
región.
extrapolate the results in
En
order
esto,
to
pues,
map
en la
the whole
optimización de
region. With
fertilizantes,
this, with
importante de no
the
solamente pensar
optimization of
en el
fertilizers,
fertilizante
it is
mismo, pero en todo
important
el
not to
sistema.
think only
Esos
about
son
the
resultados de
fertilizer,
rendimientos de
but of
trigo
the whole
en
system.
el
These
Valle de
are
Yaqui, en
results for
Sonora, y
wheat
vemos
in
que
the
con la
Valle de
misma
Yaqui in
fertilización,
Sonora,
pero
and
diferente
we see
manejo,
that with the
diferente
same
rotación,
fertilization,
diferente
but different
irrigación,
management,
podemos tener
irrigation, and
rendimientos, varias
rotation, we
toneladas
could have
diferentes. Entonces,
several
usos de
tons
eficiencias en el uso
yields
del
with
nitrógeno
different
entre lo
efficiencies
mínimo era
on how we
50% y
use
el máximo
nitrogen. The minimum was
80% de
50%,
recuperación.
maximum was 80% recovery.
También trabajamos en
Also,
reducir el uso de
we work on trying to
agroquímicos.
reduce
Eso
the
no
use
solamente es
of
pensar en el
agrochemical
agroquímico,
products.
también es
This is
pensar
not
en
only
todo el
thinking
sistema.
about the
Son fotos de aquí
agrochemical product.
donde
We need to
a
think
un lado
system-wise.
tenemos
These are pictures
a la
on
derecha
one
para
side.
ustedes
To your right,
monocultivo de trigo
we
por
have
30 años. Allá,
single crop
pues,
wheat for 30
no hay
years.
buenos herbicidas para
There
controlar
are
los pastos
no
dentro del
good
trigo, y menos si
herbicides
haces un
to
monocultivo por
control
30 años. Mientras
grasses
que a la izquierda, con la
within
rotación, la cobertura,
the crop,
tenemos 90%
even if
menos
you have
malezas
been
con el
planting
mismo
that for
manejo
30
de
years. On the
herbicidas.
other side, we have with crop
Ahora, para
rotation, better
entender esto
weed
mejor, estamos
management with
trabajando en analizar los
a
datos que
lower use
tenemos
of
para saber
herbicides.
pues, qué son
Now
los
we are
principales
trying
plaguicidas,
to order
herbicidas,
and understand the
insecticidas,
data we
fungicidas que se están
have to
usando
learn
y
about
cuáles
the
son los más
best
tóxicos, usando el
pesticides,
indicador del
insecticides,
EIQ, que son
fungicides,
datos que
and
vamos a publicar
herbicides, thinking about
pronto.
which are the most toxic ones.
Que vemos,
This
pues,
is
que
yet to be
el EIQ nos
presented, this
ayuda
information.
a
The EIQ,
cuantificar pues, la
environmental
toxicidad
impact
de los diferentes
quotient,
plaguicidas.
help us
Vemos que el mayor
quantify and
impacto viene
compare
de
the
los
use of
herbicidas y
pesticides, which one
principalmente pues, los
has
viejos
greater
conocidos como la
impact.
atracina, el paraquat, el glifosato,
Atrazine,
mientras que el
paraquat, and
impacto
glyphosate, the older
de
ones, are the
insecticidas,
most
fungicidas,
impactful
mucho
of
menos,
these
especialmente pues, si
pesticides.
evitamos
Less
los más
impact from
viejos como
insecticide and
carbofuran,
fungicides if we
clorpirifos, esas cosas que ya no
prevent
se
using
deberían
the really
usar, ¿no?
older
También
ones
vemos
like
que hay bastante diferencia
carbofuran
entre las
and
diferentes partes
clorpyrifos,
del
and we
país
can see there are
o los
differences
diferentes
across
cultivos, ¿no?
the
El trigo y la
regions and
cebada
across
tienen mucho menor
crops in the
carga
country.
de plaguicidas
Wheat,
que, por
barley
ejemplo, el
have a
maíz y el sorgo,
lower
por las
burden
condiciones en
of
que se
pesticides
cultivan
than
principalmente.
corn or sorghum. This is because of production
Lo importante
characteristics.
en todo esto, pues
What
no
is
solamente
important across
enfocarse
all
en lo
this is
bueno para
not
el medio
only to
ambiente, porque al final
concentrate
quien lo tiene
on
que
what
hacer
is
son los
good for the
productores. Y
environment,
por
because
eso,
at the end of the day,
siempre en
farmers
la
have to do
investigación
this.
siempre buscamos tener un
So,
buen registro de
in
cuentas,
our
como lo hacen
research
en el FIRA también,
projects,
siempre saber pues cuánto ha costado
we
realmente
want to
estas
be
prácticas para obtener
accountable,
estos rendimientos,
trying to
para
calculate the
enfocarse en la
cost of these
utilidad neta
practices
más que en
trying to make a focus on
Vemos
net
la relación
profitability.
aquí entre
We
los costos
can
de
see
producción
the
y de
relationship
rendimiento
between
en
production
nuestros
cost and
plataformas de
yields
investigación.
in
Sí
our
vemos un
research
aumento de
platforms.
rendimiento con mayor
And
inversión,
we can see
pero si
that there is
vemos
better
la
yields with
rentabilidad, la
more
utilidad
investment.
neta
But
en
if we
relación al costo de
see
producción, pues ya no hay
net
una relación,
profitability
porque no
versus
solamente depende
production
de la
cost, there is
inversión,
no
también depende
relationship
mucho del
because
manejo de
this
las
is
cosas
not
que no
relying
cuestan
only
dinero,
on
pero sí
investment,
tienen un
also
gran
on the
impacto. Por
management
ejemplo,
that are impactful and do
cuánto
not
agua
cost a
puedes
lot of
almacenar
money,
en tu
like
suelo,
how
por
much
ejemplo.
water can your soil store.
Pues ya no hay mucho tiempo. Voy un
And
poco
I
más,
know I
más
am
allá.
running out of
Diversificación.
time. I'd like to skip
Allá hemos
some
trabajado
files.
mucho
For crop
con la
diversification, we
rotación de
have
cultivos,
worked
por
here
ejemplo, y aquí
with
en
crop
estas gráficas vemos que
rotation.
sí, la rotación de
And
cultivos nos
here on
aumenta de
these
rendimiento,
plots, we can see
pero el
that crop
problema luego es
rotation
pues,
increases
el
yield.
mercado.
But then the issue
Necesitas
is the
tener
market
cultivos de
conditions.
rotación
You need to
que sí se
have
pueden vender, que son
rotation
lo mismo
crops
de
that
rentable que
have
el
a
cultivo
good
principal, el
value in
maíz
the
o el
market
trigo,
that the
y
main
eso
crop
siempre ha
like
sido
wheat or
el reto.
maize, and this has always been
Entonces
a
también
challenge.
hemos estudiado
So
biodiversidad de
we
otra manera,
also have
con los
studied
bordes de flores que ya
biodiversity
mencionaron en la mañana,
from a
donde
different approach,
medimos el
like
efecto
these
de bordes de
bands of
flores,
flowers where we measure
pues
their
cuánto insectos
effect,
había, cuánta
how
diversidad de
many
insectos
insects
había.
there were, how was the insect
La línea roja
biodiversity there.
nos,
The red
nos
line
muestra pues cuántos
shows
insectos
us
había
how
en el
much
borde y los
many
otros dentro del
insects
campo
were
a
there
ciertas
in
distancias.
the
Vimos que hasta
outer
20 metros de distancia sí entraban
bands of
bastante
the
los
crop.
insectos,
We could see
pero no es
that
suficiente
they were
para no
introducing
tener
more or
que
less
aplicar
20 meters,
plaguicidas.
but they weren't enough
También
in order
aprendimos que
to
estudiar biodiversidad
justify the
es bastante
pesticide.
laborioso. Si tienes
Also,
que
we
capturar y
found out
contar
that trying to
pues, varios
be
millones de insectos, eso sí,
trying to
es
increase
mucho trabajo. Entonces, como
biodiversity, it
indicador
represents a lot of work.
ampliamente usable en
So
proyectos
as
con
an
productores, probablemente pues,
indicator
no es
to be
tan
used in projects
aplicable,
with
pero
farmers,
sí fue
perhaps
bastante
it
interesante.
is not applicable.
Bien, entonces,
So
¿cómo lo llevamos a escala? Pues
how can
tenemos un
we
base
scale up?
científico de
We
la
have a
agricultura regenerativa, pero lo que
scientific
necesitamos
base
es
for
tenerlo a gran escala,
agriculture,
¿no? Que los
but we need
productores
to
sí
scale
lo
it
adopten.
up so farmers will
Por eso,
adopt
pues,
this.
trabajamos con
That is
nuestro
why we
modelo del hub,
work
donde
with
no
our hub
solamente pues,
model,
son científicos
where
diciendo
not
qué hay que
only
hacer,
we are
estamos
scientists
trabajando con
telling
todos, con
them
los
what to
técnicos,
do,
con
we
los
work along with
agroempresas, con los compradores de
technicians,
grano,
with
con otros
agribusinesses,
institutos, con
with
el
grain
gobierno, con
buyers, with other
FIRA, con
institutions,
todos, para
with
hacer un
governments,
equipo,
like with
para no
FIDA,
solamente tener
to
la
conform
investigación,
a
la
team.
demostración en
So
campo,
not
pero
only
también
we
hacer,
will have the research
generar ese sistema
findings,
donde las
field
prácticas
trials, but
sustentables
also a
sí
good
se
system
promuevan y sí se
to
adopten.
promote
Con los
adoption
números,
of
ya
sustainable
llegamos a
practices.
más de 1
The
millón de hectáreas de
figures, we
adopción,
have reached more
trabajando
than
con
1 million
cientos de
hectares
socios y
of adoptions,
colaboradores. Entonces,
working
sí
with
se puede hacer.
hundreds of partners
Sí,
and
los
collaborators.
productores
So yes,
están
it can be
dispuestos a
done.
cambiar sus prácticas si
Farmers
están
are willing to
acompañados bien
change their
con un
practices
sistema que
if
les
they
apoya, que
are
les da acompañamiento
supported by a
técnico, que les da
system that will
datos,
bring them
resultados, ideas
technical
de qué se podría
accompaniment,
hacer
data,
en sus
ideas,
propias
advice
condiciones.
on what they can do in their own
Una manera
conditions.
importante en cómo
Something
podemos llevar esto a gran
important on
escala es
how we
trabajar
can
con
scale
los
this
grandes
up
empresas, los
is
que
to
sí
work with
compran
large companies.
los
Those
granos,
that
pues también pueden
buy
tener su
grains
impacto en
also
cómo
could
se produce
have
el
an
grano.
impact on how
Estos
grain is
proyectos
grown.
trabajamos mucho
From these
en la reducción de
projects, we
emisiones,
work
en la reducción de uso de
in
agua, optimizar fertilizantes,
detection of emissions,
básicamente
water use,
transición hacia
optimize
prácticas sustentables.
fertilizers with a
Y hasta la
transition
fecha hemos trabajado
towards
con estos proyectos
sustainable
en más de 80
practices.
mil
And to
hectáreas,
date, we
más de
have worked
600
with these
mil
projects in
toneladas de
more than
maíz, 200 mil de trigo, 25
80,000
mil de cebada.
hectares and in different
Viendo
crops like
esto
corn,
como un
barley, and
modelo que
wheat.
podría
This is a
implementarse
model that
aún más
could be
ampliamente para
increased
escalar la
broadly
agricultura
to
regenerativa
scale up
por todo el país.
regenerative agriculture across the country.
En todo eso trabajo
Across
en
this
campo con los
work
productores,
with
no nada más estamos
farmers,
promoviendo
not
prácticas,
only
también
are we
estamos generando
promoting
datos.
practices,
El
we
CIMID
also
es un
are
instituto de
generating
investigación
data.
en
CIMIT
fondo,
is a
entonces
research
no podemos nada más tener
institution,
opiniones, necesitamos
so
basar todo lo que hacemos, lo que
we need to
recomendamos
base
en datos. Por
everything
eso
that we
tenemos un
do and we
sistema
say on
se llama
data. That
e-agrology,
is
donde
why we
capturamos
have a
datos,
system,
todos los datos de
e-agrology.
manejo
We
de los parcelos
capture
en que trabajamos,
data,
para luego poder
plots
sacar esos
management in order to
conclusiones y
Fonteyne, data that will lead us to
Esos,
conclusion
también
that
esos
will
datos
lead
los
to
vamos a
greater
publicar
impact.
todos,
This
estos 12
data
años de
will
datos
be published. We have
agronómicos de
12
todo el país,
years
por
of
si alguien los
agronomical
quiere analizar.
data for the country. If
Algunos
someone
resultados aquí,
is interested in
lo
the
que vimos
analysis, some
en
of the
la
results are
gráfica
here.
derecha, que sí,
To your
luego
right,
hacer innovaciones puede costar más.
it
Pero
shows
a la
that
izquierda
to be
vemos que sí,
innovative, it can cost
tener
more, but to
agricultura
your right,
regenerativa
it
sí es
says
más
that
rentable.
regenerative agriculture
Entonces, más o
increases
menos
your
un
profit. So
2,000,
more
unos
or
100 dólares,
less,
2,000 pesos, 100 dólares, más rentable
$100 or
las prácticas de
2,000
innovación
pesos.
que la
Innovation
práctica
practices
convencional
are
a
more
lo largo
profitable
de todos
than
estos años.
conventional practices across all this number of
También podemos
years.
usar esos datos
We can
para
also
generar
use this data
recomendaciones
to
para los productores.
issue
Esos son resultados de
recommendations
uno de
to
los
farmers.
análisis iniciales
This
que
is
hicimos,
one of
donde
the
teníamos todos los
initial
datos de Chiapas
analyses where we
y
have all
pues
the
los
data from
requerimos modelos
Chiapas,
estadísticos para
and we
saber
ran
qué son los
statistical
factores que
models
tienen
to
más impacto
learn
con
about which
el
are the
rendimiento.
factors that
Primero
impact
fue
most
variedad, pues no es
performance.
tan sorprendente,
First, it was
menos en Chiapas donde hay
variety.
sistemas
It
con
was not
maíces
surprising, let
criollos y hay
alone in
sistemas con
Chiapas,
maíces
where they
híbridos, entonces
have
muy
systems with land
importante
races or hybrid
la variedad,
mazes.
pero
So
luego
variety, it's
unas
important. And
variables del
then
clima,
other
en quinto lugar,
variables
la
like
materia
weather, but
orgánica.
in fifth
Entonces,
position,
la materia orgánica en
organic
el suelo
matter.
era uno de
So
los componentes que tenía
organic
mayor
matter in the
relación
soil
con
was
el
one of the
rendimiento.
components that had a higher relationship
También
with
esos datos los
yield.
podemos usar para
Also, this data
estimar
can be
a gran
used to
escala las
calculate
emisiones de la
a
agricultura.
greater scale agriculture
Tenemos los datos de
emissions.
manejo y
We
pues como
have
tenemos fertilización,
management
labranza,
data,
riego,
we have
pues podemos calcular
regeneration,
cuántas emisiones
tillage,
ha habido.
irrigation,
Es
so
un
we can
cálculo que hicimos
calculate
con el
past
CCAP-SMOD, funciona
emissions.
más o menos
This
lo mismo
was
como el Q for el
data
Q, solo
generated
que pues
with
tenemos el código y lo
CCAP's
podemos
mods,
hacer
and
a
we
gran
have the
escala con
code,
todas
and we
nuestras
can
bitácoras.
scale this up
Y
based
vemos
in all
allá
of
lo
our
mismo que
data logs.
fertilización, uso de
And
energía,
we
manejo de
also learned
residuos
that
son los
fertilization,
principales
energy
fuentes
use,
de
these were the
emisiones,
main sources for
pero que también
emissions,
a nivel
but
campo esos
also
modelos estiman aquí
these
para Bajío
models at
que
field level are
las emisiones
calculated for the
negativas son
Bajío
posibles
that negative
en ciertas
emissions
regiones del
are
país
possible in some regions
en la
of the country
producción de maíz y
in
trigo.
corn and wheat production.
Pero bien, es un modelo un
So
poco general,
this is a
un
kind of
modelo basado
general
en
model
datos de la IPCC,
database.
entonces para todo el mundo no son tan precisos y
So
necesitamos
these
trabajar
are
en
not
sistemas que
really
son más precisos para que
accurate, so
podamos
we need to
a lo
work
largo de
on
nuestros
more
proyectos
accurate
estimar muy bien
systems so
los
we can
impactos.
have
Ya vimos en este
more
proyecto con
accurate
Moderador que sí podemos usar
estimation
los datos
of
que
our
tenemos
projects.
para
With
calibrar
Moderador,
modelos
we
de
can use
cultivo
these
que nos
models to
pueden estimar
calibrate crop models that
captura de
can
carbono, crecimiento de
estimate
cultivos.
carbon
Si juntamos eso
sequestration,
con las bitácoras
crops
que tenemos de
growth, and
manejo,
if we
pues podemos estimar todas las emisiones, la
use
captura de
these
carbono
along
y
with our
también
data logs, we can predict
estimar otros
carbon
indicadores de la
sequestration
agricultura
and
regenerativa
estimate
y así a
other
gran escala tener una
indicators for
idea
regenerative
pues,
agriculture so
si
we
estamos
can have a
realmente
better
haciendo
idea
regeneración, si estamos realmente
to answer
recarbonizando
the
el suelo.
question if we are
Por
actually
eso, el reto luego es quién va a
regenerating
capturar los
soil.
datos.
So the
No podemos
challenge
pensar que
is
vamos a mandar
how to
técnicos
capture
a
this
capturar
data.
todos
We
los datos de
cannot think
todos los
about sending
productores.
a
Entonces,
crew of
lo que
technicians
deberíamos
to
también
capture
hacer
all
es
this
pensar en
data
los
with all the
productores.
farmers.
Los
So
productores
we should
podrían capturar
also
esos
think
datos, pero
about
solo
farmers.
si
They
eso
could
le daría
log
un
this
beneficio.
data, but
Por eso
only
que
if
pues,
this
con
will
Diego Pequeño
benefit
estamos
them.
pensando en usar
So
también esos
we are
modelos, no
thinking
solamente
about
para
using these models, not
calcular
only
captura de
to
carbono, pero
calculate
también
carbon
luego lo podemos
sequestration,
usar
but
para generar
also
recomendaciones
we
a
could
los
use it
productores
to
de
issue
cuándo sembrar, cuánto
recommendations on
sembrar, qué
farmers on
sembrar, cuánto
when
fertilizar para
to
optimizar su
plan,
uso de
how to
insumos
plan, how
y
much
también
fertilizer,
su
how to
rentabilidad
calculate their
y sus
inputs,
emisiones.
their profitability, and their emissions
Con eso
also.
me han dicho que pues, ya
And
estoy
I am told
al final
that
de mi tiempo.
I
Entonces, en
ran out
conclusión,
of time, so this is
agricultura
all I have to
regenerativa
present.
busca
But to
fomentar
conclude,
una
I want to say
agricultura
that
que en vez de
regenerative
tener
agriculture
impactos
wants to
negativos,
promote an
tiene
agriculture
impactos netos
with
positivos en la planeta.
net positive
Así,
impacts for our
mediante la
planet.
investigación
It is
agronómica
through
adaptada a las
localized
condiciones locales,
agronomical
sí es posible
research
de generar
adapted to
estos
local
sistemas de
conditions.
producción
It is
que
possible to
mejoran
have
al
these
suelo,
production
reducir
systems that
emisiones. Ahora
will
en agua, pues
improve the
tenemos
soil, will
ejemplos,
have reduced emissions, save
muchos
water,
ejemplos de que
and
sí
we
se
have
puede hacer.
several examples that this can be done. And to
metodología eficiente de
do this, we
evaluar los
must
productos y
develop an
también poder medir,
efficient
estimar
method to
y
measure,
incentivar agricultura
estimate, and
regenerativa.
incentivize regenerative
Con
agricultural
eso, pues,
practices.
muchas gracias por su
With that,
interés.
thank you
Si
so much
tienen
for your
más dudas,
attention.
preguntas, aquí
If you
está
have
mis datos de
questions,
contacto
this is my
y
contact
pues siempre todos
information,
los datos que tenemos, la información que
and
generamos
all
es
this
abierto,
data
entonces,
are
para
open
ustedes para
for you,
revisar más. Muchas
for
gracias.
you to further investigate on this. Thank you very much.
Bom, muchas gracias por la distinta presentación, Dr. Simon Fonteyne.
So thank you so
Nosotros
much for
recordamos que
this
tenemos al
excellent
final
presentation,
de este bloque vamos a tener
Dr.
una sesión de
Simon.
preguntas y respuestas.
After this session, these sessions we will have Q&A time. So, with no further ado, I will open up the first conversatory for today. The title is Scientific Evidences of Carbon Capture Benefits in Agricultural Soils.
La presentación de distintos presentadores.
We will hear different presentations from different scientists.
Vamos tener la presencia de três investigadores.
We'll have three researchers. Dr. Blanca Prado, she will begin. She is the coordinator to the university program of interdisciplinary soil studies at UNAM.
Aqui adelante.
I will invite Dr. Prado to come to the stage.
Les estamos llevando ya una silla adicional. Adelante.
Yes, please. Go ahead, take a seat. We'll place a chair for you in a minute. Dr. Blanca Prado is member of the work task Soil and Environment at UNAM University. They assess water movement through porous means with a special interest in the structure and soil porosity analysis with two approaches: soil as a regulator of the hydrological cycle and soil as a buffer for pollutants. She also participates in courses at the bachelor's and graduate studies on soil physics, theory of underground flow, soil science, organic geochemistry, and the course of environmental monitoring at field level. Dr. Blanca Prado has a PhD in hydrology at Université Joseph Fourier, as well as a Master in Science with a specialty in environmental engineering at the Technological Institute of Higher Education of Monterrey. I'll give the floor to Dr. Blanca Prado.
Sí, bueno, muy buenos días.
Good morning, and before I begin, I would like to thank you for this invitation. Thank you so much for the introduction. I would like to add that I am a coordinator at COIV, and that's why they invited me today. I'm a scientist, and I am coordinating a program that I will talk about this morning.
¿Hacia dónde disparo? Hacia allá. Ok, entonces en esta pequeña charla voy a abordar tres temas que son los que ven en
pantalla. I will deal with three subjects. You can see them in the screen. The first topic talks about sustainable agri-food systems, importance. Our last speaker talked about it quite comprehensively. He did it very well. Then I'll talk about sustainable management and recarbonization of agricultural soils, where I will talk about the strategies of PUEIS, the program that I'm working with in order to provide scientific evidence of the importance of recarbonization. Let's begin by remembering that agri-food systems have three impacts: social, economic, and environmental ones. And one is more important than another depending on each specific local context. Now, what we are seeking for is a convergence point among the three sectors in order to have inclusive growth, green growth, eco-social benefits in that growth. And it's important to consider these three systems in order to amend the agri-food systems in order to turn them more productive, to be more inclusive. We will include the underserved populations, and the systems should be sustainable at an environmental level. You know, it sounds easy, but it's not easy at all. Talking about recarbonization, we have to understand that in a very simple way. The fact is that the soil has to have carbon. It's important because carbon at the soil and all micronutrients at the soil are important in order to have good production in the field. The crops need the necessary nutrients. So, as member of the Academy, we have to understand the carbon cycle in this continuum of plant, soil, and microorganisms. This is key to agri-food sustainability. Talking about sustainable management and soil diversity, which is a challenge nowadays, we have to remember that in Mexico we are very rich in terms of soil diversity, and the map, each color represents a different type of soils. We have 25 out of the 32 soil units proposed by WRB, and those of us who are living here know that each soil has its own characteristics, which give them specific abilities to fulfill the different functions. Such functions are, for instance, the means in which plants grow, to be the habitat of a fourth of the planet's biodiversity, to capture carbon, which is what we're talking about, to sequester air carbon, and to regulate the biological cycle, among other functions. And in Mexico, only 10% of our soils are agricultural land. Over 50% of our soils are quite shallow by their nature, that is, they are susceptible to erosion. That's what we have to work with. And so that soil distribution in our country, made out of sustainable management and soil recarbonization, important, and they require strategies which have to be tailor-made per region. There is no single answer. In natural systems, input and output of carbon is found at balance. Each system has its own storage capacity. What happens in agricultural soils which are managed by men? They change. Sometimes we can sequester more carbon, or to keep it, or to lose carbon, as we heard a while ago. So climate change and agriculture are connected. Recarbonization is key to produce, but we also have to adapt to climate change. It's not easy, as we have heard several times already this morning, but being positive, we are at the right time because we have the proper political environment to work in this regard. In this slide, I'm showing you several examples. We have obviously sustainable growth goals, targets which are very important, Paris, Covenant, and other examples.
De esto que acabo de hablar y de lo que nos han hablado esta mañana,
what I have just to mention that what we have heard of this morning is based upon information that comes from research centers and universities. At PUEI's project, we want to take the scientific evidence of the benefits of carbon sequestration to the different stakeholder sectors, government and society. I'll talk about some work strategies that we are following in order to achieve this goal. But before that, I'll talk about PUEI's. PUEI's is the interdisciplinary studies at UNAM, and UNAM includes soil within its priority agenda, and we prepared a program, and our purpose is to promote the interaction among different stakeholders, the academy, government, society, natural, social, and biological sciences, in order to deal with soil problems at the university. But we also work outside the university premises, and we want to promote the work of different stakeholders, governments and society, so that together with the academia, we will give positive impact, we will make positive impact in our soils. How do we do it in terms of recarbonization? I will explain. At Puey's, what we did 3 years ago, more or less, was to prepare a catalog of these projects dealing with soils at the university. These are some examples. For carbon capture, we have 7 large projects already registered, working at 4 different states where UNAM works. At Puey, we also have a program called Attention to Priority Subjects of Soils in Mexico. Within this project, this umbrella project, we have soil recarbonization as an additional project. We do different works with it. In here, I'm showing 2 posters for round table works. We invite members of the academia, the government, and the society in order to establish a dialogue about realistic, promissory possibilities to recarbonize Mexico's soils. This is what Simon said. It's not what you are thinking of from your lab, but really to assess the reality of our country. And we have also given talks about the relationship of soil, climate change, and of course, where recarbonization plays an important role. We also work along with the GIZ, and these are 2 events that we held. One was called Introduction to the Price Instruments of Carbon in Mexico. The second was the National Dialogue Forum, the second one on the borderline adjustment mechanism for carbon. These 2 events were held this year. At Puey, we have a permanent seminar on the processes of social transformation of soil. And one of these seminars talked about food security and soil use change at field level. Puey is among the leaders that are preparing the biodiversity atlas of soils in Mexico. We don't have this biodiversity atlas yet. We're working on it. And one of the main purposes is to provide accurate information on the soil biodiversity to decision makers, promoting friendly soil management practices, understanding that we need a soil that is alive for recarbonization and production purposes. We are also working on a nutrient soil map in Mexico, a repository that will be of free access so that we can prepare different materials, educational materials, basically, like, for instance, these nutrient maps in Mexico. Linking this project with the global FAO nutrient soil program. Puey is also leading a global program of soil doctors from the World Alliance for the Soil from FAO in order to prepare growers with practices for sustainable management, working together, farmers with farmers. And this is a theoretical and practical workshop, a picture working directly with the workers, and this is a recarbonization module. This program has several modules. One is dealing precisely with recarbonization. We do it together with our hosts, with CIMMYT, and with the Ministry of Agriculture. And the idea is to implement this project in Mexico, and those growers participating that are called soil doctors are well trained in this module. We have soil doctors all over the country. This program is very important. It's very interesting because remember that we have to prepare solutions, tailor-made solutions per every region in Mexico. This is another project in which we have lots of collaborators. Look at them. Of course, ICA is here. 3 different levels of government, social and private entities, as well as the academia. We also work in terms of food and energy security. At the inaugural ceremony, ICA's director talked about a little bit about these projects. At PUEI, we're working along with an international consortium on developing a methodology to monitor soil quality with energy sectors, with voltaic energy, with battery energy in Mexico. This is a joint project with the entities that we have in the screen. And we're also working in terms of soil governance in Mexico. As we said, decision makers need to know what is being cooked at the academic level. We do it through ENASAS, which is the National Strategy for Soil and Sustainable Development. And we are coordinating a subcommittee of this committee, UNESA, and all the participants are shown here. That's why I was invited to this forum. We have been working and attaining great results. PUEI is also holding a World Soils Day. Thank you.
Pues antes de que el doctor Pequeno siga presentándoles a los
Before
demás
Dr.
panelistas,
Pequeno introduces the rest of our panel members, please, the doctor, stay there. Dr. Prado, stay there. Before we introduce the other 2 panel members who are connected through internet with us, I would like to remind you that there are very few questions that we will be able to take. But anyway, write them down as you are listening to our speakers. Also, for those of you who are connected, write down your questions at the chat. And please address directly your question to one speaker in particular. Now we will switch into English. However, the audio will be in Spanish. You will have to wear headsets if you want to listen to the English. Okay, so thank you so very much. Now we will hear the second presentation of this first conversatory. We will get Tek Sapkota, a senior scientist of sustainable agri-food systems and climate change at CIMMYT. Dr. Tek Sapkota leads a science group for climate change within the program of sustainable agri-food systems, SAS, at CIMMYT, and he works at CIMMYT's headquarters in Mexico. He conducts research work in the area of agricultural systems, soil science, and environmental science. He is particularly involved in the study of the outcomes of agri-system management in terms of the nutrient dynamic and their effects on food security, adaptation to climate change, and mitigation of those effects. He is member of the Committee for Climate Investment of CGIAR, and he has worked at IPCC as the main author and editor. He is attached editor to the magazine's Nature Scientific Report on Frontiers on Sustainable Food Systems. He is an agricultural expert in the GEI platform for greenhouse gas effect. Greenhouse gases in India. Thank you. Dr. Tek Sapkota, you're already online, right? And he will be giving this presentation in English. Thank you. Muchas gracias, Diego. ¿Me escuchan bien? ¿Sí me escuchan?
Yes, we can hear you.
Okay, so let me share my screen and can you see my screen?
Sí. Sí, ya podemos ver la pantalla.
Okay, great. Okay, thank you very much. Good morning over there and good afternoon, good evening for the people online. And thank you for the introduction and for inviting me to give this this presentation. So as Diego said that I work in Summit, but unfortunately I'm not in Mexico today and I had to give this presentation virtually. And sorry that my Spanish is not that good, so I had to make this presentation in English. So the focus of my talk today is again on the scientific evidence of the benefit of carbon capture in agricultural soil. I'll try to speak as slowly as possible for people to capture what I'm trying to say. So let me start my presentation by highlighting the global challenges of food system under climate crisis. So the challenge we have today is how to keep within 1.2 to 2 degrees centigrade as set out in Paris Agreement without compromising food and nutrition security of most vulnerable producers and consumers. While urgent actions are required to make our farms, landscape, and overall food value chain climate resilient, we should also understand that without a significant emission reduction across the agriculture and agri-food systems, international climate targets such as Paris Agreement cannot be met. So therefore, we should plan to reduce greenhouse gas emission and mitigate climate change across the food system. When it comes to mitigating climate change across the food system, we can do that mainly following the three major ways. One is by reducing the greenhouse gas emission by implementing various practices that cut down the greenhouse gas emission, such as, precision nutrient management, precision water management, diet management in livestock, etc., etc. By avoiding the greenhouse gas emission, for example, by reducing deforestation induced by agriculture, or by reducing the use of agrochemicals, and by sequestering carbon in soil. That is the topic that we are going to talk about. So by definition, when we are talking about carbon sequestration, so it is a process of transforming atmospheric carbon into soil. And by doing that, it not only provides the climate mitigation benefit, it also provides many other environmental and agronomic benefits, such as improving soil fertility, increasing crop yield, contributing to biodiversity, and so and so. When we are talking about carbon sequestration or capturing the carbon from atmospheric pool to the terrestrial pool, so this is the pool that we are talking about. So the major portion of the carbon is situated in the deep ocean, which doesn't change that much. So the soil and terrestrial system contains about 3 times more carbon than the atmospheric. So these are the carbon that we are talking about. So it is possible to reduce this or mitigate or transfer some of this atmospheric carbon to the soil by means of carbon sequestration that we are going to talk about. This figure is to highlight that carbon sequestration is not always equal to the carbon loss minimization due to implementation of certain practice, for example. If you look at the figure on the very top left, where there is no carbon change under business as usual scenarios, this is a steady state scenario. So in this kind of scenario that, the difference in carbon stock due to implementation of the measures is equal to carbon sequestration. Whereas if you look at the bottom left figure here, that carbon sequestration is not happening even in business as usual scenario, as well as even with the implementation of measures. So there is carbon loss minimization you can see the difference between the scenario where the measures were implemented and where the business as usual is. But in both cases, there is carbon loss. But there is carbon loss minimization due to implementation of the measure, but carbon sequestration is not happening. And similar is the concept you can see on figure B and D, top right and bottom right there. I'm not going to go in detail, but just to highlight that carbon sequestration is not always equal to carbon loss minimization, or vice versa. When we are talking about the agricultural practices to enhance carbon sequestration, so they can be, these are the, some of the examples. For example, avoiding, reducing, or reversing deforestation, land degradation, or desertification, implementation of conservation agriculture, applying cover crops, retention and recycling of crop residues, use of perennial crops and agroforestry system, and use of organic manures and compost into the production system. These are some of the examples that I'm going to give some scientific evidence of how these practices are going to sequester carbon and also provide other benefits in agri-food system. So deforestation, land degradation, and desertification can be achieved or can be avoided or reduced by conserving high carbon ecosystems such as peatland, wetland, rangeland, or mangroves. Similarly, agroforestry and silvopastoral system can reduce the need of pasture expansion, slowing down the deforestation rate. Other landscape approaches for enhancing carbon sequestration include restoration of degraded land, ecosystem restoration programs, and afforestation. So these programs, some of these examples, they not only provide carbon sequestration benefit, they also provide other benefits to the farmers, such as income diversification, enhancing soil fertility, and subsequently enhancing crop production, etc., etc. And these are some of the examples based on the publication, how to increase or reduce the carbon loss by means of reducing deforestation, reducing the use of deep peatland, or installing methane capture into the processing mills. We all know the problem associated with soil tillage and disturbance. It not only disturbs the soil and enhances respiration-induced carbon dioxide emission, but it also leads to various soil erosion, degradation of soil quality, and loss of soil organic carbon through erosion and other means. So to minimize that, various approaches have been developed, and one of them is conservation agriculture, which is based on the principle of minimum soil disturbance or reduced tillage or no tillage, permanent soil cover, and appropriate crop rotation that can be applied both on the large-scale farming condition as well as small-scale farming condition. As you can see here, some of the pictures where there are also methods to do conservation agriculture following handheld methods or even animal-driven methods, for example. So in this graph, for example, I'm trying to see how carbon sequestration has been achieved in CA over city system in a long-term trial in India. So in this case, for example, rice wood production system under jetty and permanent bed increases the carbon sequestration over conventional system, specifically over on the topsoil layer, as you can see from the right lines over here, for example. So carbon content was much more higher under conservation agriculture, zero tillage and permanent bed system with residue retention as compared to the conventional system, or even zero tillage without residue retention. So this one here, you can see the carbon sequestration benefit of conservation agriculture over a conventional system based on the long-term trial in Mexico, for example. These two figures over here, whereas the figure on the right shows that carbon conservation agriculture increases the crop yield, increases water use efficiency, and increases net return to the farmers as compared to conventional system based on the recent meta-analysis from South Asia. So here you can see that CA system increases the water productivity. So what that means is it conserves the moisture and it can produce the same level of yield even with less amount of water. At the same time, this figure shows that CA can also help adapting to the excess moisture condition because it has a better percolation system and it drains the water through the soil system easily without causing any erosion. So use of cover crops is another way of adding organic matter, which decomposes to enhance soil organic matter level. And it also enhances, it also ensures that the soil is covered year round. That will minimize the loss of carbon and through erosion and other means. At the same time, some of the cover crops, they can kind of capture the nutrients that would otherwise lost into the environment, and then it will make available for the subsequent crop that is grown in that field. So the figure here on the right is carbon stock, increase in the carbon stock due to use of cover crop as compared to no cover crop. So if you in two locations, so you can compare the carbon stock in no cover crop as compared to other treatment here with the cover crop with oat, oilseed radish plus rice or cereal rye, for example. Perennial crops and agroforestry, they help carbon sequestration by means of their deep root system. They can transfer the atmospheric carbon through deep into the soil and store there into the soil, and that is also a kind of an effective mechanism to increase soil organic carbon into in the degraded and marginal soil. And agroforestry can also provide various other income to the other income opportunity for farmer, as well as increase the biodiversity. So here are some of the examples of the scientific publications showing how agroforestry enhances biodiversity, sequesters carbon, and also improves the soil fertility and provides additional income to farmers, for example. In this slide, it shows how addition of manure and compost can contribute to soil organic carbon sequestration by directly adding organic matter into the soil. It also improves soil fertility and it increases the biomass production, and that will in turn increases the carbon sequestration by means of its root and biomass addition into the soil. And on the figure on the right, you can see how much annual net global warming potential can be reduced by addition of manure and compost system as compared to the addition of synthetic fertilizer. In this example, you can see how the retention of the crop residues into the system rather than taking off the field will increase the carbon sequestration as well as various other benefit in rice wheat system in India. And the figure on the right are the various technologies that are available in order to manage those residues in situ instead of burning. And this is the paper published in Science. So with that, I would like to end my presentation, and I'll take the questions if there are any. Thank you very much. Over to you.
Muchas gracias, el Dr. Tek Sapkota.
Thank you very much, Dr. Tek Sapkota, for your excellent presentation. At the end of this block, we will have a Q&A session, okay? So I'll go directly to our next speaker, Dr. Natalia Rodríguez Eugenio. She is Global Coordinator to Red Soil from FAO. Dr. Natalia Rodríguez Eugenio is a biologist and a soil scientist with over 16 years of experience in soil chemistry, sustainable soil management, and soil contamination. Currently, she is the officer to land and water at FAO. She concentrates a great deal of her efforts in strategic planning and soil integration in multiple areas related to natural resources resources management, climate change, the initiative One Health, biodiversity management, and empowerment of small landholders and underserved groups, including women and youth. Besides, she manages different projects related to soil, and she fosters the adoption of sustainable practices in order to reach the targets of the 2030 Agenda for Sustainable Development. She has a master's in sustainable management and soil protection, as well as a PhD in soil science. She became part of FAO in 2017 as part of the Secretary of the World Alliance for the Soil, leading actions on soil contamination. Among her best achievements is the organization of the World Symposium on Soil Contamination, and her role as the main author of the World Assessment of Soil Contamination, published in 2021 by FAO and NUMA. Currently, she is coordinating and supervising the implementation of actions and projects oriented to deal with degradation, sustainable management, and soil enhancement. Thank you very much, Dr. Natalia. Thank you for your presentation. And let's begin, please.
Muy buenos días a todos.
Good morning, everyone. Hopefully you can listen to me well and that you can see my presentation. Okay. Thank you. Thank you so much for this invitation and for the introduction. It is a great pleasure for me to be with you today. I would like to thank especially CIMMYT, because as Dr. Blanca Prado already said, CIMMYT is one of our key partners in order to start recarbonizing agricultural soils in Mexico. I will try to be brief so that we can respect the time of other speakers. We have been talking, or most of our previous speakers have talked about this topic. We have lost lots of our organic carbon that was in the soils due to poor management practices. We have to revert this situation. We have to manage our soils in a different way in order to re-inject that carbon that is currently in the atmosphere. And at FAO, the World Alliance for Soils, we did a study to understand how much carbon we had in our soils and the potential for sequestering carbon in our soils. The areas in green are the areas in which we are concentrating our efforts because they have a high potential for carbon sequestration. With these estimations, we believe that we can reduce up to 33 to 34% the GHG emissions at agriculture in specific regions. But as the keynote speech mentioned, we have to work this hand in hand with other strategies for decarbonizing agriculture. We cannot rely only on the soils to solve these problems. And from the FAO and the Alliance, we have created this initiative called RecSoil. It is a carbon-based initiative with the objective of improving soils health through maintaining or increasing the SOC stocks. It is a mechanism that is offsetting, providing rewards and providing incentives to the growers so that they can adopt the sustainable practices to increase their yields, and also they can help improving climate change and help adapting themselves also to this climate change. But we have to surveil these GHGs emissions, which are the changes undergone by the COC stocks. And that's why we have prepared several strategies. In the case of Mexico, we have been implementing RecSoil since 2 years ago, thanks to the initiative of the Ministry of Agriculture and Rural Development of Mexico's government with the support of CIMMYT and PUEIS. Why? Well, we have heard already that around 64% of Mexican soils have a level of present several levels of degradation, and more or less 28% of farmers in Mexico have reported soil fertility issues. These figures are quite worrying. Above all, if we consider that agricultural soils occupy more than half of the national territory. So since our standpoint with this Rec Soil initiative, we want to foster the training of technicians and farmers in sustainable soil management practices in order to obtain a sustainable self-sufficient system, optimizing current national resources that we have in agriculture, and also support other initiatives that the government has already implemented, such as the National Initiative for Sustainable Agriculture. So Rec Soil will form part of that national strategy. NASA strategy, I'm sure that you will know or have heard about it. And the idea is that the farmers themselves will be the backbone of this project. We consider that for a project to be efficient, effective, and sustainable at the long run, we have to work hand in hand with growers, because they will be, at the end of the day, the ones who will manage that soil and will also convey those good practices to other farmers, so that these practices can be implemented at the long term. I'll talk briefly about this project. I'll go very quickly through these slides, but later on you will have this presentation. We're implementing it in 2 areas, at Michoacán and at Jalisco states. And the idea is to create capabilities on soil sustainable management practices to improve soil conditions, and also to improve the capabilities of growers so that they can work as internal local extension experts. That's what we do through the program called Soil Doctors. Dr. Blanca already talked about this program, and to establish this soil monitoring system for carbon stocks and soils health. For us, it's crucial not only talk about carbon content. Also, at the beginning, we heard that is one of the best soil health indicators. We believe that we also have to consider other soil health aspects. In the picture, we're showing Michoacán's example. They have terrible problems of compaction, erosion, lodging, and at Jalisco, they also have terrible problems with excessive fertilization, compaction, also contamination problems and loss of organic carbon. So with Rec Soil, through different stages that are well defined, what we want to do is to create a roadmap that we can follow, first to identify problems and to identify which practices of sustainable management are the best to solve those local problems. As we said, there is no one single solution, there is no one single practice that can be considered as our panacea to solve all issues. On the contrary, we have to use practices that are specific to that soil, to that crop, and to those problems, local problems. So the decision-making process has to be based on soil data, and that's why we created this soil monitoring and surveillance system. What do we measure? We have considered 2 main key indicators: soil productivity, organic carbon, obviously, is a key indicator, soil physical properties, and biological soil properties. So we're considering respiration, but it should be always linked to other soil indicators. In order to have a harmonized process whose data can be compared not only at a national level, but also at an international level, we're using harmonized methodologies. We work with our labs in order to follow those harmonized methodologies, and we also follow a protocol explaining step by step in detail how to conduct those measurements. And lastly, it's crucial to consider the social and economic indicators. social and economic indicators that will tell us the feasibility level of sustainable management practices, including, for instance, land tenure, legislation, access to resources, access to technology, access to incentives or loans from the banks in order to invest in good soil management practices. And here you can see some pictures where we are exchanging experiences and teaching growers, showing how technicians can take measurements in the same way. And in Mexico, we have already completed the process for defining the baseline. And these results will be shown very quickly because we have time constraints, but we have seen that the main problems in some cases is pH, soil pH. We have alkaline soils and also very acidic soils. We also have a problem with the ratio carbon-nitrogen ratio, which can indicate excessive fertilization or symptoms of soil exhaustion due to the excessive or intensive agriculture. In the case of Jalisco, at lime or lemon and agave grower soils, we saw terrible problems of erosion and a great loss of carbon due to their management soil practices. At CIMMYT, we have already created an intervention menu where we're proposing a series of practices that will be shown to the growers that are participating in this program. We will train them so that they can adopt them. This is a list of 8 basic interventions in order to reduce tillage and better use of contour lines, and stop using nitrogen-based fertilizers, and instead of that using amendments, etc. With the results on the soil measurements that we have already made and the basic or the preliminary analysis of the fields, we have a series of recommended practices for the growers, and we're at the stage of implementing them. The idea is that if we are able to implement these practices in 136 hectares in total, with the farms that are participating will be able to reduce an equivalent of 160 GHS emissions, and we will be sequestering that carbon and recarbonize our soils for agriculture. And these are some pictures of the workshops that we are giving for soil doctors, and also some other examples of biological pest management practices and conservation agricultural practices. And that's it. If you have any question, I will be glad to entertain it. Thank you.
Muchas gracias, doctora Natalia, por su excelente
Thank you very much,
presentación.
Dr. Natalia, for your excellent presentation. I would like to start now with the Q&A session. I would like to invite Dr. Simón and Dr. Blanca Prado.
Bueno, la primera, tenemos un tiempo reducido para preguntas, pero
yes, we don't have a lot of time for questions, but we have time for 2 questions. So we'll begin by questions to Dr. Simon Fonteyne. We have one question from Alejandra Rice from INE. And congratulations, doctor, your presentation was excellent. What is the future of regenerative agriculture? And along with another question regarding if there are negative aspects on carbon sequestration, meaning is there a limit on soils to sequestrate carbon, meaning that there would be an excess of carbon in the soil? Well, thank you so much for your questions. To answer the first question, I think that next in the regenerative agriculture space is that it will never be done. It's not that there is a limit, so as far as we can go and then we can retire in peace. No, we will need to continue our work trying to support biodiversity, better use of water and soil. So there is a lot to be done. In research terms, the world is full of different characteristics. So we need to continue our work, our extension to incentivize farmers, support them implementing these practices, and then we will need to study the impacts this will have. And the other question, is there an excess? Well, I don't know if we could have an excess. I think that in terms of the agriculture, we don't need to worry about that. Our challenge is to increase organic matter content, and with the practices that we have, we will never reach an status of excess. Those soils we have, peatlands, we have other types of soil that have a lot of organic matter, but they are pretty fertile, but they will be better as sinks. And I think this question is more for soil scientists, less agronomists as I am. Thank you. Thank you. And we have a question for Dr. Blanca from Aurora Lobato. And is this, are you in communication with the European Union on the practices they have? This is a community that joins representatives of different soils and they work for this. Well, thank you for your question. My answer is no. We do not have any collaboration with the European collaboration. If you have a contact information for a representative, I would appreciate it if you could forward it because we can contribute and change for the better. Thank you. Well, thank you. And with this, I would like to conclude this block, and I would like to give the floor to our MC, and thank you very much for your participation.
Pues así fue este primer bloque
This
temático.
has been the first block of presentations. As you can see, we have a little delay on our agenda and we need to adjust this. We have planned, but we need your collaboration, and it is that we will skip our break. We still have the coffee service and the soft drink service outside. You can go out and have your piece, but we will not have a pause. So before beginning the next block, I will like to share some information. In the morning, we presented the number of people connected via Zoom, and I would like to give you an update. So close to 900 people are connected online, and 300 were connected on the first section of today. So thank you very much for your attention via the platform.
Y les presento ahora al moderador.
Now I would like to introduce the moderator for the second block, and he is José Luis Ayala Espinosa. Please, if you can come up to the stage.
José Luis Ayala Espinosa es
He
coordinador de
is
proyectos
project
en la
coordinator
delegación del ICA en
in
México.
ICA,
Posee una
Mexico's
maestría en
delegation. He
agronegocios.
has a
Su
master's
publicación
degree
más
in
reciente
agribusiness.
es la
His
Agricultura de
his
riego en
latest
México.
publication
Cuenta con
is
más de
Irrigation
25 años de
Agriculture in Mexico.
experiencia en
He has more
producción
than
agrícola y
25
ganadera
years
directa, sistemas
experience
de
in
pastoreo de bovinos
agricultural and
y bovinos,
livestock,
comercialización y
range
financiamiento
systems for
agropecuario,
bovine
así
and
como en
caprine
evaluación de proyectos y
commercialization,
agronegocios, entre otras áreas.
agro and livestock
Adelante,
funding,
José Luis.
and project assessment and agribusiness. You have the floor.
Bueno.
Well,
¿Sí me escuchan?
can you hear me?
Bien. Muy buenos días y buenas
Good
tardes.
morning
quizá buenas
and
noches a
good
quienes nos acompañan
afternoon, perhaps
en
good evening across the
este
globe.
foro. Gracias a
Thank
todos y a
you,
todas por su presencia.
ladies and
Vamos a iniciar
gentlemen,
con el
for
segundo
your
bloque
attendance. We will
y
begin our second
este bloque
block, and
tengo
this block
el honor de iniciar con la
I have the
presentación.
honor
Tenemos
to
a un gran científico
introduce
permito
you to
presentar,
a
el
great
doctor
scientist,
Ratan Lal.
Dr.
El doctor
Ratan
Ratan
Lal.
es profesor distinguido de
He
ciencia
is
del suelo y
distinguished
director
professor of soil science
del Centro
and
de Ciencias
director
Alimentarias,
of
Agrícolas y Ambientales
the Food and Environmental
de la Universidad
Sciences
Estatal de
Center
Ohio.
from
Es
the
profesor
State
adjunto
University of
de la
Ohio.
Universidad de
He is
Islandia
joint professor
y del
of
Instituto Indio
Iceland
de Investigación
University
Agrícola.
and
También es
also
profesor visitante
of the
en la
Inter-American
Pontificia
Institute
Universidad
for Latin
Católica
America.
de Valparaíso
Also,
en Chile.
he
El doctor Ratan Lal
is
recibió el Premio
guest
Nobel de la
professor
Paz
at the
en el
Pontificia
año
University
2007
in Valparaiso
como parte
at
del
Chile.
panel
He was
intergubernamental sobre cambio
awarded with the
climático y
Nobel
también
Peace
ha
Prize
sido
in
Premio Mundial de la
2007
Alimentación
as
para el
part
año
of the
2020. El doctor
Intergovernmental
Ratan
Panel
Lal
on
es
Climate
embajador de buena
Change.
voluntad
He is a
del Instituto
Goodwill
Interamericano de
Ambassador
Cooperación para la
from
Agricultura,
ICA,
el ICA, colaborando con
and
proyectos
he
sobre la
has
importancia de la salud
collaborated
del
on
suelo y el
projects
potencial
regarding
de la
the
agricultura
importance
como
of
único
soil
sector
health and the
productivo que puede
potential
secuestrar
of
carbono
agriculture as
y de
the
esta manera
only productive
contribuir a la
sector that
mitigación
can
del cambio
sequestrate
climático.
carbon and in this way
Es un
contribute to
gusto
the
el
mitigation of
presentar la
climate change.
disertación del doctor Ratan Lal.
It is an honor
Tenemos un
to
video que les vamos
present
a presentar sobre
Dr. Ratan
su
Lal. We
experiencia
have a
en la
video
materia.
regarding
Iniciamos,
his
proyectamos
experience
video, por
in the
favor.
matter.
Gracias.
Thank you. Please run videotape.
Bueno, ya. Listo, gracias.
Thank you very much.
Corre video, por favor. Gracias.
We are sorry, there is no audio in the video. I think this is something that the technicians will need to work.
Ustedes saben cómo es esto de la tecnología, pero
You
tenemos a
know
todo el equipo
how
trabajando en ello, entonces
technology
estoy segura
has
que en unos
its ups
instantes
and
más
downs. The technical
comenzamos.
team is working
I
on.
want to thank
¿Qué
ICA,
tal?
with whom the Carbon Center at Ohio State
is very strong, mutually beneficial cooperation, especially this program through the representative of ICA in Mexico and the cooperators of ICA in Mexico. I greatly appreciate the opportunity to talk to you. Because I'm traveling to COP29 today, I'm getting this message recorded and send you a link. The title, as was suggested, Recarbonization of Agricultural Soil and Decarbonization of Agri-Food System. To understand that topic, we need to understand, need to comprehend the interaction among different carbon stocks and the impact of human activity on those stocks. We have atmospheric carbon, it's called gray carbon. We have red carbon, which is a fossil fuel carbon, which when it is consumption, using fossil fuel, it increases the emission into the atmosphere, and the atmosphere interacts very closely with plant through photosynthesis, and that's a green carbon. The green carbon is transported into the soil through roots and through input of litter and other biomass carbon, and that's the soil carbon or the humus. The soil carbon can respire back into the atmosphere and have emission from soil into the atmospheric. And soil also is transported into the ocean and aquatic system, and that's a blue carbon. And soil also have inorganic carbon, calcium carbonate, magnesium carbonate, that's white carbon. And of course, we have black carbon, which is combustion of biomass leaving biochar or charcoal in the soil. And all these different forms of carbon interact with one another, and their interaction is changed drastically by human or anthropogenic activity. So management of these different carbon stock is very critical to understand the recarbonization of the terrestrial biosphere and of course the decarbonization of the food system. The CO2 concentration in the atmosphere at present in November 2024 is 427 parts per million. It very strongly follows what we call the Keeling curve, which is a seasonal cycle in the northern hemisphere. During the winter time, the concentration is the highest, and during the summertime, because of the photosynthesis, the concentration is the lowest. And this leads to us looking at the carbon stock in the atmosphere, how it had changed pre-agriculture, 10,000 years ago. It was 360 gigaton per kilogram. Pre-industrial revolution, circa 1750, it increased by 200 gigaton per kilogram to 560, primarily because of land use conversion, deforestation, and agriculture. And at present, it's about 880 gigaton. Total emission from land use change in agriculture to date is about 575 petagram per gigaton, and total emission from fossil fuel since 1750 is about 450 gigaton. And that difference in magnitude is very important to understand. CO2 in the atmosphere in 1960, when I was a school student, was about 350 parts per million. At present, it is, as of today, 427 parts per million because of two reasons. Number one, agricultural land use conversion, going back to 10,000 years ago, and fossil fuel combustion, going back to 1750. Humans, therefore, have impacted the global carbon cycle tremendously. Land use change in agriculture, with a total emission from 8,000 BC to about 1750, about 320 gigaton, from 1750 to 2020, about 235. Total about 560 gigaton, of which the soil contributed 133 to 135. Total fossil fuel emission, as I mentioned before, about 460 gigaton. And the total anthropogenic emission from 1750 to 2050 is about 700 gigaton, of which agriculture and food system is the 34%, which means management of agriculture is very critical component of maintaining the temperature of the planet Earth below 2 degrees centigrade. What is the fate of anthropogenic emission? Atmosphere has absorbed between 1750 and 2020 about 290 gigaton, ocean absorbed 180 gigaton, land absorbed 215. The question is, how can the uptake of the land be increased by deliberate management of land use and agricultural practices? That is the key component that we want to consider. Global deforestation, conversion of forest to agricultural land use has contributed tremendously. Area-wise, forest was 6.5 billion hectares, and at present it's about 4. Cropland is 1.4, grazing land 2.3, and that affects carbon stock in the soil, both organic, which is dark horizon on the surface layer, and inorganic, which is the calcium, magnesium, carbonates, and bicarbonate in the subsoil, especially those of the arid and semi-arid region. 2 components of the carbon stock in soil, organic and inorganic. The depletion, as I mentioned before, soil carbon stock is estimated about 130. How much carbon can we afford to keep burning from fossil fuel? That's a very critical question. Doubling of the atmospheric CO2 of 280, doubling means 560, minus what the present 427, multiply by 2.13 gigaton per 1 parts per million of CO2, which means 283 gigatons. So the total amount of carbon that humanity can burn from fossil fuel and emit in the atmosphere is approximately 280 gigatons. The question is, how do you divide this pie? How do you do the recarbonization and decarbonization of the food system? Soil degradation plays a critical role. Almost 40%, the recent estimate of the total land area is degraded by water erosion, by wind erosion, by salinization, by depletion of organic matter content, and many other activities. Therefore, the 21st century green revolution, vis-a-vis the 1960s green revolution, which was a seed-centric, dwarf varieties, heavy inputs of chemicals and irrigation water, which we now should have a soil-centric revolution based on soil resilience with high eco-efficiency and with science and management-driven option of improving soil health. So the green revolution, which is soil-centric based on soil health, which refers to soil's capacity as a dynamic and biologically active entity to create multiple ecosystem services for human and nature, and human are part of nature. How do you manage soil health? By protecting and restoring soil, by restoring soil organic matter content, by restoring soil biodiversity, by living in harmony with nature, by observing the law of return, treating soil like a bank account, and adopting nature-positive agriculture. Why? Because of its large environmental footprint, there's a strong and urgent need for developing innovative farming systems which reconcile the need to produce food for 8.2 billion people and increasing and getting more affluent by the day with the necessity, absolute necessity, to restore the environment. Using food or restoring the environment. They go together. It's not one or the other. The threshold level of soil organic matter content should be about 2.5 to 3.5% in temperate climate. In tropical climate, maybe slightly less. But in many developing countries, the soil organic carbon content is less than 0.5%. Therefore, the use efficiency of input, therefore the productive capacity of soil to generate ecosystem services has been jeopardized. Why? Because carbon is the heart of soil health. Organic carbon is the heart of soil health. Humus is the heart of soil health. And we must create a positive carbon budget of agroecosystem so that we increase carbon input into the soil more than the losses. Input by practices such as biochar, compost, cover crop, root biomass, crop residue, and the losses such as erosion, leaching, and decomposition. This is what we should have. Unfortunately, in many sites, with the resource poor farmer and desperateness, the inputs of biomass is always less than the losses. Therefore, we have a negative nutrient budget. If we were able to create a positive nutrient and carbon budget, the technical potential of carbon sequestration in soil of the world is about 2.5 gigaton petagram of carbon per year, billion tons of carbon per year. Combine that with the forest vegetation, between now and 2100, soil can absorb 178 gigaton, vegetation another 155, total about 333. That translates into the atmospheric drawdown of CO2 of 157 million. Therefore, if we can find an alternative to fossil fuel, renewable energy sources, and we do better management of land use for agriculture purposes, keeping temperature of the planet Earth below 2 degrees centigrade warming is still possible. And growing carbon as a new crop can facilitate that process. And that means paying farmer for increasing carbon stock in the soil and trees and land. How much payment? In 2010, the price was about $35 per credit, which is metric ton of CO2. At present, it's about $50 per credit. And this would require our total farmers of the world of 700 million, of which 550 million are small landholders and 150 million are medium and large landholders. If we were to pay each one of them for the carbon credit at $50 per credit, it's approximately $100 billion per annum. Not 1 billion, which was requested in COP21 in 2015 in Paris. $100 billion. And where will this money come from? All exporting countries, private sector, diverting funds from war, and of course consumers. We are 8.2 billion. If each one of paid $12 extra per year, that's $100 billion. Very small price indeed to recarbonize the biosphere and decarbonize the food system through negative emission in the future by making agriculture a solution. And I must say private sector is very critical in that role by promoting nature positive agriculture, by increasing access to input, by involving improving investment in agriculture research and training. We need policies because soil is a living entity, just as the universal rights of human, rights of animal, there must also be rights of soil, rights of nature. Being the essence of all life, soil must have rights to be protected, restored, thrive, and managed judiciously. For that, we need a Soil Health Act. In the US, we have a Clean Air Act 67, Clean Water Act 72. We need a Healthy Soil Act so that we have a trinity of acts. And the farmers who adopt these three acts together, they should be rewarded. $50 per credit of carbon sequestration. There could be separate credit for water and biodiversity. This is just for the carbon alone. And finally, peace is a scientific issue. And war and hunger are man-made tragedies. And we must make famine and mass starvation politically intolerable, morally toxic, ethically unthinkable, and humanly unacceptable. Our mission is no farmer is left behind. And thank you very much.
Invitamos, por favor, al señor Carlos Torres a acompañarnos
And
también al
now we
frente.
would like to ask Mr. Carlos Torres to come up to the stage. Thank you very much. So now we'll move on without a brief reflection on this dissertation from Dr. Ratan Lal. Certainly the concepts he presented not only in terms of the impact on this anthropogenic and how this has evolved throughout the centuries, where he shows proofs and the metrics in order rigorously to quantify them and quantify the cost that this implies to revert all the negative impacts that we are facing today in our planet, with interesting concepts like soil health, live soils, therefore soils that demand their own rights. So moving on. Now in this block, the second block, that the title is Regenerative Agriculture, Climate Change, Food Security and Carbon Sequestration in Sustainable Agri-Food Systems. Now we have a discussion panel with two researchers. I don't know if Dr. Mohammed is online. Yes, thank you. So I would like to begin by introducing our next speaker. If I must say, it is a pleasure to have Dr. Mohammed Ibrahim. He's virtually connected. Right now, he's in Costa Rica. He is Technical Cooperation Director of ICA and Comprehensive Management of Risk. He has representative of ICA in Belize and General Director of ICADE. He has a PhD in Agronomy and Environmental Sciences from Wageningen University from Holland, and in his publication he has one for Payment for Ecosystem Services, a chapter on a book of degraded lands, recovery, and silvopastoral systems for mitigation and adaptation to climate change. From 2013, his areas of interest include understanding on how market mechanisms and regulatory frameworks affect the adoption of silvopastoral systems. Dr. Mohammed Ibrahim, thank you very much for joining us, and if you can hear us, you have the floor now. Thank you. Hello and good afternoon. Can you hear me? Yes, we can hear you. Wonderful. Well, first of all, I would like to thank the organizers, ICA, CIMIT, and FIDA, for inviting me to participate here on recarbonization of agricultural soils. If you give me a minute, I'm trying to share my screen.
Okay. O sea, ¿puedes ver la presentación?
Can you see my screen?
Vemos su diapositiva.
Yes, we see your screen.
Okay. Bueno, perdón, es problema
Well,
de tecnología
yes,
también.
thank you. This is a technology issue. Okay, so recarbonization of soils is stemming of countries that are advancing with their indexes, and in Mexico 15% of the from the agricultural section. But I think that the point is not only for emissions, but how we can manage the soil health, as Dr. Ratanlal, to improve food production and also keeping the environmental services. We can see that across the globe, many soils are degraded, so they have lost their carbon and organic matter stocks. So the issue is stemming that the recarbonization of soils is part of the solution. So it will be a solution to reach the mitigation objectives against climate change. In Latin America, there are so many regions where there is a lot of soil degradation and also a lot we need to see how to recover. So the matter of regenerative agriculture is a solution that, along with good practices that many farmers have implemented as part of the solution, and I will share some examples on this. The approaches on how to reduce emissions or how to...
Si me permite, doctor, no estamos viendo que avance su presentación.
Sorry, Dr. Mohammed, your presentation, the slides are not changing. So yes, this will be land degradation. If you can ask us to change to the next slide, so we can do so, because otherwise we can't. Can you see the slide? We see the slide that has the title Degradation of Land. Why don't you manage my presentation? I stopped sharing. Yes, yes, of course. Just give us a second to the technical team, and I'll let you know when we can move on.
¿Ya está su pantalla, doctor?
Is your screen free? Yes, I stopped sharing. Maybe you can begin sharing my presentation. Yes, yes, we can do so.
Okay, entonces la estrategia es incrementar las expulsiones.
So the strategy is to increase expulsions. And the next slide, please.
Siguiente.
The next one, please. So, as Ratanlal mentioned, the soil and carbon have a lot of effects, like carbon sequestration as part of mitigation, water retention, infiltration of water, erosion resistance, and soil fertility. So we can see there are multiple benefits upon carbon sequestration. These are very important axes. The next one, please. So ICA, along with Living Soil programs, and Dr. Ratanlal is a part of this project, we have food systems and we monitor soils in a gradient of different uses and production systems in order to have specific data on the increase of carbon stocks, carbon sequestration in different systems, and also to have monitor activities in these ecosystems. The next slide, please. So this is an example where we sample soils. We have different soil types, and the baseline of carbon stock line it's different. It all depends on the degradation level and soil management level. So to establish the baseline of information, it's really important to define the different carbon stocks in these systems. So ICA is working along with PepsiCo, and there is the objective to have 7 million acres globally to reduce an estimated 3 million and plus tons through regenerative agriculture. And this is just an example of practices they are promoting, like zero tillage and at the same time soil conservation practices. The next one, please. So another example of improved pastures in North Central Caribbean South, we can see how these carbon stock are increasing. Like if we increase the stock 1.03, we can show that yes, if we invest in soils, we can reach the mitigation objective versus climate change. So the question is, we are focusing on the soils, but there are a lot of conservation practices in silvopastoral systems where we increase the carbon stock in the vegetation, in the soil. So there is a positive gain when we add both in order to calculate the net gain in these changes.
¿Cuáles son las prácticas que están a
As
nivel
an
de escala?
example, which are the practices in free scale? In Latin America, there is an agroforestry system, Quesungual. They have beans, trees, maize in rotation crops with soil management, and the data shows that the performance of these systems have increased from 0.6 to 2 tons per acre, but also organic matter content has increased up to 4.1, and this is an indication of the quantity of carbon that they are producing. And these practices are free of scale, so there are opportunities to improve these practices, even increasing the quantity of carbon these systems have, and these systems are of regenerative agriculture across Central America. These examples are for agroforestry for coffee and cocoa plantations. These are diversified systems with several species, not only coffee and cocoa, but also different trees, varieties, legumes, and other species that work recycling nutrients that have an important role in these systems. They simulate a forest system as for their environmental services, and this is another example. And this is a table of benefits. We don't need to see the benefits of system in for carbon, but also on weed control, environmental services, biodiversity, water availability, and benefits on the livelihood of families. This slide shows to the upper right quadrant of more diverse systems, and they have more production and more carbon sequestrated. So the design of regenerative agricultural systems promises to have more carbon in the systems, and this is an important to consider on how to support the diversification of agricultural systems. Also, many rangelands are degraded. And please, the next slide, please.
Ok, pasturas degradadas para convertir en una renovación de pasturas.
Yes, these degraded rangeland, once they are restored, they all have a gradient of carbon sequestration. And also there could be a secondary management vegetation, and these are like transient systems in the recovery path of these systems. So certainly there is a lot of progress on silvopastoral systems. As for their carbon and nutrients, there are some data that I can show. These are systems that we have in Guatemala, showing that forests have a higher value in carbon sequestration. In rangelands with live fences, there is higher carbon sequestration also in cover crops. This is very important to understand the matrix of land uses in this region. We have achieved to reach carbon neutrality in the system. This is Mexico, Campeche, Chiapas, and Jalisco. Carbon capture versus emissions. So this is the equation. Next slide, please. So I developed a method to calculate carbon index and biodiversity index, showing higher value in carbon as we increase better practices or more biodiversity. And I am using this methodology to introduce change, and there will be a payment for this exchange. This slide shows that these payment systems shows that these exploitations adopted these silvopastoral practices, and this is a methodology for policies because they increase the carbon sequestrated. These are the examples on how the changes have been translated into benefits. So we also have these NAMAs. This is being promoted in Honduras, also in Mexico and Costa Rica, providing technical assistance, financial instrument, and the political framework. And these NAMAs, this is the example in Honduras, the baseline of information, the project's impact. It's showing a reduction in emission, and it's quantifying carbon sequestration in the soil, stating that the countries are reporting these indexes. Obviously, we need to see in these practices if there is a return of investment, carbon sequestration, and biodiversity, because it is not only about carbon, it is also about multiple ecosystem services. And as you know, there are some practices like herd structure, live fences. So there are multiple benefits using the economic instruments that we provide, and this is the example that we have tried to understand the cycle of carbon sequestration. And this is part of the model we have. We have the recovery and the impact and the soil as the structure for carbon sequestration. Obviously, 30% of the area is changed throughout 20 years. We were able to reduce in 44% greenhouse gases emissions. For the year 2050, we will need 70% of this area to reach a net zero of emissions. And this is a table with data that shows the income of farmers in regulated markets. We want to have these more regulated markets to increase their income. And right now we are in negotiations with these carbon markets to have payment. And at the end, these are my recommendations. We need more elements to assess the changes on the carbon stock and funding for this. Thank you very much.
Muchas gracias, doctor Mohamed. Le agradecemos por toda la cantidad de información que nos ha presentado. Habrá que dedicarle un poco más de tiempo para irla digiriendo. Gracias. Y también pedirle si nos sigue acompañando para continuar con este panel y recordarles también a todos los presentes y a los que nos acompañan en la virtualidad que al final tendremos una breve sesión de preguntas.
I would like to remind everyone that at the end we will have a Q&A session. Thank you, Doctor, again. And now we'll go on to our next speaker. Let me introduce Dr. Carlos Torres Barrera. He is an agronomist with a specialty in horticulture from Antonio Agarro University at Saltillo, Coahuila. He has a master's in innovation and strategic leadership by Instituto de Innovación y Desarrollo Tecnológico in Morelia. In his professional life, he has been working with tech transfer systems for sustainable production of grain and vegetable crops, as well as ornamental horticulture for 3 decades, linked to the trust funds linked to agriculture by FIRA. From 1991 to 2007, he was in charge of production units for conditioning of micro-propagated plants and flower production, as well as ornamental nurseries and hydroponics at Technological Center of the Soyuca. From 2008 to 2017, he was an expert at the Development Center Tecnológico Salvador Lira in Morelia, Michoacán, and specialized in protected agriculture. And currently, he works at the Center for Technological Development of Villa Diego, devoted to sustainable agricultural production at Guanajuato. Thank you so much, everyone. Thank you to CIMMYT for your invitation. Hopefully, the talk that we will have will help conveying what FIRA does through one of its technology transfer centers.
Ahí está.
Here it is.
Ahí está. Que se encuentra ubicado en el estado de Guanajuato.
Which is located at Guanajuato State at Valle de Santiago Municipality. In these centers, our task is to assess technologies, to demonstrate such technologies, and training and providing training. The Sustainable Production Center for Vegetables and Grain Production also has to create innovative networks. In the last 5 years, we have undergone through a series of critical scenarios, and therefore yields and profitability have been compromised. We're very concerned about the issues that the growers are going through, because we have to make sure that they can still grow grain cereals in order to have food security. The increase of imports, the grain price is quite low, and if we have to add to all these the terrible conditions, environmental conditions that have prevailed in this region, have reduced greatly the productivity levels. That's why we have to make the best out of the available resources and to make more efficient our productive processes. It is very important to think once again on the way in which we're doing things. We which kind of agronomic practices we're following, because we are losing biodiversity, we are deteriorating our soils, and we are polluting them. The conditions that we have nowadays, like drought or excessive rainfall in very short periods, have created flood problems as well, flooding problems. It's important to have the best management of that water available. We need seepage enough so that the water tables can be recharged. And we need those water resources in order to deal with the adverse environmental conditions that we are wasting. So FAO says that almost 30%, up to 60% of the world's soils have suffered some level of deterioration. In other studies, we have seen that more than 50% of the Mexican soils are suffering from such deficiencies or deterioration, up to 64%. So that's why we require to grow healthy food products with high quality, but protecting our natural resources. That's what FIRA does through these technology centers. And throughout the 36 years of existence, we have been promoting the use of conservation tillage. We call it zero tillage or non-tillage, but it's the same term. Basically, we're promoting the least disturbance of soils with machinery and to protect the soils with cover crops and crop rotation. So we have a series of steps that will enable us to understand how we're going to distribute the crop residues, the stubble, how to improve the soil conditions so that they can still provide, so it can still provide nutrients. How can we help pathogenic attacks using antagonistic microorganisms? And also we have assessed the decisions that are necessary to make in order to continue working with this technique in the long run, and also to work with the stubble or with the crop residues so as to protect bare soils and continue working in agriculture. We want to reduce costs and also the time to start a new crop season where less passes of machinery will be resulting in less use of fuel, less GHS production, and a lower carbon fingerprint. But to that end, we have to measure resistance to penetration. Like in the last picture, we were drilling a borehole into the soil to measure the health of the soil. We are working with this conservation tillage in order to help the soil condition. We're improving in terms of savings in fuel, in time, and also in less contamination. Out of the organic matter present in the soil, almost 40% is carbon. We use the measurements in order to understand which is the content of organic matter in the soil through soil fertility tests, and then to redistribute the crop residues in order to improve the carbon retention in the soils. We have conducted several trials where we are comparing different types of tillage systems and their effect on carbon sequestration. For instance, in the work that we do along with INIFAP, the National Research Center, we have understood that there is some label labile, organic carbon, where, and we also have recalcitrant carbon. The labile can be lost easily through tillage. So this conservation tillage is contributing to distribute slowly, gradually the organic matter and to use it also in a gradual manner. Then we began from 0.7% of organic matter to 4.4% in those soils where we started using this kind of conservation tillage. The importance of growth residues is also of great importance. For instance, maize crop residues will turn into nutrients that plants can uptake, and we will have therefore less need to use other types of fertilizers. We are also improving the soil aggregates. The particulated material of the soils has been improved, avoiding compaction, and therefore we have also increased the microbial soil life. These pictures are some pieces of evidence on how those soils can withstand better erosion as well as the rainfall impact. For instance, on the left-hand side, we can see soil in which there has been tillage and the soil has been disturbed, and we are using even ammonium as fertilizer. On the right-hand side, we have soil with an organic matter of 1.37 versus 3.37 on the right-hand side, and the water holding capacity has improved by 40% on the non-tillaged soil. Irrigation. Irrigation is also very important, and this practice has a huge impact on it. We measure the water used, we determine the water use fingerprint, and we have found that there is 5% difference in the water usage, 33% of less time to apply the irrigation services. By comparing both techniques, a deeper tillage with a conservation tillage, water conservation or water savings are much greater by 22%, less use of diesel, less conditioning costs for the field, better water fingerprint, capture of rainfall without seepage, and less emissions of CO2. As we integrate these techniques with others, we can see the effect of the use of microorganisms, beneficial microorganisms or biofertilizers. See, this is very important. For instance, in the case of wheat in this crop season, 75% says that is the decrease in fertilization by 25%, improvement of such fertilization by almost 50%, applying it directly to the root system, mycorrhizal fungi, nitrogen fixing bacteria and other beneficial microorganisms directly injected into the root system. So we consider 6.0 plus 6.8 as 5 kilos of difference, but the production cost is much lower and the yield is much better at 50%. The cost of production is less, is much lower per ton produced. So this system is more efficient and it is more flexible and resilient. It's better prepared to face price fluctuations of the grain. So there are some techniques which can help improving crop profitability.
And with regards to biodiversity of the microbiota, which are the effects of it? See, this is some historical data. The red arrows mean that with the implementation of this use of conservation tillage techniques, the use of biofertilizers, decrease of chemical fertilizers by 50%, soil test, and a target for yield target, we have increased the population of microbial colonies which are beneficial for the soil, and they are well balanced with some micropathogenic organisms which can be found in those lands. The importance of cover crops, we have seen that as we do rotation with the cover crop, the fungi and the actinomycetes increase very much in that soil, and we can see the effect of that cover crop. See, because we are suppressing the bad weed. And see the effect of crop rotation. How can we replace other types of crops, for instance, for fall, winter, in order to increase profitability of the farmers and to reduce weed infestation as well as to improve soil properties? And some of the very important indicators of soil health is which is the effect of the tillage system over the population of earthworms, for instance. The first two on the left is using conservation tillage. On the left side, reducing the fertilization rates by 50%. The one in the middle is having chemical fertilization at 100%. On the right hand side is steep tillage. That disruption of the soil is affecting the earthworm's survival. The effect of the cover crop on, and also the use of the crop residues for water retention capacity. For instance, this effect, the hat effect that protects the soil, decreases the soil temperature, preserves moisture, and the sponge effect of the crop residue, which is capable to retain moisture equivalent to 10 millimeters of rainfall at the first layer of crop residue. See, this soil that is protected retains better the moisture versus that soil which is bare. And this has improved profitability, productivity, it has enhanced the environmental fingerprint, it has dealt very well with bad weed, and there are many other benefits. And something quite important is that at the short term, this grower will achieve the best yields, at the same level than with the conventional systems. Profitability will be much greater at the medium and longer terms. Those physical and chemical properties of the soils will be enhanced substantially. This is a very important technique that we greatly recommend using. Another one is we have a very promissory expectations in order to improve yields through innovations in biofertilizers, such as the use of these endophyte bacteria that are applied to the foliage of the crop. But see, there is an increase of 1 ton more in yield in wheat production. And other work that we have been doing is creating green color maps so that we can make a better use, a rational use of nitrogen-based fertilizers. So we are going to reduce NOx emissions as well as GHG emissions, and that will improve the profitability and the yields. This is a comparison between the implementation of sustainable agricultural techniques in general, because this is a more systemic outlook. In here it says conservation tillage versus traditional. And then in wheat is 26% more yield, and in maize we have 18% better yield than with the conventional system. And with this I close. Sorry if I took too long. Thank you for your attention. Thank you, Carlos. Thank you so much for this presentation. You provided us with very interesting data. And now we'll go on to the Q&A. There is a question that has been made several times to Dr. Mohammed. Doctor, can you hear us? Are you with us here, Dr. Ibrahim?
Sí, me escucho.
Gracias, doctor.
Yes, I can hear you well. Okay, thank you, doctor. They were asking
several questions which can be summarized in one.
¿Cómo acceder a los pagos por
How can we
captura de
have
carbono?
access to payment due to carbon
Adelante.
capture? Please go ahead.
Los pagos de captura de carbono
Payments for carbon capture have several examples. For instance, in Costa Rica, there is a national fund, and this fund is used to pay for the carbon that has been sequestered in the systems. However, there are two types of markets. One is voluntary. You can have access to that payment as a volunteer. And there is another market based upon stock exchanges. But we do not yet have a very clear panorama. So what's the most important one is the voluntary carbon fund. And through those two markets, you can get a payment for those carbon captures. Okay, thank you so much, Doctor. For those of you who are interested in this topic in particular, I would like to tell you that tomorrow we will have a panel where we will be talking in more detail about this.
En este caso es para Carlos. Y la pregunta
Carlos, this question is addressed to you. It is very simple, and it says, well, based upon the evidence, the experience, and after almost 4 decades of you having worked in conservation agriculture at FIRA, why in Mexico we have not yet been able to increase in terms of surface area, having more production systems with conservation agriculture in Mexico? Your opinion, please. Well, in fact, this answer will not be short. It's not an easy answer, really, because there is a series of barriers which are limiting the adoption of this technology, beginning by... I'm saying this based upon some studies which have been conducted, which have pointed out to the age of growers that have been working with extensive agriculture, and they grow basically grain cereals. They are already aged and they resist change. It's not easy for them to change after so many years. And there is another point that is mentioned quite often, and they say, well, if we have to implement these techniques, we have to invest in the techniques in buying tools and machinery for conservation agriculture. Well, FIRA is here to support you in this regard, but that's another limiting factor. Another limiting factor, and we have not mentioned it much, is the way in which we cultivate the land. Look, those people who are more willing to use these conservation tillage techniques own their own land. However, in Mexico, almost 50% of the land is being leased for agriculture. And these growers have to pay for that land use, so they have to get immediate profits in order to pay for that. And these techniques, they long, see? So they are not really willing to wait for a long time in order to enhance the soil, because they said, well, I leased this land for 2 years and I invested in it, and then I will leave the land and this owner will lease the land to somebody else, and I will leave all my investment inside the land. This is a very limiting factor, and I have talked to people who said this directly, quite straightforward. And of course, the age of the growers and resistance to change are also important factors limiting this conservation agriculture. Thank you so much. So based on the information that we have heard from Dr. Mohammed and Engineer Carlos, indeed, there is evidence, scientific, economic, social evidence saying that not a single institution is responsible for the change. Not a single actor is responsible to enhance these agri-food systems. We need a comprehensive solution and therefore a comprehensive effort. It is easy to talk about integrated solutions, and it is a reality indeed. It is a good business. Recovering soil's health is a good business, but we also have to consider the time required in order to enhance a deteriorated soil. In average, Carlos said that according to Fidal's experience, soil under conservation, tillage under conservation practices at Villa Diego took almost 4 decades, 40 years, taking from 0.05 organic matter content of soils to 4.2% of organic matter content. With the conservation tillage, let's reflect about our conventional agricultural systems.
Respecto a la salud de los suelos. Muchas gracias a todos. Gracias, doctor
Where
Mohamed.
we
Gracias,
are
ingeniero
just
Carlos.
scratching
Continuamos.
those
Gracias.
efforts that are required in order to enhance our soil's health. Thank you.
Pues ahora sí, los invitamos a los presentes aquí en la
Now
sala,
we
también
will
a los que nos
invite
siguen desde
you,
Zoom, a un
both
merecidísimo
participants
descanso
that are
de 10
connected
minutos
and
para que
those
todos
of
se
you who are
estiren,
here in the
tomen
audience to
agua,
have a 10-minute break
hagan un pequeño descanso, también
so that you
beneficial,
can
y en
stretch
10
your
minutos
legs,
los
rest a
empezamos
little
para
bit,
continuar con la segunda
refresh,
parte de
and
la
then
jornada.
let's come back to the second half of today's meeting. Thank you.
Ir tomando asiento nuevamente.
Hello, we are asking everybody to take your seats again. Those on site. Thank you.
Los invitamos nuevamente a ir ocupando de nuevo sus asientos, por favor.
If you're kind enough to take your seats, we will continue with the second part of today's session.
Pues bienvenidos una vez más a este foro.
Welcome again to this session. We will move on and begin our second session of the day. We have had an amazing morning with all the information and data, perhaps a little technical, but now we'll begin the section with a different perspective. Now we'll have a panel on reflections and realities on all these issues. I will introduce the moderator, and she, in turn, will introduce the speakers. But before that, just some reminders of the audience on site and those connected via Zoom. Remember that we have live interpretation services in Spanish or English. You can do it via Zoom or here with a headset. The dynamic will be the same as the speakers present their topic. You can upload your questions in the chat if you are a virtual attendee, or here with a note so the floor attendants will gather. And now a reminder for our speakers. In the table, you have a control. So with that control, if you can point to this window, there is where the operating booth, it is where the signal will be received and your slides will change. So let me introduce this panel's moderator. She is Ms. Daniela Vega. She is a coordinator of advisors for the DG of CIMID. He has a bachelor's degree on business administration by Tek de Monterrey, a certificate on supply chain and logistics by the Business School Soder from the University at British Columbia, and a certificate of excellence in management from Harvard Business University. Her work is focused on the design of innovative solutions for complex issues, strategic management, and the development of business models to improve agri-food systems. Ladies and gentlemen, Daniela and the speakers, thank you very much. Thank you, people here on site, and you connected via Zoom. Thank you for these kind words. As we heard this morning, the most important takeaway for you is the importance of the recarbonization of agricultural soils and the importance of decarbonizing agri-food systems. So that is why it is my privilege to present this panel from representatives from the private sector. A lot has been said about the private sector, how it can help us to influence the consumer. I think we're always talking about this issue from the perspective of farmers. We want farmers to do some things, to change and modify. Also, technicians, they should do this part, but many of these can be leveraged by the private sector to influence the consumers. We are all consumers, and I think that we buy and use their products. So I think it's important to understand the perspective from the private sector. So with this, we asked these panel members if they can share their diagnostics, their challenges, their goals, they think they will accomplish. So, Patty, I would like to begin with you. Patty is Business Sustainability Head for Syngenta, and I will read her bio. She is a prominent figure in the agribusiness and entrepreneurial sustainability. Currently, she is Vice Chair of the National Agri-Livestock Council and Corporate Affairs Director for Syngenta. She has been instrumental modeling possible practices in the agricultural sector. Her professional service has been in agribusiness, and in Syngenta, Brazil, she led strategies of public affairs and sustainability scheme from priority technologies in Latin American countries. She has an approach in diversity and inclusion, and short of that was her lead with the Multicultural Intelligence Initiative. So not only she has a bachelor's degree in marketing and also a proficient academic career. So thank you very much for joining us. If you can share the potential of carbon sequestration in Latin American and Caribbean countries. Thank you. Thank you very much, Danny. It is a privilege and an honor, a huge responsibility to be here in this panel, an important forum. And I would like to say, adding to the call here, that to have this seminar as a first step of all the actions, with all the information and tools in order to give the next step in how to do. So this is also the contribution from the private sector, Syngenta, and the National Agri-Livestock Council we would like to share with you. And especially thinking about that this has the attribute of an ecosystem phase in this integration, and this is how we will move forward. So, and I think this is a clicker. How? This shows the perspective from a macro perspective in order to produce more food with lower climate impact. There are 4 components as shown on the slide, and this is the global vision. How we must reduce the waste of food, and we can quantify this in -5 gigatons. Increased productivity will help us reducing emissions in the field, increase carbon in soil, and this is the matter of this forum, and a series of measures that we must have in order to reduce greenhouse gases emissions, which are the precedents for the agriculture in the target date 2050 as Syngenta. We are a science-based company, but we are characterized to have these private-public collaborations. We are collaborating with CIMMYT for more than 15 years. I will give you the number. I have been working for over 20 years in CIMMYT, in science-based collaboration scheme. And a critical foundation, as Carlos was presenting in his previous presentation, is how all these sustainable agricultural schemes, how to decarbonize and recarbonize, is part of the agribusiness, and how we can recarbonize soils, measuring how we can decarbonize agri-food systems. And I would like to share some of our practices. In Syngenta also, we have promoted through innovation, and this is answering your question, Danny, how through innovation we could have all these multiple capabilities to serve farmers. As I was chatting with Pedro, here, a farmer that began conservation agriculture, we were saying, well, we need to help to take these to the farmers so it can go massive, and this is our core responsibility and our strategic vision. How we do it and which are these innovations, I say it here at a macro level, but everything has a field program. So first, I must say that we have a platform to have a most accurate agriculture. This is what we call digital agriculture. It is not enough to write conventional agriculture. We were used to it, and this is where soil recarbonization begins, because we were following different practices and we realized we need to recarbonize, and this is how we promote different practices. Digital agriculture for us is a strategic strategic cross-sectional technique so we can accelerate this and make it possible. There is a platform that is called MacroWive, and I will present earlier. Also, the next item, the next bullet is technological agronomic inputs. This is a matrix because it's not enough. The protection of conventional crops is no longer enough. What we need more, and we are promoting this in the field, and this is the matter of having so many partners and farmers, is how with the crop, traditional and conventional crop protection, it can be integrated and blended with new technologies like biological products or inputs or mycorrhizas. Like with Syngenta, maybe this is not part of the public mind of our line of work. This is one of our proposals. In order to reduce the chemical loads that there are, in order to have a specific attention to the crop, understanding the whole ecosystem across the value chain in order to have an ad hoc program. This requires a lot of complexity, but this is where our proposal lies. And also as Syngenta, we partner with the National Livestock Council to have this macro level and our input. And also high performance seeds, as mentioned in another panel. Biotechnologies is a global tool that is part of all of these technological matrix. And also here, regenerative agriculture, because growingly we are promoting this in the field in order to measure the microbiota, placing all these practices and trying to go massive in the different production hubs with small farmers, middle-sized farmers, large farmers, exporting farmers, and together develop sustainable solutions. We have integrated this into a platform that is called Horizonte Sostenible, and this is our vision for the long term, sustainable in 3 pillars: environment, economic, and social. But ESG, but how we started this to make it a reality today. This is our proposal with innovation, and this is our contribution of this, and we have heard about data. It is critical to understand the baseline of soil, and then we can place the different regenerative agricultural practices like soil rotations, conservation, agriculture, and measure it, place it in a platform in order to measure progress and to have proof across the value chain from the primary stage to do so. We have this platform that is called crop-wise sustainability, and this is one of the modules we have, and this is easier for the farmer. It's easier to measure. We advise including the value chain, and we hope the industry will use these. Heineken is here, and Miguel, this is a success case we have on the field. He will talk about this, and this is a platform to have on-site measures so people in field can have real-time decisions. Last but not least, we also launched this standard, which is SOA, Sustainable Outcomes in Agriculture standard, that is regarding FSA 3.0 standard from SAI. These are international standards, and we are adding to these, but not only as stakeholders, we are leading this agenda to make it possible. So with this, to save on time, we are transforming agriculture. This is a reality. We are putting this into practice in the field. These are some pictures that show, as Bram was saying, one of the example are functional margins to increase biodiversity, and all of these together as Horizonte Sostenible or Sustainable Horizon, and this is for the benefit of farmers and agri-food chains. Thank you, Danny. No, thank you, Patty, for this brief introduction of what Syngenta is doing today, the potential of carbon sequestration and the horizons that we will be able to explore. If I may, now I will make some introductions and then we'll continue with the conversation. And now, Miguel Ángel. Miguel Ángel Esquivel, he is Materia Laras, Grajales, barley production. He is a graduate from the School of Sciences, also a master's degree from Agadis, coaching for high-performance teams from IPADA, and more than 25 years of experience of Heineken Mexico, where he is the lead of the Barley Committee and an active participant of the Strategies of Production Program Excellence Center in Maltese Heineken and implementation of net zero via in malt and barley production. Also, he is certified in ISO 9000 and raw materials. So he has broad knowledge on control and processes and critical points management. So with this background in his participation in Heineken Mexico, I would like if you could tell us about the efforts and progress that you as Heineken are implementing. Which are the priorities for decarbonization? Which are the challenges? Which are the challenges that you face in the recarbonization of soils and decarbonization of systems? Thank you, Patty. I am honored to be here.
Bien, como decía, en
la
parte introductoria, Patty, creo que los retos
as in the introduction, Patty was saying, I don't know if you can see the presentation.
Nosotros, dentro de como Heineken México,
as Heineken Mexico, we have a strategy that we call Provide a Better World, Brindar un Mundo Mejor. We want to raise the bar in our demands. We were talking about, Eduardo Torres was sharing that we should promote a change of mindset. At Heineken Mexico, we want to improve our habitat, contribute to its preservation, and we assess our value chain. We assess what we call from the field to the bar, and in each production stage, we have estimated the carbon footprint emission per component in order to concentrate efforts and address the different scopes, 1, 2, 3, accordingly. So I would like to elaborate on scope 3, which is agriculture for Heineken Mexico. The agriculture scope represents 21% of emissions, and the goals we want to achieve by 2030 is to have less than 30% of these carbon footprint emissions and reach neutrality by 2040. We want to be one of the brewing companies here in Mexico with more tradition but leadings of the sustainability agenda. We feel responsible with communities, with farmers, with our stakeholders. This is our mission. How are we doing this? First, in our country, Heineken Mexico produces more than 50,000 hectares of barley across the region. And of these hectares in production, close to 40% of our farmers are being trained and developed in an international sustainability certification. They are being trained, they are being coached, and we help them implement practices in their daily activities in order to change their mindset, as we heard, to raise the needle, move the needle, and change traditional practices for conservation agriculture practices. Not only we certified, someone said this is not all about them. We also contribute with advisory services, consulting services, so they can have a more expedite transition. Something about our Mexican agriculture field is that there is no social security. Our farmers working for Heineken Mexico, those that are certified, their employers and their families have social security, and this is a scheme that will change the landscape of Mexico's field. And second, not only we help them to implement practices, we conduct auditing exercises so it will be a true change and not only a good vision or a strategy. And lastly, today, we want to close this year, 2024, and almost 40% of our farmers will be certified. Some of the people here are one of our certified farmers, and I think this is a really important task. The third line that we do is migration of fertilizer sources. If we talk about carbon footprint in agriculture, the most important component that contributes to the emission of greenhouse gases is the use of chemical fertilizers. From Heineken Mexico, we promote the use of low technology fertilizers to cut down on these emissions for our carbon footprint, and this will help us improve the habitat where we grow these crops and increase productivity. To date, more than 30% of our area is using these emissions and will impact the 20% of emissions we generate across the value chain. Another example of one of the activities we conduct, and is a success case, and it is our program Cultivando un México Mejor, which is growing a better Mexico. And along with CIMID, we are implementing conservation agriculture following three principles: minimal soil movement, permanent soil cover, or increments of organic matter, and crop rotation. During this process that we have developed along with CIMID, we have reached good results in terms of an efficient water use, efficient fertilizer use, reduction of agricultural machinery, but also increase the profit for our farmers and the quality of their production. This is an example on how these strategies and production techniques may be the key that will lead us to the decarbonization of the Mexican field. Obviously, this is not an easy task. It requires a different mindset, but also enablers. And a very powerful enabler that we use to achieve this decarbonization at Heineken Mexico is we use the 4R principles for agronomy, but we also use the experience and knowledge our farmers have to help them now through technology to potentialize this expertise and transfer this knowledge with strategic items. What we are using, if we think about any crop, not only barley, we have a traditional way of growing the crop. We have line by line a recipe of NPK fertilizers. Then the crop, we measure it only by visual observation, and in many cases we don't visit every plot, or we just see the average behavior of the crop. We also have crop protection without difference in preventive or corrective doses for all hectares. And we also have weather monitor only for a small period of time. So we are using digital tools to measure soil fertility, everything that we call like variable rate. We are reducing concentrations and doses of fertilizers, macronutrients for barley production through an early or timely detection of the needs of the soil. Second, through satellite images and sensors, we monitor the development of the crop, so farmers will not invest their time in plots that are okay, do not need further attention, and instead of that, they can dedicate more time to those that need it. In terms of irrigation, we also use satellite technology to go from the irrigator experience to have a more uniform irrigation that will help us potentialize the yield. And also crop protection, it is not less important. We use some agrochemical and other products, but we also want to migrate to products with better technologies that will help us lower the doses and in a preventive application. And last but not least, important, climate. We know that the climate effect is like an obstacle for our economic activity, not only in the field, but across activities. And we must monitor because temperature and cold and rain seasons are changing, and this will change our plowing date or not. Today, we need to use technologies to set plowing dates according to microclimates and different weather conditions across regions. This is just some examples. These are actual data of some farmers at the Bajío region, and instead of giving all of our attention to plots that are okay, we only tend to those that need more attention, helping them improve their crops. We can have applications like Patty was saying, crop-wise. We also monitor weeds or diseases on different regions, and this helps us to do a customized package per region instead of a standard doses across crops. So also important, there was a question to Carlos, why conservation agriculture has not progress. I liked his answer, but I would like to add that not only is the change of mindset, investment, and crop rotation, we need to have to grow critical mass in the value chain. All stakeholders, primary, secondary, tertiary, we should have the same concept, promoting these practices. It doesn't matter if it is Nestle with their products, Syngenta or Heineken, if it is wheat or other. We must begin speaking the same language, because one of the most amazing cases that we have is that most of the farmers, they do not own the land, and when they lease the plots, they don't want to invest. But if across the food chain we start speaking the same language, the same vision forward, I think it will be the starting point of significant change. And this is all I have to present. Thank you very much, Dani. Well, thank you, Miguel Ángel.
Muchas gracias, Miguel Ángel, por
And
resumirnos
thank
en ese
you,
sentido
Miguel
los
Ángel,
desafíos y
for
también dejarnos algunas
summarizing the
encomiendas ya
challenges
con
and
esto. Muy interesante
also
también lo que nos compartes en cuanto
giving
a
us
esta parte de la masa
strategic
crítica y
ideas.
poder
This
hablar de este
last one
tema a lo
about the
mejor con
critical
palabras un poco
mass
menos,
and to
menos
be able to
elaboradas y que sea mucho
discuss
más fácil para
this,
que todos podamos
and
entender,
perhaps
¿no?
it will be
La
easier for
importancia
us to
de este tema.
understand
Muchísimas
the
gracias.
importance on this
Ahora
topic.
te doy la bienvenida, Alfredo,
And
por
now,
favor, para que nos puedas
Alfredo,
compartir desde
welcome.
tu rol.
Perhaps now I think it's time that
Alfredo Reyes es gerente senior en la unidad
from your
agropecuaria
role, but
regional de
let me
Latinoamérica de Nestlé
introduce you.
México, egresado de la Universidad
He
Autónoma de
is
Aguascalientes de la carrera de Medicina
a
Veterinaria y
graduate
Zootecnia.
from the
Tiene
Aguascalientes
39 años trabajando en
University as a
Nestlé México en el área
veterinarian
agropecuaria,
medicine.
gerente
He has
senior
been working for
en esta
39
unidad,
years
con
in
experiencia
Nestlé
en manejo de las áreas de
Mexico,
compras en lácteos y asistencia técnica a
experience in
proveedores de leche,
purchases in
suero,
dairy
frutas, cereales y
products and
vegetales.
technical
Ha ocupado
assistance
diferentes
in
cargos en el
milk,
área agropecuaria y
whey,
actualmente como
fruit,
responsable
cereals, and
técnico para la región
vegetables.
Latinoamérica.
He has held
Tiene a su
different
cargo el desarrollo de
positions
materias
in the
primas para los productos
agro-livestock
infantiles de la
in
marca
Nestlé
Gerber, que
Mexico.
muchos de ustedes seguramente
Currently,
conocen y han consumido
he
en algún
works as
punto de su vida,
responsible
que se
for baby
producen en
food from
fábricas de
Gerber,
México, Europa y Estados
manufactured
Unidos.
in factories from
Asimismo, es el
Mexico,
encargado de
Europe,
llevar a
and the
cabo la
US. Also,
implementación de
he
prácticas de
is in
agricultura
charge of
regenerativa
taking the
con los proveedores de
implementation
cereales,
of
vegetales y frutas para la
regenerative
categoría
agricultural
Baby Food
practices
y la
with
categoría orgánica de
vendors
Nestlé
from
México.
cereals,
Con
vegetables for baby
este
food and
contexto, si me
organic
permites
from
nada más
Nestlé
ponerte la
Mexico.
pregunta
So,
para que nos puedas
Alfredo,
contar un
if I
poquito más.
may ask you a
¿Cuáles son las
question so you
prioridades en
can
el tema de
elaborate on
descarbonización
this?
de sistemas
Which are the
agroalimentarios para Nestlé?
priorities on decarbonization of
Daniela.
agri-food systems for Nestle?
Y buenas tardes
Thank
a
you,
todos.
Daniela, and good
Nestlé
afternoon,
voy a
ladies and
tratar de hacer
gentlemen. I will try to
de lo macro a lo
go
individual
from
aquí en
our
México, porque
macro
pues van a entender
level
que es
to the
difícil hablar
individual
de todas las materias primas que
aspect here in
manejamos.
Mexico,
Y
but
hoy día,
because I think
pues a
you can
nivel
understand that
Nestlé,
we manage so many
pues tenemos un
inputs.
macro acerca
So
del
in
cambio
Nestle,
climático,
we
pero
have a
hay
macro
una
vision
reflexión
regarding
que
climate change.
desde la
However, there
mañana
is
lo hemos
a
estado
reflection,
escuchando, ¿no? El
and
cambio
as we
climático,
have
todo el mundo
heard all
hablamos, pero pues
morning, everybody
el cambio
talks about
climático no está
climate
esperando
change, but
a nadie.
it is not
Eso está
sitting
cambiando,
waiting
nos
for
está cambiando
anybody.
todo.
It's
Y
changing,
de ahí
it's
tenemos que
changing
generar
everything for us,
muchísimas
and we
acciones
need
y
to
aplicar todo el
initiate
conocimiento. Hoy
several
día,
actions, apply
quizá en mi
all the
presentación vayan a
knowledge,
ver
and
muchos
perhaps in
datos
my
que ya
presentation,
se han dicho
you
aquí,
will
pero
see
nosotros
a lot of data that
prácticamente
has
somos de
already been
una
shared
cadena de
here, but
abasto y
we
es, como bien
are
dicen mis
just
compañeros,
members of a
pues
supply
somos una
chain,
industria de
and
transformación de
also
materias
we
primas de origen de campo. Entonces,
are
como Nestlé a nivel
participants of a
global, lógico
transformation
que hicimos
sector
una
from
hoja de ruta para
agricultural
las
raw
emisiones
materials
y
to
tenemos metas
products.
que
So we
esto,
have a
quien guste
roadmap
en las
to
páginas de
reach
Nestlé
our
están ahí.
zero net
La verdad ya no
emissions.
los
You
alcanzo a
can
ver,
look it
pero
up. You can look
tenemos
it up in our
bastantes metas,
Nestle
pero
website.
una
I think the
reflexión
font
es,
is really
hace
small,
rato
but
Miguel Ángel decía que ellos
as
tienen el
Miguel Angel
2040,
was
nosotros le
sharing, is
pusimos
that their
2050. Y si le hacemos
target year is
cuentas, nos quedan
2040,
25
ours
años.
is 2050, and
Entonces,
adding and
aquí quiero aprovechar
subtracting, we have only
una
25 years
enseñanza que
left.
me enseñó, valga
I
la
would like
redundancia,
to
el doctor
share
Simón
a
cuando vine la
takeaway by
primera vez
Dr.
aquí en
Simon.
México,
For the
aquí al
first time,
CIMIT.
I came
Esa
here to
fotografía de hoy en
CIMIT.
la mañana que pone
That
de
picture
un
that
pedazo de
he
tierra de
shared
30 años que no han
today,
hecho nada
where he
contra
shows
el
a
resto que sí se
plot
ha
of
hecho.
30 years
Pues
where nothing has
imagínense
been done
qué tenemos que
against
hacer
all
en
the
25
activities.
años con
Imagine
esa tierra.
what we need to do in
Hace
25
rato
years
hablaban que
with
en
that
40
of
años subió
those
no sé qué
plots.
porcentaje
Someone
de
told
materia
that 40
orgánica.
years ago
Vámonos a
the organic
limpiar esa
matter
tierra
content
durante los
increased.
próximos
Why don't we
40
turn
años a
it
ver
around? And
si
in
le
the next
ganamos o
40
no, pero
years,
el
let's
tiempo
see
corre
if our
y
gains
los
are the same,
agricultores,
but
igual que
time is
nosotros,
ticking
ya
by, and
las canas nos
farmers,
están pintando.
just like
Entonces,
we
por
are,
eso esa
we
es
are
nuestra mayor
covered with gray
reflexión.
hair. So I think this is our
El cambio no espera y
greatest
nosotros hemos
reflection.
hecho un modelo
Change
holístico
waits
de
for
ver
no
todas las
one.
materias
And
primas
this is
desde
a
la
holistic model considering all inputs, milk, coffee, cocoa. And the pillars that we have is how can we preserve the soil's health? What is it that we need to do? How can we make a good use of water? When we were back at school, people said that gravity irrigation, then spraying. We need to be
la cebada,
customizing
qué
according
necesitas,
to the
el trigo,
needs of
etcétera.
each crop,
Y desde
barley,
luego la
wheat,
biodiversidad,
and
donde
of
veíamos que
course
el doctor Brown decía,
biodiversity.
vieron las
Dr.
mariposas,
Bram says, did you
biodiversidad
look at
benéfica
the
en los
butterflies?
Entonces,
We
todo
need
este
to see
modelo, y
this
ahí en el centro habla del agricultor, sí, muy
beneficial
importante,
diversity, and at the
pero
center
igual
of
que
the slide, the
nosotros,
farmer.
una
Yes,
agroindustria,
he
no
is
estamos
important,
solos.
but we,
Igual
as an
que el agricultor,
agro-industry,
y si
we are
todos
not
le
alone,
queremos echar
just like the
la
farmer.
responsabilidad al
And
agricultor,
if
que nos vamos a
everybody
equivocar.
wants to assign the
Somos una cadena de
responsibility to
suministro
the
desde el
farmers, we will
agricultor,
be
el dueño
mistaken.
de la tierra, el que
We
la
are a
renta,
supply chain of
la
vendors,
escuela o la
the farmer,
universidad,
the
la
owner of the
ciencia,
plot,
todos vamos de la
schools,
mano.
universities,
Y si no
sciences,
ponemos esa cadena
scientists, we
en este
all
modelo holístico,
are together
algo va a fallar
holding
y
hands.
eso no
And if
nos
we
sirve
are
para el
not
futuro ni para
take
el presente.
responsibility of our part
Igual,
in this
lo
chain,
mismo,
everything will
los
fail.
beneficios de
And
todo esto que
also
ustedes
the
pueden ver,
benefits of
retención de agua, sistemas
everything
radiculares,
around us. You
etcétera,
can read
infiltración
it,
de
water
drenajes de agua, todo
retention,
esto
root
tenemos
systems,
que ver y
all of
pensar y
this. We need
reflexionar
to think
cómo
about it
vamos a
and
cuidar
reflect
el
on
suelo.
how
De ahí viene
are
todo.
we going to
Todo
look
viene del
after
suelo.
the soil, because
Es para allá.
everything comes
Y en
from
la
the
mañana
soil.
hablaban aquí ya
And
del trabalenguas
earlier
de
today,
recarbonización
there
y
was a tongue twister,
descarbonización. Lo quise poner por ahí,
recarbonization,
como viene,
decarbonization. I wanted to
léanlo,
include it
pero
here. Please
finalmente es
read it,
quién lo produce y quién lo va
because at
a
the
quitar.
end of the day is who
Entonces, ubiquémonos
generates
cada quien
this
como
and
industria en
who
donde
will
estamos,
remove it. So
el
as
qué es
an
lo que vamos a
industry,
hacer para
we
devolver
must realize
ese
where
carbono
we
al
are
suelo, quitarlo
standing,
de
what
donde
is
lo
it that
tenemos
we
hoy
are
día.
going to do
Y
to return
todo este
carbon to the
modelo que
soil.
estamos siguiendo en
And
este
all this
de
model that we
descarbonizar,
follow to
vamos a
decarbonize,
ver qué son las prácticas
we
para
need to
descarbonizar. Nos vamos de lo macro ya a lo
see
particular.
which are the
Y hay una
practices
palabra que
for decarbonization, from macro
empezamos con eso que se llama
to
agricultura regenerativa.
decarbonization.
Y ya todo
And
el mundo
there is
puede
a
poner
term, regenerative
las
agriculture, and anybody
definiciones. Hoy ya
can
no existe una definición per se. Cada quien puede
propose
hacerlo, pero
their own
esa
definitions.
palabra,
There
ese
is
par
no
de palabras
specific definition, but
significan
these
mucho.
two
Que
words
tenemos que
mean a lot
concientizarnos
that
nosotros como
ha
industria,
has to do
concientizar a
with
nuestros
our
proveedores y
awareness
concientizar
as
a
an
nuestros
industry,
consumidores
create
de
awareness
todo lo que
in our
tenemos que hacer
vendors,
para
create
obtener
awareness
una
in our
materia prima
consumers of
que
everything we
finalmente se va a
have to
convertir en
do
uno de
to
nuestros
have an
productos
input that
como
will
materia prima
transform
de un trigo hasta
into a
para un bolillo,
product,
o un
perhaps
pan o
a
para un
plot of
cereal,
wheat that will be
etcétera, pero
transformed in a
todo
loaf of
indica
bread
qué
or a
estamos
bowl of
haciendo
cereal.
desde el
But
campo y a quién
everything
se lo estamos y tenemos
is
que
about
enseñarle
what
lo
we
que a
do
nosotros
in the
nos han
field,
enseñado.
and we must
Nosotros
teach
somos
them
una
what
industria
we were
que hoy
taught.
día nos
We
sentimos
are
muy
an
orgullosos de
industry that
participar
we
en
feel very
organismos como el CIMIT,
proud to be
con el ICA.
collaborating
Tenemos
with
relaciones muy directas
bodies like
con
CIMIT,
la
like
banca,
ICA, with
con el FIRA desde hace muchísimos años.
the banking
Entonces, todo
sector,
esto,
with FIDA.
alguien tiene que
So
empezar,
someone
alguien tiene que
has to take
continuar
the
y ser
first step,
permanente, porque
someone
también
take
hay
the
una
next
realidad. El
steps and be
campo,
permanent,
los dueños
because there is a
son
reality.
generacionales. Y el reto mayor
The
aparte de esto,
owners
tenemos
of
que ver
these
las
in the
nuevas
field are
generaciones
different
que se crean en el
generations,
campo.
and we must pay
Si no
attention
hay
on the next
gente trabajando
generations
en
that
el
will
campo como
work
dueños
the
o mano de
fields.
obra,
If
créanme
there
que va
are
a ser muy
no
difícil
people working the
implementar cualquiera
fields,
de estas
it will be
prácticas.
really
Es para allá.
difficult to implement
Y en
any
este
of these
simple
practices. So
esquema,
in
hoy día
this
hablamos de
simple
2, 4, 5
scheme,
esquemas.
we talk about
Todo
2,
lo que hemos
4,
hablado,
5 schemes.
coberturas, mínima
Everything that
labranza,
we have talked about, minimum tillage,
el personal
cover
de
crops,
FIRA, si más no me acuerdo, no sé si estén.
the
FIRA, desde que yo
people
salí de
from
la escuela ya
FIDA,
hace
ever since
algunos
I
ayeres,
graduated
ellos
from
decían
school
mínima labranza,
several
no es que
years
era,
ago,
por ahí era
they were
la
always
palabra.
talking
Y
about
vean,
this minimum tillage.
ando sobre los 40 años
And
en esta empresa, yo sigo
I
hablando
have
de,
been
oye, le
like
puedo poner
40
mínimo tillage si
years
quieres,
on
pero
this
sigue siendo lo
company,
mismo.
but it's
Quizá
the
esto
same
se vaya a
concept.
aumentar, no sé, o
Perhaps
se vaya a
this will
disminuir, pero
increase or it will
todos los
be
compostajes, la
decreased. I don't know,
cobertura del
but all the
suelo,
compost
que debe de estar la mayor parte del
soil
año
cover
cubierto.
that
Y eso es lo que
should
tenemos que
be there
entender.
most of the year,
Porque hoy
and
día
this is
vemos
something that
que
we
crece el
must
pasto y
understand because we
la
see
podadora, ¿no?
the grass
Y
is
eso tenemos que
growing
enseñar y
and
ver
we need mowers to cut the grass, but these pillars are the foundation of what science teaches us to preserve the health of the soil. If we practice this, we will have regenerative agriculture applied when where it should, by who should do it. This is a cycle, this is a circle. Look at it as a circle. So the first two pictures, how many of us have we seen a clean field, clean of everything like that? Nothing growing there. And people say that they like watching their plots like that, and it stays like that for 6 months. And along with CIMMYT, we are trying to promote the image from the second picture, where we are sowing on what was left in the field, and with this we continue, and to close the circle we will sow or plant the next crop with what is left from the previous crop. So decarbonization, I think, is apparent in the clean field, but we need to recarbonize like it is shown on the last picture. Regardless of the crop, we will have better yields at a lower cost, as presented by the previous speakers. So there's the business there, but let's forget that the soil is the source of the 5, 10, 15 tons of wheat or maize, because we need to preserve soil's health, biodiversity, and structures of the soil. So this is dedicated to climate change, and science will teach us to have better, more resilient crops, water management. If it is micro spraying or other techniques, we will need to learn from them and further our research to apply this in the field. So there are so many things, and whatever we do in every country involved globally in Nestle, to introduce it with every input. Tomorrow we will see success cases. I wanted to share our success case with CIMMYT. We are really happy with that. We have been working for 3 years with wheat growers in Abasolo, in Guanajuato. We are benefiting small farmers, not only for their purchase, but we have reduced CO2 emissions through their wheat crops. So this is a success case, very important for us. That is why we feel we are brothers of CIMMYT, because we work applying the knowledge generated by CIMMYT with our vendors. And this is a call for action. Let's read it, please. What is it that we need to do? We need to support each other across the value chain, regardless of our size. All the companies, we rely on the soils, on farmers, on animal breeders. So we need to build our present, the future, with sustainable agri-food systems. Thank you very much.
Muchas gracias, Alfredo, por esa.
Thank you, Alfredo, for your presentation and the context that you share. I see that there are more than 200 people online, and here also we have an audience. I want to give time to all of them to ask questions, but I don't know if you could give us a comment because
Entonces,
you
en ese
mentioned
sentido, no es quién
your
gana, no es
target
quién va más lejos
year
y quién puede ver
2040,
más lejos, quién
2050.
está más alto.
Here in
Pero en
CMIT,
este sentido sí
we
es quién
went up
puede
really far, 200,
pensar y estructurar de la mejor
2010.
manera hacia el
But
futuro, y en ese
how
sentido también
can
nos
we
enorgullece
better
esta alianza
structure
que
our
tenemos con el
future?
ICA,
And
con
that is
FIRA,
why we
porque
feel
son
so
capacidades
proud
que
with
no
our
tenemos tampoco,
collaboration
¿no?
with
Entonces
ICA
creo que
and
vale
FIRA
mucho la
because
pena entender
these are
cuál es el rol
capabilities
que
that we
jugamos
don't
cada
have. So
organización, cuál es el rol
it's
que podemos
good to
jugar cada
understand
organización,
the
que
role
podemos
we
poner en la
can
mesa y qué nos falta, ¿no?
play as
Entonces
an
escuché mucho de
organization
esto
and what we
en
need
sus,
to
en sus
do. I
conversaciones, en sus
was
pláticas,
able to
y con
hear
esto
these
me
in your
gustaría preguntarte, Alfredo, ¿qué
presentations. And
incentivos son
Alfredo,
los que
I
le
would
han
like
dado a
to
los productores en
learn
ese
which
sentido
are the
para que puedan adoptar
incentives
esto? O sea, nos
you
hablabas de tengo
give to
40 años
farmers for
escuchando
them
la
to
labranza
adopt, because
mínima,
you
tenemos
said I
todos
have
mucho
been
tiempo escuchando que
listening
hay que
minimum
hacer
tillage
ciertas
for
prácticas.
40
¿Cómo le
years.
hacemos para ese
How
cambio?
can
¿Qué
we do
incentivos han
that
hecho ustedes?
to promote change? Which are
Gracias.
the
Desde
incentives
luego, como
you
empresa
give?
privada
Well,
tenemos
as a
que
private
compras de
company,
materias primas, ¿no?
we
Entonces,
buy inputs.
nosotros tenemos que incentivar la
So we
producción
must
de la materia
incentivize the
prima X,
production
¿no?
of any
Todo se
input.
basa en que el productor
Everything's
vea un
about
beneficio.
farmers'
Tenemos desde la leche,
benefit.
en
We have
donde en la
milk,
cuestión de control de un par de enfermedades que hay
or
en el ganado,
there's
brucela,
the need to
tuberculosis, desde ahí
control some
empezamos.
diseases on
Financiamientos,
cows, brucella,
conectamos
tuberculosis,
a los
funding.
proveedores
We
con
connect
financiamiento,
vendors
con
with
instituciones de financiamiento,
funding
con nuestros propios
institutions
recursos.
with our own
Estamos
resources as
incentivando
well. So we
precios de
incentivize
nuestros propios productos. ¿Para
the
qué?
price of our
Para que
products.
además del costo
So
per se de la
not
materia prima,
only there will
por eso
be
se llama
the
incentivo, que los
cost
proveedores no
of
nada
the
más
input,
vean
that is why
que
there
si le
is an
das 1, 2,
incentive.
3 o unos
So
centavos, no, eso no es.
farmers and
Simplemente es
breeders
que tienes que
will not
hacer
pay attention in the 2 or 3 cents. No,
una producción
they will
estratégica, incrementas
consider
volumen,
strategic
incrementas
production,
lo que
increasing
el
volume,
productor realmente se lleva a
or
la
we
bolsa
increase
y gana en
what
el
they
año.
take to their
Entonces,
pockets and
el
their
hecho de
yearly
monetizar sí
income.
se puede hacer,
So
pero nosotros
yes, we
siempre
could
hemos ido de la mano
monetize,
en
but
donde
we
un
have
productor si tiene una
always
hectárea, ¿por qué no tiene dos?
have said if
Yo creo
a
que ese es el mayor
farmer or
incentivo
breeder has
de
1
qué?
hectare, why don't
Del
they aim
mercado.
for having
Tú
2?
puedes producir
So
un
because
kilo
this
más
is a
de
good
grano, el
market
día que
incentive,
quieras,
maybe
pero
you
si no hay
can
quien te lo compre,
have 1 more
entonces
kilogram
esa
yield,
es
but
parte
who
del
will buy
incentivo
it
de la
from you?
producción,
So
que
this
tú
is also
tengas un
part
aliado a
of the
quien te compre.
production incentive. There is a partner that will
Muchísimas
buy their
gracias.
excess. Thank you very
Alineado a esto que
much.
nos compartes
And
y
aligned
el
to
tema del
this
incentivo económico
and in
siempre es algo. De
economic
hecho, una de las
incentives,
preguntas que tenemos acá en
this
línea va
is one
justo
of
muy
the
alineado a esto. Y
questions
entonces,
presented
Miguel
online.
Ángel, regreso también
So Miguel
contigo.
Ángel, with you.
En CIMIT nos hemos plantado
At
también el
CIMIT,
objetivo de
we
pensar en las
set
trayectorias de vida
the
de los productores.
objective
O sea,
to
no
think
solamente hablar
about
de lo que el productor tiene que hacer ahora, sino de entender que estamos en un proceso de
the farmers'
acompañamiento en
lives,
esa trayectoria de
and
vida,
not
¿no?
only
Así
what they
como
have
todos
to do
estudiamos,
today,
después
but also
tenemos,
about their
hacemos
lives.
familia, luego
Like
hacemos lo que sigue y lo
we
que
go
sigue,
to
luego los hijos
school,
tienen que ir a la
we
escuela,
build
etcétera,
a
etcétera. La
family,
vida va
we have
avanzando. Entonces, en
children,
ese sentido,
and life
me gustó mucho lo que
continues.
nos compartías
So in
acerca
that
de esto,
sense, I
de hacer que no solo sea el
enjoy
incentivo
hearing you
económico hacia los productores, sino también
saying
un tema de
that
seguridad
it is
social.
not
Entonces,
about
con
an
esto en
economic
mente,
incentive,
no sé
but
si nos
also
puedas
now
compartir un
social
poquito qué es lo que
security.
hacen
Now, with
ustedes
this in mind,
desde
could you
Heineken
share
con el
what
tema de la cebada
is
sustentable, cómo
Heineken
hacen este
doing with
cambio de
sustainable
mentalidad también
barley?
con los
How is
productores,
this
que me imagino que la
change of
primera pregunta
mindset
es
with
textual como
farmers?
la
And I
tenemos
think
en
that
línea, si
the
estás
first
pagando mejor la
question
cebada
is if
sustentable o
you
no,
are paying more
pero ¿cómo le
for
dan valor a
sustainable
a este
grown
tema
barley or
adicional de,
not.
ok,
So
tenemos
how can
seguridad
you
social,
assign
tenemos
this
cosas de largo
value
plazo,
because they
a
have
largo, o sea,
long-term
cómo están
benefits
dándole
like
ese
social
peso a estos
security?
beneficios de largo
How
plazo
are
que
you
no generan o
weighing
no
in
representan
these long-term
un valor
benefits
inmediato?
that are not
Sí, Diana, con
reflected
gusto.
in an immediate
Quisiera
value?
iniciar
Yes, of
respondiendo
course. So
nosotros tenemos claro que el centro
I would like to
en la
say that
parte
it is
agrícola de este
clear
escenario,
to
de este
us
producto,
that the farmer is at the center of all of this. So what are we doing for it? We want them, our farmers, to grow barley as a profitable crop. So every time we are with them, we are always taking into consideration their production costs, their practices, the inputs they need. They need to have a clear picture of the challenges they face. We use a lot of public information. Our friends from FIDA they
de costos de
publish
producción.
these
Entonces, utilizamos toda esa
packages of
información para
production
poder
costs.
calcular
So we
los
use this
costos rentables que
information to
tenemos
calculate
para producir una tonelada de cebada.
a profitable
Segundo,
cost to produce 1 ton
nosotros
of
nuestra
barley.
visión es que el
Second, our
100% de las
vision
materias
is
primas que
that
utilizamos en el país
all
se produzcan aquí
100% of
en México.
inputs we
Y eso
use here in
es algo que
Mexico
siempre vamos
are
a
grown
privilegiar
and
sobre
produced in
cualquier
Mexico. This
otra
is
importación
something
de
that
grano.
we will
Evidentemente, el
prefer
cambio climático a veces
over
no
any
nos
other
da oportunidad de producir
imports.
todo lo que queremos en
Sometimes
el país y tenemos que recurrir a
the
otras fuentes,
country's
pero siempre nosotros
production is not enough
promoviendo el
and we
desarrollo
need
de
to
los
find
productores.
other sources,
Segundo,
but always thinking
certificar a
in
los
mind the
productores no
development of
solamente es llegar
farmers.
con ellos y
And
hacerles un examen.
next,
Hay que
to
hacer todo un
certify
proceso de
farmers is not just
entrenamiento,
to
de
go with
compartir
them and
prácticas.
have
Hacemos
an
sinergias con
exam.
otras
No,
empresas,
we
por
train
ejemplo,
them.
la empresa
We
Singenta. Nosotros
partner with
dentro del
other
SAI
companies like
tenemos que entrenar
Syngenta.
a nuestros
In our
productores
side, we
para el uso,
train
el
our
buen uso y manejo de
farmers
agroquímicos. Nos
to
ayudamos con ellos, que son
properly
los expertos
use
para
and
estos
manage
procesos. Hacemos
agrochemical
alianzas con
products. This
Agricultura
is done
Digital,
with the
desarrollamos
experts.
sus
Also,
competencias
we
con sus proveedores,
develop
con sus
their
trabajadores, para
competences
poder
to practice
incrementar
digital
su
agriculture in
conocimiento.
order
Y
to
no solamente para
increase
nosotros,
their
porque una vez que
knowledge. And not
ellos
only
certifican,
for us,
están
because once
certificados
they
con
are
un estándar
certified,
internacional
they are
y sirve ese
certified on an
estándar para
international
cualquier
standard
cultivo que
and they
ustedes
can
produzcan.
use it
Entonces
in
también
any crop.
creemos que esa es una
So we
aportación.
believe
Todos los
this is
servicios
a
de
good contribution.
certificaciones, los
All the
servicios
services
de
for
consultoría,
certifications,
desarrollo de competencias,
consulting firms,
Heineken México
develop
está absorbiendo todos esos costos para que el
building
productor
of skills.
pueda dedicarse
Heineken does
directamente
that to
a lo que es la
support them
etapa
so they
productiva.
can
Y contestando la última
dedicate
pregunta,
to the
sí,
production
creemos
activity.
que
And the question
aquellos que tienen ese
also
cambio de
that you
mentalidad,
ask, those
aquellos que
that
hacen las cosas diferentes y se
change their
esfuerzan
mindset,
por marcar
those
un
that do
cambio en la
things
forma de producir,
different and
también merecen ser
work
reconocidos.
hard, are changing the
Y
way
siempre
they
reconocimiento
practice
en desarrollo, el
agriculture should
reconocimiento verbal,
be
creo que es
acknowledged.
importante,
And
pero
this
también
verbal
la rentabilidad
acknowledgement
cuenta para ellos.
is
Y nosotros,
important, but
nuestros
also
productores que
a
son
profit
certificados en
counts
este
for
estándar
them.
y que
Our
están
certified
mejorando prácticas
farmers
para
that
mejorar
are
la huella de
improving
carbono,
the
huella hídrica,
practices to
tienen un precio
improve
diferenciado en
the
el pago
water
del producto
print
que estamos
or carbon print,
desarrollando
they
con ellos.
have a
Muchísimas
different
gracias,
price
Eugenio,
selling
por
us
por
the
esa
product.
respuesta
Well,
también,
thank
por
you very
esa,
much for your
por ese
answer.
mensaje también para poderle dar un
Thank
valor
you.
económico también
Thank you
a lo
because there
a lo
was
que se
a
puede
message
proveer
in your
y
answer
resaltar también lo que la
stating
empresa
that there
está
is
cubriendo,
economic
¿no?
value
En
and
este
also
sentido.
for
Tenemos ya
highlighting
varias
what the
preguntas
company is
de la
doing. Thank
audiencia
you.
y ya
We
nos
have several
convirtiendo
questions
que
from
también
the
tenemos poco
audience,
tiempo.
and
Entonces,
also I was
para
sure that
poder
we
cubrir
don't
las
have a lot
diferentes
of time
preguntas.
possible.
Pati, quería, justo
So,
me llamó mucho la
Patty,
atención lo que nos compartías de este enfoque
regarding
de
what you
ciencia,
shared
de
on this
innovación
approach
y
to
de cómo
science
podemos
and
realmente
innovation
empaquetar todo
and
esto
how
de
we
una
can
manera
bundle
atractiva y creo
it
que
in
se
an
relaciona
attractive
mucho con una
way,
de las
I
preguntas que
think
nos
it
hace
relates
el
to a
público, que es
question here from the audience
primero
that
un
says,
comentario muy
first,
interesante
a
todas las
comment
charlas.
that
¿Cuál es la
all the
herramienta más útil que han
presentations
detectado para
were
la
very
adopción de agricultura
interesting, which is the
regenerativa?
most
¿Qué
useful
herramienta
tool
consideran que sea
for
útil, pero que
regenerative
vale la pena y
agriculture,
necesite
which
aún
tool is
lograr un
useful
poquito más o
but
tener un poco más
needs
de potencial para desarrollar?
further
Entonces, no sé, Pati, si nos puedes ayudar con
development
eso.
for
Sí,
to reach its
gracias. Y
potential.
primero voy a hacer un
Patty,
paso atrás
well,
porque quiero
thank you.
reconocer
First, I would
mucho
like to take a
tanto
step back
Miguel, Alfredo,
because I want to
Heineken y Nestlé. Qué padre
recognize
que
Miguel and
me tocó con
Alfredo,
ustedes el panel,
Heineken and
porque
Nestle.
nosotros buscamos ser
I am
estos
happy that
aliados
I shared this
estratégicos con la
panel
cadena de
because we
valor
want to
que
be
conecta al
this
agricultor con las
strategic
prácticas
partner
de
across the
agricultura
value
regenerativa,
chain,
justamente
connecting
con
the
la
farmer
innovación, y ya
with
respondo,
regenerative
y
agriculture, with
potenciar esto, ¿no?
innovation,
Entonces, aquí
and
es un ejemplo de
potentialize
cómo sí
this.
lo
So this
podemos
is an
lograr juntos.
example
Hay mucho más
of
por
how
hacer,
we
pero
can
ya
do
nos
this
da
together.
unos
There is a
buenos
lot
casos y
more to do,
experiencias en
but
nuestro
we have
país, en
good
México, de
experiences
que
and
sí lo
examples
podemos
in
lograr,
our
y aquí hay
country,
unos casos
Mexico,
de éxito buenísimos de cómo
that
conectamos
this is
agricultor,
possible.
innovación,
And we have
servicios, y lo
examples on
llevamos
how we
incluso
connect
hasta
the
nivel de
farmer
consumidor con
innovation,
ustedes. Entonces,
services and consumer with you. So I am honored to be here. And when I approach innovation and science, for innovation, I reiterated at Syngenta, we want to diversify, bringing more innovation, being more efficient. Perhaps farmers only use 5 grams of a product, and there is less crop protection, less agrochemical product, but perhaps the practice is more efficient. So We always hear less agrochemical products, but also it will be with a more efficient use, because it is not like demonizing agrochemical products. No, we have this practice. That is why science, because you can hear 5,000 researchers plus partnerships working in last generation innovations, so agriculture will be more sustainable. Syngenta is launching this. And also the use of biological products. There are some biostimulants, and even when you mention wheat, we have data that a product helps increases yield in 4%, but also reduces emissions. And this is a progress of how we measure and how with the aid of technology we can complement with regenerative agricultural practices. And the trigger that we must have, I need to refer to this change of culture and mindset, because this is something that is promoted through training workshops, and perhaps this is an advertisement. We are promoting this across the value chain in the field, and also there is a platform which is free of charge, proagricultor.com, strengthening skills in the field, taking more information with our technicians, but this is an educational aid. So we take these practices to the field. We needed to study and understand each ecosystem. First, the soil, the microbiota and its behavior, measuring it, and the practices that make sense, if it is crop rotation, because we should never forget the water issue. It should be considered in these practices. It is how we have this holistic view of the ecosystem and partner together with collaboration between universities, the academia, the private sector, the national agro-livestock sector. So we must act together. This is how we measure in the field: crop rotation, tillage, field technology. Without demonizing, we need to make a blend and measure it. Well, thank you very much, Pati. I have an issue because the next questions are really interesting. So I apologize to the team because it will take longer. The question is really interesting and it is open to any of you. What can we do as young farmers that will take charge of the field in the future, but we are not staying in a control position? Well, I think that a connection point with younger generations in the field is digital agriculture. I think this is an appealing way for new generations to see how they can leverage the knowledge conveyed by older generations, linking it with science, and they can begin with these targeted data analysis, because new generations are not imposed to work in the same path always. We need to work on a more inclusive and fair way. Try to bond with your parents, with your grandparents that are in control. Show them how some technologies or information can help them improve their production, because also what they teach us or teach you is very powerful. I would like to add also sharing good experiences, how the new generation, they say we are gaining bits by bits. So it all depends on the size of their production. They say say, hey, Dad, why don't you give me this number of hectares so I can make a trial of a model? And I say, fight for your beet. Perhaps you will not change the whole system, but if you begin by a little bit, you will have like a demonstration plot, and you begin measuring, placing technology, learning, convince yourself in the field that it can be doable. So I think that this is like a practical side of things, trying bit by bit, so they can gain their share of their exploitation. Yes.
Pues sí, miren, yo creo que es los jóvenes nos tienen que buscar.
I think young
Porque hay
people
muchas
need to
oportunidades dentro de la
look
industria.
up us,
Y lo
look
que
up,
decía Miguel o dice Pati es tienes
trying
que
to find us, because there are many
conectarte,
opportunities in the industry.
involucrarte
And
con
as
las nuevas
Miguel, as Patty is
generaciones
saying, you need to be
para que
involved
aprendan y
with
ellos
new
vayan
generations, so they
aprendiendo,
will
valga la
learn
redundancia, cómo
and
trabajar
they will
su tierra. Entonces creo
find a
que
way
el
with
acercamiento con
old
la
and new
empresa es
learnings
muy
to
importante
work
y
their
estamos
lands.
abiertos para
So they
recibir.
need to approach the company, and we are open to welcome them. And with this,
creo que ya tenemos
we
algunos
have the
voluntarios. ¿Qué
very
se
last
necesita para que la
question.
industria abarque
What
más
do we
estados? ¿Qué se
need
necesita para que
to
estos
add
programas que nos compartieron este día,
more
esta tarde,
people?
estén en más estados?
What
Por
do we
ahí hay alguien de
need
Michoacán
for
que
you
alza la
to
mano
be
también. Entonces, ¿qué se
present in
necesita? ¿Qué
other
es lo que
states?
tenemos que
What
hacer
is
para
it
que
needed? Some
más
people from
estados puedan
Michoacán
contar con
raise their
estos
hand,
eventos?
so more states could have this participation. Well, I can begin, yes.
Para de verdad compartir también esta experiencia
To share
en
this
cuanto a la colaboración
experience
que estamos
as for
teniendo, no es
collaboration
solo
that we
por
have,
estar acá en el CIMIT, pero sí
is
es
not because I am here
compartir
at
esta
CIMIT,
metodología, por ejemplo, que ustedes
but
tienen en CIMIT de los
if
hubs,
you
¿no? Yo creo que
share the,
sí es
the
una
hub
experiencia muy
methodology
exitosa
from
y referente a
CIMIT,
nivel
I
mundial,
think
¿no?
this
Porque a mí
is
me
a
toca estar
really
también de responsable en diferentes países
good
y realmente a nivel
experience
mundial es diferente. Entonces, ¿pero por qué lo
across the
digo? Porque es
globe.
este efecto
And I say this
multiplicador,
because
¿no? De la
it has
tecnología y de
this
las buenas
multiplying
prácticas y demás.
effect
Entonces,
of
sí creo que es
technology
una
and good
forma de
practices.
ramificar los
So I
beneficios que tenemos
think
para que
it
llegue a
is a
más
way to
lugares. Entonces,
branch
pero mi
out
segundo punto
benefits
es
to
tener
reach
estas
further
colaboraciones, lo que es lo
locations, and
PPS, o sea,
also
público,
to
privado y
have
social.
these
O sea, sí
public and
tenemos
private
como la parte privada, pero
associations.
digo incluso
We
la parte
have
primaria y la
our
parte
private
agroindustrial,
connections,
pero
but
sí también
also
ver
the
cómo aliarnos
primary and
con
industrial,
las
but
localidades,
we
¿no? Ahora sí
need
que irnos a nivel
to
municipio,
partner
ver cómo son
with
con
different
programas públicos y
communities
con
in
esquemas de
different
colaboración que incluso
municipalities
se están
if there
impulsando
are
también en
public
tanto desde la
spaces
perspectiva pública
because
y poder
the
ahí estar,
field
¿no?
is being
Entrelazando como
promoted
estas
from the
oportunidades muy
public
puntuales para
perspective. We
decir,
need to
si tú eres
find
un
these
productor de maíz, pues
specific
cuánto
opportunities.
estoy produciendo ahora y
Like
cuánto
if
lo
you
quiero
are
llevar,
a corn
con qué,
grower,
¿no?
how
Con qué
much are
tecnología y
you
con qué prácticas.
producing now?
Entonces es mucho
And
más fortalecer estos esquemas de
how could we
colaboración para
help you
poder llegar a más.
potentialize? So I think we need to strengthen these collaboration schemes to
Pues
reach more people
que nos llamen porque pues
and
finalmente
have them give us a call.
nosotros aquí en
Because
México
here in
prácticamente
Mexico,
estamos en todos los
we
estados, ¿no? Con
are
todas las materias
present
primas
in
desde
every
leche,
state with
café,
all the
cacao.
inputs, milk,
Simplemente en Guerra
coffee,
nada más
cocoa,
tenemos
along with
46
Gerber, we
diferentes
have
materias primas locales.
46
Entonces,
local
prácticamente
inputs.
desde Chiapas
So
hasta
from
Chihuahua estamos.
Chiapas to
Entonces, es
Chihuahua, we are
cuestión,
there.
insisto,
So it's just
si
a
nos buscan a
matter
través
that they look
de
us
las
up
páginas o nuestros
in our
correos,
websites,
creo que
our
con gusto
email
estaremos y
addresses.
que nos conozcan y
I
conozcámonos también.
think they
Habrá un
can
rincón
call
que no
us,
vamos,
and
bueno, no sé, lo
if there is a
conoceremos con mucho
corner
gusto.
somewhere that we haven't
Sí,
been there
es
yet, well,
de la
call
misma
us
manera
and
es
we'll be there.
levantar la
Yes,
mano en las zonas donde
and please
operamos
just
o donde
raise your
quieran participar
hand
para la
in the
producción,
regions where
pero
we
también
are
creo
if
que
you
un cambio
want to
importante es
participate in our
CIMIT es
production.
para
But
nosotros
also,
y para muchos
CIMIT for
es un
us
brazo
and
muy
for
fuerte
many,
del desarrollo de esta
it's a very
tecnología
strong
y
arm in the
siempre hay un hub
development
de
of
CIMIT.
technology, and there's
Hace rato lo
always
mostraban
a
en el mapa
CIMIT
en
hub,
muchas partes de
as
la
we
República.
saw
Mi
on the
consejo es
map.
acérquense a esos
In many
técnicos de
regions,
CIMIT,
I advise
levántenle la mano
approach a
porque ellos
CIMIT
los van a enlazar
technician, raise
con
your
nosotros de una
hand
manera más rápida y
because they
directa.
will
La
put you in
segunda, también
contact
está
faster.
en IFAP, otras organizaciones, el
And
CNA,
also there
los
is
mismos
in IFAP,
proveedores de
CNA,
agroquímicos,
the,
fertilizantes,
the,
ellos nos
the very
conocen. Entonces,
vendors of
tenemos muchos
agrochemical
canales de
products or
comunicación con los cuales
fertilizers, they
pueden
know us.
acceder a estos
There
programas
are
y
several
contactarnos
communication
si están
channels
interesados
where you
en
can
volverse
approach us
agentes
if
de
you are
cambio y
interested to
querer
become
ser
an
la punta de
agent of
lanza
change be the sphere arrow in the new agriculture
Muchísimas
for our
gracias. Y
country.
con esto
Thank
también
you. Thank
de
you
mi
very
parte
much.
compartir que cuando escuchan que
And
dicen CIMIT, cuando
I want
escuchan
to
que
say
estamos hablando
that
de CIMIT, no solo
whenever
somos
you
nosotros,
hear
sino también toda esta
CIMIT,
red
it
que
is not
representamos en los
only
hubs y en las
us,
diferentes
it is a network that
entidades en
is
donde estamos
represented in
trabajando.
the
Entonces,
hubs, in the
sí, también
different
ese
entities where we
llamado,
work.
muchísimas gracias.
So
Muchas
this
gracias por
call
todo
for
lo que nos
action,
compartieron esta
thank
tarde.
you.
Muchas
Thank you
gracias
for
por su
everything you
participación.
have
Gracias también a
shared
ustedes por
this
escucharnos.
afternoon, and thank
Muchas
you
gracias.
for your attention.
Les dije que seguía interesante el día y la jornada.
Told you that this day was going to be very interesting. The journey has been
Ahora
so
con
far.
el
So we will
tercer
continue
bloque temático,
with the
último
third
ya del día y que sigue otra vez
subject
esta
matter
estructura
block.
de conferencia,
And the
magistral
last one,
y
we will have
conversatorio
a
asociado
keynote
a la misma
speech
temática.
and a conversatory dealing with the same subject.
Este último panel,
This last
como les decía,
panel,
más bien este último bloque,
or
tiene
rather this
también la
last block,
intención de hacer unas propuestas realmente
is
interesantes
going to
sobre
propose very
qué
interesting
hacer, qué opciones tenemos ante, sobre
actions,
todo los
what to
desechos
do,
que
which are the
estamos generando.
options that we have,
Pero bueno,
especially
para
for
volver a la misma
the
estructura que estábamos, les voy a presentar
wastes
al
that
moderador
we
de
are
todo este
creating.
bloque y él a
And
su vez le irá
I
dando
will
paso a los
first
diferentes
introduce the moderator
participantes.
to this
Entonces
block, and then
solicitamos
he
ahora
in turn
la
will
presencia y
introduce
participación
the
del señor Ramiro
panel
Ortega Landa.
members. Mr. Ramiro Ortega
Es
Landa,
especialista
we ask
en
him to come
finanzas
forward to the
rurales y
stage. He is an
climáticas del
expert in
programa, Sistemas
rural and
Agroalimentarios
climate
Sostenibles del CIN en
financial
México.
systems
Es asesor de educación financiera rural
the
para las
sustainable
finanzas
agri-food
inclusivas
systems
y
from
desarrolla
CIMIT in Mexico.
proyectos
He is a
para el
consultant
desarrollo de
in rural
créditos de
financial
carbono y
education for
financiamiento
inclusive
climático en el CIMIT.
finances,
Además,
and he
facilita la
develops projects for
implementación de
carbon
programas
credit
para el
development
desarrollo de
and
cadenas agrícolas de valor
climate-based funding
en su
at CIMIT.
tránsito hacia
Recently
la
facilitates
construcción de sistemas
implementation of programs for
agroalimentarios
the development
sostenibles,
of
inclusivos y
value
resilientes.
agricultural
Ortega
chains,
Landa tiene
or
una
in
doble
transition towards the
licenciatura
construction
en
of
Economía y
sustainable
Relaciones
agri-food
Internacionales
systems,
por
inclusive
la
and
Universidad
resilience.
de Arizona,
Mr.
una
Ortega Landa
maestría en
has
Administración
2 bachelor
Internacional de
degrees in
la
economy and
School for
in
International
international
Training
affairs
y otra
at
maestría
University
en
of
Administración
Arizona, a
Pública
master's
y
in business administration by the
Microeconomía
School for
aplicada
International
por la
Training, and a
Harvard
master
Kennedy School.
in
Como
business,
miembro
public
del
business
Harvard
management,
Innovation Lab,
in
recibió el
microeconomics,
Premio
in
Internacional
applied
de
microeconomics by
Innovaciones
Harvard
en la
Kennedy
Cadena
School.
de
He's a
Valor
member of
de
Harvard
USAID.
Innovation Lab.
Y
He
ahora
received the
lo dejamos
International
al
Prize
frente
on
y a cargo de
Innovations
este
of
último bloque.
USAID value chain. He'll be in charge of moderating this last panel.
Bueno, muchísimas gracias. Muy amable.
Thank you
Muy
very
buenas
much.
tardes.
And good
Tengo un
afternoon.
especial honor y privilegio de
It's
poder estar con
my
todos
honor
ustedes
and it's also a
esta
privilege
tarde
to
y
be with
saludarlos a
you
nombre
this
del
afternoon
CIMIT,
and
a
to
nombre de
greet you
ICA
on
y a
behalf
nombre
of
de FIRA,
CIMIT, ICA, and FIRA,
las instituciones que estamos organizando
the
este foro.
institutions that have
Quisiera en
organized
primer
this
término
forum.
convocar
First
a
of
la
all, I
doctora
would like to
Verónica
invite
Pérez.
Dr. Verónica Pérez.
Cerezo, perdón. Verónica, bienvenida.
Verónica,
La doctora
welcome.
Verónica Pérez
Dr. Verónica Pérez
posee un doctorado en economía,
has a
una
PhD
maestría en
in
economía
economics
agrícola
and
por
a
el
master's in
Colegio
agricultural
de
economics
Postgraduados.
by
Actualmente se
postgraduados,
desempeña como
Colegio de
especialista en
Postgraduados. At present,
bioeconomía y
he is an expert
agronegocios
in
en el
bioeconomics
Instituto
and agribusiness
Interamericano de
at
Cooperación
the
para la
Inter-American
Agricultura
Institute for
en la
Agricultural
representación
Cooperation,
de México.
representing Mexico.
Es líder de la Red
She's a
Mexicana
leader
de
of the
Bioeconomía
Mexican network of
Circular,
circular
miembro de la Red
bioeconomy.
Latinoamericana de
He is a
Bioeconomía
member of
e
the Latin
investigadora
American Network
externa
on
de la
Bioeconomics and
línea de
external researcher
investigación de
of the research
bioeconomía,
line
alimentación
Bioeconomics,
y
Food
recursos
and
naturales
Natural
del
Resources
Colegio de
from Colegio
Postgraduados.
de Postgraduados.
La doctora Verónica Pérez
Dr. Veronica Perez has participated as a coordinator and researcher in different publications of scientific papers and books, among which we can mention bioeconomics concepts and principles, bioeconomics instruments for the economic analysis, a threshold of a new agriculture, and bioeconomics, the case of the egg in Mexico, as well as author and co-author of several publications related to the topics of bioeconomics, value networks, and circular economy, as well as hybrid finances. It's a pleasure for me to welcome you, Dr. Veronica Perez. I would also like to invite
Doctora Juliana Morales Castro.
Dr. Juliana Morales Castro to come to the stage, who will speak after Dr. Perez's presentation. Juliana, welcome. Dr. Juliana Morales Castro has a PhD and very well known for her work in research on food science.
Instituto Tecnológico de Durango. Además, ha trabajado
Durango Technology Institute. She has worked since 1992 in that educational institution. He has a PhD in food technology by Cornell University, and he has a specialization in innovation and scientific communication management. Her research work is focused in taking the best advantage of agri-industrial wastes in order to obtain bioingredients and techno-functional ingredients, as well as for the development of biopolymeric films for food packaging. She has published 50 scientific papers. He has led 26 research projects, and she has trained students at the PhD, master's, and bachelor degrees. She is a member of the National System of Researchers, SNI Level 2, and she has been director of the Council of Science and Technology from Durango. Besides, she has been working in the arbitrage of different scientific international magazines, and she actively works in initiatives where communication is spread out and the promotion of sustainable development targets. Thank you very much. It's a pleasure and an honor to be with you. I would also like to invite to come to the stage Dr. Luisa Martín de Block.
La doctora Luisa Marín cuenta con más de 25 años de experiencia.
Dr. Luisa Marín has over 25 years of experience in non-government organizations. She has concentrated herself in environmental preservation and sustainable development. She was the country's director for General Biochar Systems in Mexico, the first initiative to produce biochar at an industrial scale in Mexico. She worked in the Nature Conservancy, and she led the work of Conservation International Mexico, where she worked in development projects funded by international cooperation. Dr. Marin also includes an approach in social and community inclusion in environmental projects, ensuring thus the participation of local communities in her professional work. Besides, she forms part of the consultancy board of the International Initiative of Biochar and the Latin American Institute of Biochar, promoting biochar as a sustainable solution to mitigate climate change. Throughout her professional career, Luisa has shown consistent commitment with environmental management, outstanding in the preparation of policies and project management, as well as thanks to her work with stakeholder groups to create global impact. So, without further ado, it is my honor to give the floor to these three ladies, these great professionals who are helping the world to successfully face climate change.
Pues muy buenas tardes a
Please,
todos.
Dr.
Yo les vengo a
Veronica.
platicar un
Good
poco de
afternoon,
cuáles
everyone.
son
I will
los
talk
retos
briefly
de cómo
about
hay que
the
redefinir estos
challenges and
sistemas.
how we
Un
have to
poco de lo que ya
redefine
platicaron en
these
el panel
systems. You
pasado,
have already talked
pero
about
ahora
it
digamos que una
briefly
escala más
in the
chiquita.
last
¿Cómo
panel,
vamos a
but
tener
we'll
que
do
hacerle
it at
todos
a
los
smaller scale.
productores, incluso
What are we
los
going to do
emprendedores,
from the
que tenemos que contribuir
growers
a esta
and the
descarbonización de las
entrepreneurs
cadenas, no solamente esperar
standpoint?
a que nos
We have to
traiga
contribute
una empresa
also
grande el
to
cambio,
decarbonize
empezar a hacer
these
estos
supply
cambios desde
chains,
origen.
not
Y
wait
primero, bueno,
until somebody
definiendo lo que
else
son los sistemas
does
agroalimentarios
the
o cómo
work
fueron
for
definidos
us.
en un inicio.
First, we
Y
have to
esto
define
basó
the
en
agri-food
la idea de que
systems.
todo era ilimitado, los recursos
And the
naturales eran
idea at the
ilimitados,
beginning was that the
nuestra
natural
capacidad
resources
para
were endless,
procesar
our capacity to process
manejar los desperdicios
or to
también era,
manage
y
waste was also
bueno,
endless.
también que teníamos gran cantidad de mano de obra
The premise
disponible
was that
que
we
en
had
el
a
momento en el que
great
se esquematiza,
quantity
se
of
define sistemas
available
agroalimentarios,
labor.
pues había
As
todas estas
these
partes de
agri-food
sociales donde no había un
systems,
sueldo definido
we did
o no
not
eran
have
buenas
any
prestaciones o
wage,
como
we
hablaban en
did
las
not
mesas
have good
pasadas, no
benefits.
todavía
We
no hay
had
seguridad
social
social
issues
generalizada en el
there,
campo.
and in general,
Estos
currently there
sistemas
is no
agroalimentarios
social
actuales se
security
definen como
in
tomar,
the
producir,
field.
consumir y desechar.
This
Hoy en
model
día,
follows
se habla de sistemas
this premise:
agroalimentarios
take,
y no de
produce,
cadenas o
consume,
no de
and
redes, porque
dispose
son
of.
todavía más
We cannot
complejos. Al
talk about
nosotros engresar
networks.
en una
We
cadena,
cannot
la
talk
parte
about
social
really
y la
supply
parte
chains
ambiental,
because things
la
are even
volvemos todavía
more
mucho
complex.
más
When we
compleja,
talk about the
mucho más compleja
social
de manejar y
impact
mucho
of the
más
supply
compleja de
chains, we find
redefinir.
out that it is very difficult to
Los sistemas
redefine and
agroalimentarios
to
que
manage.
regularmente nosotros
The
conocemos, pues son
agri-food
lineales o los manejamos,
systems chain, our
esquematizamos de
systems
manera
are
lineal.
linear.
Tenemos la
We
parte de
show
materias
them in
primas, la parte de
the form
producción,
of
el
a
consumo, los
flowchart,
desechos,
raw
y uno
material
de los que
production,
siempre dejamos
consumption,
fuera de
and
esta ecuación y que
disposal.
son
And one of
importantes en
the
cada uno de estos
stages
y
that
que
we
felicito
do
a
not
Heineken porque en
consider
esta ocasión sí
within
lo vi en su
this
cadena de valor, es la
chain,
parte de
and I
logística.
congratulate
¿Cómo
Heineken
muevo
because
esas
they do
materias
have them,
primas
is
de
the
donde las
logistic side.
compro a
How
donde las
will
voy
I
a
move
procesar
these raw
y después
materials, where
cómo
I
las
buy
muevo
them
a
from,
donde las
and
voy a
where
vender?
are we
Y
going
parte de
to
este sistema de logística es
transform
lo que a
them
veces
and to
encarece
those places
los
where they are
productos
going to
y
be sold
además
as
la parte que
end
más contamina.
products.
Hoy por
And
hoy hemos
precisely
hablado que
this
la
is the
agricultura
part
contribuye
that
con
has a
un
huge
tercio de
impact on the agri-food
de los gases
systems
de
and the
efectos
most
invernaderos
pollutant,
y de ese
the
30%
most
más o menos
polluting
que genera la
stage as well.
agricultura
Out
de
of
gases de
more or
efectos invernaderos,
less
un
40% of the
30% es en los cambios de
GHG is
uso de
produced
tierra,
by
otro
agriculture.
40% por los
Part of it
sistemas
comes
agrícolas,
from the
pero este último
land
30%
use
se concentra
change and
principalmente
also due
en la
to the movement
logística de la
required.
distribución
This
y
is
en diferentes,
concentrated in the
en los
logistics and
desperdicios que hay a
distribution
lo
as
largo de
well
la
as in
cadena,
the waste produced
principalmente
throughout the
después
supply
de que
chain.
llegan a los hogares. Donde
After
se
they
realiza el mayor desperdicio
reach
de alimentos,
households,
regularmente
that's where
es
we
después
waste
de que
more
nosotros los
food,
compramos y los
after
llevamos a
we
la casa.
buy them as
Entonces, el
consumers,
problema
after we
es
take
a lo
them
largo
home.
de
So the
toda la
problem
cadena, desde que
goes
nace el producto
from the
hasta
beginning
que lo
of the
desechamos,
supply
¿no?
chain till
Hemos sido
we
generaciones
dispose of
que
those
crecieron con el
products.
problema de
In our
suficiente abasto de
generations,
comida,
we
tendemos a
grew
comprar
with
muchas más
sufficient
cosas
food
de
supply.
las que realmente
We
consumimos
really
y hoy
tend
por
to
hoy
buy
tenemos
much more than what
aproximadamente un
we will
desperdicio de
eat,
entre
and
el
currently
30 y
we
el
have a waste of
50% de
almost
los alimentos
30 up to
solamente de los que se
50% of the
destinan a
food that
consumo
we
humano. Y
purchase.
toda esa
This
basura
is only for human
pues genera
consumption. All
también
that waste,
efectos
all
de
that
gases
garbage is
invernadero.
also creating
Como
GHG
conocemos, los sistemas
emissions.
agroalimentarios
As
actualmente
we
traen
know,
consecuencias
our
negativas y
current
positivas.
agri-food
En este
systems
caso, por
have
ejemplo, se
positive
dividen
and
en
negative
económicas, sociales
outcomes,
y
and we
ambientales,
can
y
split
las
them
que
into
nosotros nos
economic,
concentramos
social, and
en
environmental
esta mañana
outcomes.
han sido
Today,
las
we
consecuencias ambientales,
concentrated ourselves in the
específicamente las
environmental
relacionadas
outcomes,
con
specifically
cambio
those related
climático,
to
degradación de
climate
suelo,
change,
pérdida de
soil
la biodiversidad,
degradation, loss of
contaminación atmosférica
biodiversity,
de los desastres naturales.
ocean
Hoy por hoy
contamination,
sabemos
and the
que
increase in
existen
natural disasters.
grandes
But we know
tormentas tropicales
there
o
are
grandes
huge tropical storms,
depresiones que están afectando a España y que
severe
son
tropical depressions like the one that is impacting Spain currently. They are as a consequence of the whole degradation of our planet. We have huge ambitious targets to reduce global warming, very high-level targets that we have to comply with, but not only large companies should concentrate in achieving those goals. We, small entrepreneurs, small growers, and even at the household level, we have to shift, to make this shift. We have to change our chips and help decreasing the production of GHGs. And of course, there are several areas that we have to understand also. Well-being, system digitization, and sustainability. Obviously, in terms of well-being, we need better food, more health, or healthier food rather, and must be in sufficient quantity to provide food for all the population. The population keeps on growing. We need to take care of biodiversity while we feed this ongoing population. With regards to the digitization systems, we talked about it in the last panel. We need to provide that information to all the stakeholders, to the growers. They need to have access to those instruments that will help them mitigate, qualify, and quantify their own impacts on climate change, and also to show small, medium growers as well as consumers which are the effects of climate change and how we are contributing in creating positive or negative effects in each link of the supply chain. Today I will concentrate on the carbon fingerprint. We wanted to be neutral, we wanted to be positive, that is to recarbonize our soils, to get more carbon for the soils, to lower the carbon fingerprint in such a way that with all the forests and all the natural resources in our country, we can contribute with a positive carbon fingerprint. If it's not positive carbon fingerprint, at least this fingerprint should be neutral. And this requires lots of care. What about the fingerprint, carbon fingerprint? How do we create it? Well, all of us at each one of our actions conducted in this planet as human beings, and even actions conducted by animals, leave a carbon fingerprint, emissions of NOx, some fluorocarbons, and also carbon mainly. And we measure them in carbon equivalents. Each one of these gases have a carbon equivalent measure so that we can track it in a proper way. And our carbon fingerprint has not stopped since the 50s when we started with the fluorocarbons. Currently, we have 61% in the increase of the GHG emissions. We have had some reductions. We have not yet been able to reduce them by 40%. Some countries have remained neutral, whereas some other countries have increased their carbon fingerprint. As I said, each one of the links in the supply chain, talking about the current well-known supply chain, contribute in a different manner to GHG emissions, but we can also contribute to mitigate their effect. In this first talk, I will talk about how are we contributing? Well, in food production, grain production, planting crops. These are not the only activities that produce GHGs. Livestock, raising cows are also one of the main factors producing GHGs in agri-food systems. There are new solutions and more are coming up in order to mitigate the carbon fingerprint. We'll talk about them in a few minutes, but it's not only processing, but also transformation. For instance, I raise cattle, but I don't eat them. I drink their milk, or I help cutting their meat. And those links also create GHGs. And many of these much of this food, we eat them at home, and this is shown in the chart in the right-hand side, increase the production of GHGs. And that's why we say that switching to more vegetarian diets, stop eating meat, stop products with a high carbon fingerprint can also be a good option to help alleviate the effects of climate change. There is not one solution. The solution is that we learn as consumers, as growers, to set an order in everything that we do, to quantify our carbon fingerprint and make decisions which will enable us throughout the chain or through our work activities to decrease, minimize this GHG production. Logistics, as I said, is a great link that is creating a lot of GHGs. If you transport your products by truck, you can release into the atmosphere up to 101 emissions by transporting 1 ton of products just 1 kilometer. Imagine that milk that comes from Chiapas down South Mexico and to take it up north in Coahuila. So part of these logistics, part of these value supply chains networks require having raw materials close to where they are being processed. If we have close to us raw materials, we can lower this carbon fingerprint created by logistics. If I move our products by ship, I will be producing 31 tons per every kilometer moved. And if I do it by train, the figure is lower, 22. But in terms of consumption, as I said, diets leading to being vegetarian and to change our lifestyle are helping in a positive manner to decrease the effect of GHG emissions production. But it's not just a shift in diet, it's a shift in lifestyle. If I'm moving to the store close by 3 blocks away and I use the car instead of walking, I'm not helping at all. Like for instance, in Mexico City, because there was too much traffic, there were too many cars, they established in which some cars with a given number plate will not be able to go out to the streets. So thinking in how we are impacting in a negative or positive way in the production of GHGs, each one of us. This is truly important. As for waste, the main topic of this panel, you know, that 6% of the households are contributing to the waste produced throughout the supply chain. Out of that, 40% produced of waste produced throughout the supply chain, because we just throw away the waste or the products that we do not eat at home. And from this, several initiatives have created, like for instance, food banks that rescue those food products that can still be eaten by underserved communities. Or there are some technologies that enable you to use this waste, like for instance, the peel, mango peel or mandarin peel that can be used as biological inputs for other companies, packaging, for instance, pharmaceutical products, or even different types of food byproducts, and that will help reducing the GHGs of these agri-food systems. And on the other side, in this part of the chain, I would like to talk about digitization. We are pretty much used about about it. Right now, we have over 500 people connected through internet, our emails, our Zoom activities, also creating GHGs. For instance, electrical appliances can produce different GHG emissions. If we send an email and we send images and then the presentation, etc., the GHGs are increased. These cloud systems, Google, Microsoft, etc., create heat. Large buildings with modems and routers which produce heat, and this heat released increases the negative effects on climate change. So each one of the things that we do in our everyday life, either to produce, to sell, or to consume food, increase GHGs. This is a fingerprint based upon the agri-food system. Here I'm saying that it's very well for us, it's very good to contribute little by little baby steps with every action that we do to mitigate, to alleviate climate change. However, it should always be seen as a chain, like Henneken said. Henneken measures each link, each product, and their pollution capability. So as we consider ourselves a chain, we know to which chain we believe, to which agri-system we belong, and then we can see which are the actions that we can contribute with in order to face the challenges posed by climate change. Nowadays, all international initiatives, especially those coming from the European Union, ask you for your products to have the water use efficiency or the carbon efficiency fingerprints. So they are exerting pressure on us to lower down this carbon fingerprint. But in Mexico, we have a severe problem. We don't even know to which chain or to which agri-food system we belong to. So it's rather complicated to understand how we will quantify them. Because as you know that regarding soils, we have very well established parameters that I can measure in order to know if I am recarbonizing the soils. But in terms of agri-food chains or systems, we have to tailor-make a solution for each one of them to understand which strategy can be followed in order to continue producing with a lower carbon fingerprint. As for food, bovine and sheep meat are the ones that produce more GHGs, and fruit and vegetable production as well. But where are we aiming at? We want to decarbonize these chains. We want to create methodologies and follow actions that will enable us to lower the carbon fingerprint of our supply chain, or even at our home. From ICA, we believe that bioeconomics is an option that will help decarbonizing these chains, basically due to the use of waste from the bioeconomics standpoint, the use of biodiversity in a regular, foreseen manner will help us. We believe that, for instance, systems of vertical agriculture with well-established parameters can be the ideal option to produce some vegetable crops in order to reduce the impact. In ICA, our concept of bioeconomics is the intensive use of the knowledge that we have in order to use these resources, processes, technologies, principles, etc. Those biological principles that will help us produce in a sustainable manner food
Hoy por hoy creemos
products and
que la
services.
bioeconomía tiene la posibilidad de
We believe that
transformar los
bioeconomics
sistemas
currently has the
agroalimentarios,
possibility of
generando
transforming
ganancias,
agri-food
eficiencia y
systems by
sostenibilidad para cada
creating
uno de los
profits,
productores
efficiency, and
a través de
sustainability
incremento de productividad
for
con
each
semillas
grower
mejoradas,
by
biofertilizadas
improving the
o
productivity and
semillas que
sustainability
produzcan
with
mejores
fortified or
rendimientos,
enhanced
que
seeds,
sean
seeds that will
sostenibles y que
produce
nos
higher
permitan
yields
crear
that are
biomasa cuando
sustainable and
requerimos
will
biomasa o
help us
reducir el
produce
índice de biomasa en
biomass when it
plantas
is required
perennial.
to reduce the
Su objetivo final
biomass
no es la producción de
index
biomasa,
when
que nos va a permitir
we
transformar
have
territorios rurales,
crops whose
que
end
también
result
vamos a
is
utilizar,
not to
vamos
produce
a
more
lograr un mayor
biomass,
aprovechamiento de todos
and
los
creating
recursos,
systems where we will
principalmente
use better
utilizando
all the
biorefinerías.
resources using
Imaginemos, por
biorefineries,
ejemplo,
for instance.
un
Let's
ingenio
imagine
como una
a
gran
sugar
biorefinería.
cane
Nosotros utilizamos el ingenio para
in
producir azúcar,
industry where
pero
we
también
have
puede
a
producir
huge
etanol,
biorefinery. We
también
can
puede
produce
producir otros
sugar, but
productos
also
y
ethanol and
vinajas,
other
vinagres, flavores,
byproducts,
etcétera. Y
binanas,
además puede generar
bio-oils,
agroquímicos.
etc. And then we can also help
La bioeconomía también nos
co-generating
puede ayudar para
energy.
mejorar la nutrición y la salud de la
Bioeconomics can
población
also
y
help us to
también a
improve the
contribuir a la
health and
sostenibilidad
nutrition of our
ambiental.
population
Creemos
and
que
to
la bioeconomía a través de
also
las biorefinerías
improve
nos pueden
the
ayudar a la generación, por ejemplo, de
economics in
biocombustibles de
general. We
máxima
can
calidad,
produce
no
biofuels
necesariamente
of high
provenientes
quality that do not
de
come
alimentos o de
necessarily
productos que
from
pueden
food
considerarse
or
alimentos, sino
products that
incluso
may
de
be
desechos
considered food, but
que
from
nos
waste.
permitan producir
Waste
etanol, que nos
that
permitan
can be
producir
used in order to
biodiesel,
produce
como son las grasas de
ethanol or
restaurantes,
biodiesel,
y
like
que
for
podamos
instance,
competir con
fatty wastes
estos productos
of
de manera
restaurants.
eficiente.
And
En ICA tenemos,
they
como
can
les
be
comentaba,
used in
la
an
visión de
efficient
tener
way. At
granjas
ICA, we
verticales.
share the
El
vision of
lado de la foto
having
del lado
these
derecho
vertical
es
farms on
una
the
foto
right-hand
donde
side.
tenemos un
We are
módulo de
showing a picture where
aproximadamente
we
4
have
por
a
2,
module of
4
more
por
or
3
less
metros, donde
4
producimos alrededor de
times 3 meters,
1,200
where we
lechugas por
produce
ciclo, con
1,200
una
lettuces
cantidad
by
de
crop
850
season
mililitros de
with
agua por
850
lechuga.
milliliters of
Entonces producimos lo que
water
se puede hacer
per
una hectárea,
lettuce.
pero
So we
solamente
produce here
alrededor
what
de
we could
menos de
have planted
450
in 1
litros
hectare,
de agua por
but
ciclo.
with less than 450 liters of
Sabemos
water
que el
per crop
principal
season.
reto es que todos
So we believe
conozcamos
that
a
the
cuál
main
cadena o
challenge
a cuál
is
sistema agroalimentario
for us to
pertenecemos
know
para
to
saber cómo
which
sumar
supply
esfuerzos.
chain, to which
Hemos mapeado algunas
agri-food
cadenas y
system
les
we
hemos
belong
dado la
to.
opción
We have
de
mapped
productos de la
several
bioeconomía que
chains and we
podemos
have
tener a
give them
través de
several
los
options
desechos
of
o incluso de la biomasa generada.
bioeconomics that we
Por
can have
ejemplo, es el
through their
plátano, como
waste or
podemos
the
producir,
biomass
incluso
that
de
they produce.
de
For
los
instance, with the banana
hijuelos
industry, we
que se
can
cortan
use the peel
la penca de
and
plátano,
also the
desde pads,
cuts that
toallas
we
sanitarias
get
femeninas,
from
hasta
the
productos o aminoácidos
trees.
esenciales específicos
We
para la
can
refinación
use
o
them
para
for
la
the
industria
production
farmacéutica.
of
Lo mismo hemos
for the
trabajado
production
con
of
café,
pharmaceutical
con piña,
purposes
con limón y con
or
algunos otros productos.
mixed
En el
with
caso, por ejemplo, de
other
Bolivia,
byproducts. For
trabajamos
instance, in
con,
Bolivia, we worked
se me fue
with,
el nombre, pero hemos
sorry, I
trabajado en
can't
diferentes
recall the name,
áreas.
but we have
Creemos
worked
también
with
que la economía
several
circular puede
companies
ser un
combining
buen cambio de
byproducts
paradigma al utilizar
of
todos
the
los desechos,
agri-food
pero
systems, and
teniendo un
it's
concepto diferente
very
desde,
nice to
desde
make
el
this
momento en que se concibe el
paradigms
producto,
shift,
desde el
but
momento en que yo
we
sé cuál va a
must
ser el
have
producto o servicio que
exactly
voy
what we are
a
seeking
lanzar
for
al
from the
mercado,
time in which
yo
we
reconstruyo todo
have the
ese
idea of a
proceso
product that
para
can
que
be
tenga
launched
el
into the
mínimo impacto,
marketplace,
tenga
and
menos desperdicios
I
a la
can
hora
start
de
building up the whole
producir,
process in order to minimize
sea más
my
eficiente en la
impact,
producción y que
so I
también
can start
llegue
producing in a
a
more
los hogares con
efficient
mayor
way,
tiempo de
reaching
almacén, con
households
mayor
with
tiempo de uso,
longer
para que yo
shelf
pueda
life
utilizarlos. En este caso de economía circular
and
incluso se está
longer
promoviendo la parte de
life
servicios,
cycle
el
in
utilizar
general.
la
And
renta
here we're
de
including different
computadoras,
services,
la
like for
renta
instance,
de
leasing
equipo de
computers,
electrodomésticos, en lugar de
leasing
comprarlos
electrical
como un
appliances
servicio
instead of
para que se pueda
purchasing them.
disminuir el
We can
impacto.
list them as
Y otro
services
de
in
los
order to
que
reduce our
consideramos y que hemos revisado a
impacts.
lo largo del día es la
Something
agricultura
else that we
regenerativa.
have been
Creemos
working
fielmente que la
with
agricultura
is
regenerativa es una opción
regenerative
para
agriculture.
mitigar
We
los
definitely believe
efectos
that
de
this
cambio
is a great option
climático,
to
no solamente
mitigate
para
the
recarbonizar
climate
cadenas
change
con
effects, not
suelos,
only to
sino
decarbonize our soils, but also it can be considered as an option to decarbonize the chains at which we work. And finally, we have the short chain agri-food systems. They were really the flagships in the pandemics. They helped us survive in the 2 years of the pandemic. And we have to rely on these short chain agri-food systems, having the raw materials pretty close to the production or transformation centers. And they, in turn, should be close to the end consumers, avoiding traveling for long distances to find markets. And besides these short chain agri-food systems, enable growers to be part of much larger agri-food systems. So this is all that I want to present, and this is a piece for thought. We are about to be part of the history of that generation that ended up with the planet, but still we have time to change this. Instead of being remembered as the generation that ended up with the world, we can be the generation that saved the world. Thank you.
Bueno, pues para interrumpirlos y sacarlos un poco el tema en el que estamos.
To interrupt a little bit your train of thought,
noticia, sorpresa,
I would like to give you some news, a comment really. Even though you believe that this doesn't have to do with what we have heard, it does have to do with it, because at the end of the day, it has created a very low impact carbon fingerprint. Our last speaker is celebrating her birthday today. So we would like to give them a small token of recognition.
Y ahora sí pueden continuar.
And so we can continue now.
Muchas gracias por una nota tan grata.
Thank you so much for such nice news, and congratulations.
A la segunda parte, si se quiere, de este foro. Durante buena parte de la mañana y hasta hace muy poco hemos hablado de la
most of the morning, we have discussed about recarbonization of soils, and now we are in the decarbonization of agri-food systems. Following this, I would like to give the floor to our next speaker, and that is
Juliana Morales.
Dr. Juliana Morales, researcher.
Había anticipado antes del Tecnológico Instituto de Durango.
Muchas gracias.
Con
el permiso de la audiencia,
Tecnológico Instituto of Durango. So I am used to give lectures standing, so I ask your permission to be standing up. I am here as a representative of a network of academicians created in 2016. We are professors of universities, superior schools, and research centers, and we all work with food waste, mainly how to reduce waste, but trying to make apparent something that was not easy in 2016. First, create awareness from the public, and then we evolved for
residuos o desperdicios que ya nos habló la doctora Verónica.
Leveraging this waste, as Dr. Verónica Pérez presented. Thank you, because she just presented the framework for this. So this is me. I am representing my co-workers and colleagues, members of this network.
Ahí está. Bien. pues la agenda que tenemos.
This is
Voy a
the
saltarme algunas
agenda,
láminas
and
porque
I
lo que
will
ya traía
skip
preparado al
some
inicio, pues
slides
ya lo hemos visto a
because
lo largo de
what
esta mañana. Sí.
many of the things that I
El
prepared to
impacto que tienen los
present,
sistemas
we have
alimentarios
seen this
científicos, que
morning, the
precisamente también lo
impact
acaba de
that
colocar
food
la doctora
systems have,
Cerecedo
and just
en el contexto.
Dr. Pérez
No hay dónde ponerme
Cerecedo
porque si me pongo acá le doy la espalda
presented.
a mis
I'm
compañeros del
sorry, I'm
panel,
moving
quizá
around because
aquí,
I
¿verdad?
don't
Para
want
poder
to
verlos
give my
atrás,
back
¿no?
to
Bien, y
my
también esto pues ya lo habíamos visto.
panel members.
La doctora
This
ahorita
also we
enfatizó cómo
have heard
el sistema de suministro de
Dr.
alimentos, las
Pérez
etapas de
Cerecedo
transformación,
underscored
envasado,
the
así como el comercio
different
minorista, pues son los que
transformation
contribuyen en mayor medida
stages.
a la generación
Packaging
de
and
emisiones de gases de
retail
efecto
also
invernadero.
contribute to the greenhouse gases
También la
emissions.
Agencia Europea del
And
Medio Ambiente
here, the
recomienda ciertas
European
acciones para
Environmental
descarbonizar
Agency
los
recommends some
sistemas
actions
agroalimentarios
to
y una de ellas, la
decarbonize
última que está acá
agri-food
abajo, es
systems,
reducir
and one of them
precisamente
here
el desperdicio de
in red
alimentos,
is to
cambiar hacia
reduce food
dietas
waste,
menos
change for
contaminantes, menos
less
sostenibles,
polluting
rutas más cortas y reducir
diets,
importaciones que también
shorter
la doctora
transport
Cerecedo ya
routes,
ahondó al
and
respecto.
reduce imports, as
Bien,
Dr. Pérez
solo
Cerecedo
quisiera también mencionar
presented
esto
also. And
de
briefly,
una
I would like
fundación
to
que
share
MacArthur Foundation
this
que
from the
promueve precisamente
MacArthur
el uso de la economía
Foundation
circular
that
en los
promotes
sistemas
the use
alimentarios y
of
menciona
circular
que el impacto social,
economies in food
ambiental y
systems,
económico de la
stating that the
producción de alimentos sobre los
social
alimentos es tan
impact
grande
of food
que por
production is
cada
so
dólar que
big
gastamos en
that for
comida
every dollar
estamos
that we
gastando,
spend
haciendo,
on food,
pagando
we
$2
are
más
paying
por
two
el
more
impacto
dollars
socioeconómico y
due to
ambiental
the
que genera
socio-economical and
el consumo de
environmental
alimentos en la
impact
actualidad.
that this
También
food
es
intake
importante, ¿verdad?
generates. Also, it is
Fundamentar
important
que
to
si cambiamos la
state
forma en que producimos y
that
consumimos
if
alimentos,
we
vamos a poder
change the
reducir los
way
gases de
we
efecto
produce
invernadero en
and use
10.3
foods,
gigatoneladas al
we
año
will be
y
able to
también
reduce
el hecho
greenhouse
de
gases
disminuir
emissions in
las emisiones de gases de
10.3
efecto invernadero en el sector
gigatons per
alimentario
year, and
contribuiría a
also
un
we will
20% en la disminución,
contribute
la
to
cantidad
a
total necesaria para
20%
mantener la temperatura dentro de los
reduction
límites que
of
ya
what is
hemos
needed to
hablado.
maintain the
De esta
temperatures
manera,
within the limits that we are aware of.
¿qué representa el desperdicio de alimentos en el sistema agroalimentario? Ya la doctora
What does
nos
food
dio
waste
una
represent
introducción,
in the
¿verdad?
agri-food
Pero es
systems? We
importante que
just heard
recordemos que el
an
30% de los
introduction, and
alimentos
it is
producidos al día de hoy
important
se
to remember
pierden
that
o se
30%
desperdician
of
a
food
escala
production
mundial.
today
El
is lost
14% de
or
esas
is
pérdidas ocurre en las
disposed of
primeras etapas
as
de la cadena
waste in the
entre la
world.
producción y lo
This
que llegan
happens in the
a
first
los
stages of the
centros de transformación,
production
así como a
chain,
los centros
while they
de
reach to
venta
the
al menudeo, y
transformation
se conocen
centers,
como
the
pérdidas
retail
en el
centers, and
lenguaje
these
que
are
usamos se conocen
considered
como
as
pérdidas, mientras
waste
que un
or losses,
17% de
and
este alimento
17% of
despreciado
these
ocurre en las últimas
wasted
etapas, que es
food
en la venta al menudeo y en los hogares,
happens
que
in
serían los
retail
desperdicios
sellings and
propiamente.
at
Se
households.
ha visto también, se ha
So
reportado
we
que de todo
we
ese
know, as
corriente
it is reported, that from
desperdicios,
all
el
this stream
60%
of
proviene de
waste,
las frutas y
60%
vegetales, que es
comes
una
from
cantidad
fruits
enorme.
and
Y la
vegetables, which
mayoría
is
de
an
ellos se deposita
amazing
en los
amount,
rellenos
and most of
sanitarios.
them
En
are
Estados Unidos, el 22% de los
disposed of
residuos
in
sólidos municipales
landfills.
son
In the
alimentos
US,
y ese valor del
22%
desperdicio pues
of
equivale
this
a
municipal waste is
muchísimo
food,
dinero. ¿Sí?
and this is
Podemos ver aquí en
translated
el
in
gráfico
thousands of
cómo
dollars. We
la contribución del
can see
desperdicio de
in this
alimentos
pie
en su
chart
mayoría se da en
how
restaurantes, tiendas de
food waste
comestibles, así como en la etapa de
share is
en el
in
hogar. ¿Sí?
households, restaurants,
Bien, ¿y qué
pharmacies,
representan
and
las
others?
pérdidas y desperdicios?
So
Ya lo mencionaron también, pues un impacto enorme social, desde el punto de
this
vista social, pone en jaque a la
represents a
seguridad
social
alimentaria, desde el
impact.
punto de
It
vista ambiental, ya lo hemos
jeopardizes food
visto, la pérdida de
security.
biodiversidad, etcétera,
From
y
the
desde el punto de
environmental
vista del
perspective,
impacto
there is a
económico, pues
loss
todo
of
lo que se pierde cuando
biodiversity,
perdemos
and the economic
alimentos.
impact whenever
Pero
we
¿cómo
waste
contribuyen?
or lose food.
Específicamente hay una
But
publicación, ¿cómo
specifically, there
contribuyen
is a
las frutas
publication,
y
how
verduras al cambio
do
climático?
fruit and
En
vegetables
tres
contribute to
puntos
climate
principales.
change? In
Cuando el
3
desperdicio de
areas.
alimentos representado
First,
por
when
frutas y
food
vegetales
waste
sufre
represented by
biodegradación, pues genera
fruits and
emisiones
vegetables
de
degrades,
CO2
they
que
have
contribuyen al cambio
CO2
climático.
emissions
Cuando
that
se
contribute
depositan en
to
rellenos
climate
sanitarios,
change. When these
además
are
del CO2
disposed
de la
of in
descomposición se
landfills, not
genera
only there is
metano, que es
CO2,
un gas
but
mucho
also
más activo,
methane,
más
that
potencial
is a
que el
more
CO2,
active and potential gas, as well as its precursors, and also global warming is accelerated. And if this waste is incinerated, there are CO2 emissions and aerosol nitrogen particles. This graph from 2017 from RAP, a body in the United Kingdom, presented this slide to show the waste of food. In green, there are the actions to promote, which are to prevent or reduce that there is no waste. But once we have food that will not be eaten or that was dismissed, the first option is to reincorporate it in the value chain, redistribute it to people. And this is what the Bank of Food is done. Then it can be sent for forage or recycling or aerobic digestion, compost, recover energy. These are less desirable options as well as their disposal in landfills. And currently we are focusing on agri-food waste, mainly in the transformation stages, even that these are generated across the chain. The academicians are focusing on these sectors. We have agro-industrial residues, co-products, waste. Each one has a definition, but they can be solids, they could be liquid, the byproducts, it could be from animal source, vegetable source, it could be seeds, bagasse, wastewater from animal feathers, skin. And what can we obtain from this? Because even when this is wasted food, it still has a chemical composition capable of nourishing. That is why we need to recover stems, roots, leaves. We could have dietary fiber given the wide range and diversity of byproducts that could be recovered from this industrial waste. Also, there is another classification, which are the agricultural residues or food processing. Here, there are the different crops, stems, seeds. During the transformation process, there are husks, peels, stems, skin, and finally, in animal production, there is a wide range of byproducts. For oil production, oily seeds, we have all these starches that have these components and elements that we can use, and the cellulose content and the lining content, we could obtain, separate these products and use them for resins, biopaper, biofuel, bioplastic. So as you can see, there is a wealth of compounds that can be reobtained. So what is it done with this waste? There are conventional practices, there are other sustainable options, and these are some from animal food, filling for landfill, compost, or thermal treatment for energy, but this is the less desirable. So the sustainable option is to value, assess what can be done, have an integrated remediation, circular economy, as Dr. Pérez Cerecedo presented, and bioconversion, which are the assessment strategies that are currently perceived in the academic sector. The extraction of bioactive compounds, bioactive because they have a benefit for health. Polyphenols, carotenoids, terpenoids, peptine, and from residues like peels, seeds, bagasse, and tarts through hydrolysis. These will be compounds high in protein content. The bioactive peptides could be obtained, and they have a good chance to be used. We have a wide array of applications for all of these compounds.
Me adelanté un poquito, ¿sí? Hablaba yo de la obtención
I'm
de
sorry,
compuestos
my
reactivos, de
slides
péptidos
are
reactivos.
okay.
También hablo
Bioactive
de
compounds, bioactive
digestión
peptides,
anaeróbica,
also
llevar a cabo
anaerobic
procesos biológicos, y
digestion,
también por ahí nos mencionaban un
biological
poco acerca de
processes, and we
biorefinería, los
heard
procesos
about
para obtener biocombustibles,
biorefinery
electricidad,
to
calor,
obtain
etcétera, ¿sí?
biofuels,
Los residuos
electricity, heat,
lignocelulósicos son
and
una
the
fuente
lignocellulosic
inagotable de
residues
productos, como
are
podemos ver ahí,
an
todo lo que podemos
endless
obtener,
source
¿sí?
of
A
all
partir de
the
celulosa
things
podemos
that
obtener
are presented
nanocelulosa
on
y
the screen.
celulosa
We
y
could
toda esta gama
obtain
de productos metano, ácido
nanocellulose and
fórmico,
cellulose and
etcétera.
methods,
Pero ¿cómo
formic
llevamos a
acid,
cabo
ethanol, and the
todos
likes.
esos compuestos
But
que recuperamos de los
how,
residuos tienen aplicación
once
en la
we
industria
recover these
cosmecéutica, en
compounds,
envases
how
activos,
could we
alimentos
use
funcionales, porque
these
tienen propiedades
products?
antioxidantes,
Because they have
antiedad,
antioxidative,
en alimentación animal,
anti-inflammatory,
etcétera.
anti-aging
Entonces,
properties.
¿cómo
They can be
podemos
used in
nosotros
animal
llevar a
foraging.
cabo estos
So
procesos de
how could
valorización?
we
Ahí a
conduct
nivel
this
académico en investigación
assessment
estamos hablando de procesos que se producen
exercises?
como
In the
en cascada,
academia,
que lo que
we
hacemos
talk
es
about
extraer algún
cascading
compuesto de interés
processes. We
primeramente,
extract
lo
a
obtenemos de forma
compound
primaria,
of
el mismo residuo
interest.
lo
We have
obtenemos
a
para
primary
convertirlo,
optation.
por ejemplo, para
We,
biocombustible, y
for
el mismo residuo lo podemos
biofuel,
obtener para una
we
tercera extracción. Entonces, de esta manera
we
llevamos
could
a
even
cabo
have
procesos
3
en cascada,
extraction
¿sí?
processes.
También
This is cascading processes.
hay una
And
tendencia
also there
también
is
a
a
hacer también
trend
sostenible los procesos a nivel
to
laboratorio, y
have
estamos hablando de
sustainable
lo que se conoce como
laboratory
química verde,
processes,
utilizar
which
solventes
is
verdes
known
para no
as
dañar el ambiente
green
en todos esos
chemistry
procesos de
or
extracción de los compuestos
green
bioactivos, y utilizar
solvents, not to
tecnologías que
harm
tienen
the
menor
environment,
impacto ambiental.
using
Todo esto se está
technologies that
utilizando
are less
a nivel
impactful
laboratorio. Y bueno,
environmentally. And this is all
¿qué
being
ejemplos,
tested
qué
in the
aprovechamiento
laboratory.
tenemos? En la red,
And
como les
what
mencioné, son más
examples
de
do we
30
have
instituciones
in
de
this
educación superior y
network? As
centros de
I mentioned,
investigación, en
there
los
is
cuales
over
llevamos a
30
cabo todo este tipo de
institutions,
proyectos.
and we
Considero que hay más de
are
100,
currently
200 trabajos ya
working
de
in these
investigación y mucho
projects. I
conocimiento
believe there
generado
is
en
around
todas estas universidades y
150
centros de
to
investigación. En los
200
tecnológicos
projects,
dependemos de una
and
dirección general que
we
es el Tecnológico Nacional
depend
de
on
México, y
the
estamos algunos de los
general
tecnológicos también. Ahí yo
authority,
vengo del
which is
Tecnológico
the
de Durango,
Tecnológico de
entonces lo pueden ver
México.
ahí. ¿Qué
I
estamos
come
haciendo
from
en el Tecnológico de Durango,
Durango,
por ejemplo?
and at my
Estamos trabajando en
center,
la
we
valorización de
are
las percas
working
del
in
agave, ¿sí?
assessing
Se produce mucho mezcal, entonces
the
estamos
leaves
trabajando
of the
con las
agave. There
pencas
is
del
a
agave, las
lot of
recuperamos
mezcal
a través de
production. We
diversos
recover
procesos
the
verdes, como
leaves
ya les mencioné,
through green
microondas de ultrasonido,
processes
sometemos
with
a proceso
microwaves
térmico
and
y utilizamos
ultrasound.
un
They are
compuesto
subject
novedoso
on
que se llama
thermal
NADES,
processes, and we
obtenemos la
have a
celulosa,
new
la
process,
modificamos
what is called
químicamente
NADES.
y obtenemos
We obtain
finalmente hidrogeles que
cellulose,
sirven, por
and
ejemplo, para
at the end
pañales,
we have
sirven para
hydrogels for diapers,
toallas sanitarias, tiene una gran gama de
sanitary
aplicaciones.
napkins. There is a wide
También
array of
estamos trabajando
applications.
para obtener
Also,
algo que
we
se conoce
work
como
to obtain
nanocelulosa. Cuando
something
la
that is
celulosa la
called
convertimos al tamaño nano,
nanocellulose.
tiene
When
propiedades muy diferentes
cellulose
y
is
amplía
shrink to
muchísimo, se
nano size,
diversifica
it
su
has
aplicación.
a lot
También
of
estamos
applications.
obteniendo,
Also,
estamos
we
trabajando con residuos
are
de la calabaza
working
semillera. No sé si
with
ustedes conozcan cómo es el
pumpkin
proceso, ¿verdad? Entonces, en
residues,
este caso,
and I
lo
don't
que
know if you are
hacemos es
familiar with this. In this
recogemos
case,
el
we
residuo de la
collect
calabaza,
the
la
pumpkin
separamos, la
waste,
trabajamos en
we
conjunto, la
separate it,
separamos en
we
pulpa y cáscara, llevamos a
separate
cabo
it in
procesos de
pulp and
extracción,
skin.
obtenemos diversos
There are
compuestos como compuestos
extraction
fenólicos,
processes. We
pigmentos,
obtain
carotenoides que son antioxidantes, fibra
phenols,
dietaria, también de
carotenoids,
forma
dietary
mixta
fiber,
también hacemos lo
and
mismo, y de
also
esta manera
we
podemos aprovechar todos estos compuestos que
obtain
están
all
presentes y
these
aprovechar ese
compounds,
residuo que se
and we
genera en los
leverage
campos. También
on the
trabajamos con
waste.
jícama, la jícama de
We
descarte. En la
also
mañana
work
hablaban de
with
que el
jicama,
consumidor cambiamos, queremos
and
frutas perfectas, no hay frutas
earlier
perfectas,
today
¿verdad?
we
Pero sí
heard
podemos
about
trabajar
changing
con
the
aquellas
mindset of
imperfectas que son consideradas
consumers.
merma
There
o
is no
desperdicio,
perfect
y
fruit.
hemos
We
logrado
can
obtener
use the
almidón
waste, and we
polisacárido,
have
¿sí?
managed to obtain
En un
starch
centro de
and
investigación que es el CIAD
polysaccharides.
Hermosillo, están trabajando
At
con
the CIAD
residuos
in
del mango a
Hermosillo,
través de
they are
diversos
working with mango waste
estrategias. Es un
through
enfoque
different
multidisciplinario el que han
strategies. This is a
trabajado ahí.
multidisciplinary
Los
approach.
subproductos del mango
And the
pues son
byproducts of
numerosos, como
mango are
ustedes ya se
several, as
imaginan,
you
fruta en
can
mal estado, bagazo,
imagine.
cáscara, hueso y semilla. Y todo eso se
Rotten
utiliza
food,
para nuevos productos y
the
para la
seed,
alimentación.
the
animal.
peel, and this is
También
used
ahí
for
mismo en el CIAD,
byproducts
este
and
proyecto
animal
ha
feeds.
producido resultados,
Also
¿verdad?
here
Que,
at
que se
CIAT,
traducen en publicaciones. Por ejemplo, en este caso
they
se generaron
have
12 artículos científicos.
12
Se generó
scientific
también
publications.
diversos alimentos en que a
Also,
través de
they
procesos de
have
extrusión,
managed
de
to
extrusión, se
produce
mezclaron residuos
different foods
del
through
mango y se
extrusion
obtuvieron
processes. They
extrudidos que son como
blended
botanas también. En el
these
mismo
snacks
CIAD
from
se ha
mango.
trabajado
And
también
also
con
at
los subproductos
CIAT,
derivados de la
they
obtención
have
de aceite
worked
de aguacate
with
y pues una vez que se obtiene el aceite de
avocado
aguacate en frío o
oil
en caliente se obtienen
byproducts,
subproductos
either
que
hot
también
or
tienen una gran gama
cold.
de
There are different
aplicación.
byproducts, a wide array of applications.
Y un ejemplo de cómo la pasta de aguacate
An
ya sin aceite
example
se
of
utiliza para
how the
desarrollar chips
dry
funcionales, por ejemplo.
avocado
¿sí?
paste is used
También
for
en el
functional
CIAD, pero en
chips,
Culiacán, se está
and also at
trabajando
Culiacan's
con
CIAT,
las partes
they are
de
working
la planta, raíz, hoja,
with
tallo y fruto de la berenjena, con la
the
finalidad de encontrar
eggplant
diversas
stems,
aplicaciones
leaves,
y
and
se
roots
obtuvieron
in order
metabolitos
to
secundarios
find
como los que ya
different
mencioné que tienen
applications, and
propiedades
they
bioactivas también
obtain
y se vio
secondary
su
metabolites that
aplicación.
have bioactive
En Torreón, en la
properties.
Universidad
In
Autónoma de
Torreón,
Coahuila, se
at the
identificaron las causas de
Autonomous
pérdidas y
University of
desperdicios del
Coahuila,
melón
they
y se
analyzed
encontró que más del
causes for
50%
waste
del
of
melón en la
cantaloupe,
huerta se
and it was
pierde.
found that
Entonces, ese
close to
melón pues tiene todo un gran
50%
potencial.
of
Actualmente se
cantaloupe is
utiliza en la
lost
alimentación de
at the
animales
orchards.
domésticos,
Usually they
abono
are
al
used
campo, pero
for
también
pet
se
food,
dona a los bancos
like
de alimentos.
fertilizer or
Finalmente,
cover, but
quiero
also is
mencionar
donated to
que
food banks.
para la
And last, I
medición
would like to
de qué
state
impacto está
that
teniendo esas
in order
estrategias de
to
valorización,
measure the
ya hay varias
impact of
publicaciones
this
en las que se están
assessment
evaluando precisamente
initiative,
este
there are
tipo de
some
metodologías
publications where
para ver lo que
these
estamos haciendo de
methodologies are
valorización, qué
published
impacto
to
tienen disminuir precisamente las
disseminate this
emisiones de gases de
information
efecto
and the
invernadero. Y con eso
impact
termino.
they
Muchísimas
have to
gracias
reduce
y a
the
sus órdenes.
greenhouse gases. And this is all I have to present for you. Thank you very much.
Muchas gracias, doctora
Thank
Juliana
you,
Morales Castro,
Doctora
por su
Juliana
excelente
Morales
presentación.
Castro, for your
Y me
excellent
permito
presentation.
dar
And now I would like
invitación muy
to
especial a la doctora
ask
Luisa Marín de Bloch para
Dr.
que
Luisa Marín
nos
de
haga
Bloch
conocer sus criterios acerca de biochar.
to share her presentation regarding biochar.
¿No? Allá, ok.
Hello,
Hola,
yes.
buenas tardes. Me voy a
Hello,
poner
good
un poco de pie.
afternoon.
Y los invito a que también
I
se pongan
will
de pie, han
stand up
estado mucho
also.
tiempo
And please,
sentados.
you
Vamos a
all, you
darnos
can stand
30
up. We
segundos
have been
para estirar las
sitting for
piernas,
so
los
long. We
brazos,
can
para cambiar un
stretch
poco
our
y ya casi
legs and
terminamos.
arms for
Muchas gracias.
30 seconds just to
Sí, un poquito,
change a
porque
bit,
ha sido
a
una
little
jornada
bit.
bastante
This has been
intensa.
pretty
Y
intense
mientras hacemos este ejercicio de
day.
despejarnos un poco, quiero hacer dos
And while
aclaraciones.
we stretch,
Agradezco
I
mucho
would
al CIMIC que me haya
like
subido de nivel,
to
pero no soy
clarify,
doctora.
I thank CIMIC that
Gracias. Y
they
tampoco soy la vicepresidenta
increase
del
my
IBI, soy tesorera y
level. I
fundadora,
am not
nada
a
más porque
doctor,
no
but
se vayan
thank
a
you. And I
esas
am not
sensibilidades por ahí,
vice
entonces nada
chair.
más
I
quería
am
hacer esas
also
aclaraciones.
manager and
Muchísimas
treasurer.
gracias. Y
Thank you
ahora sí,
very
si gustan
much.
tomar su asiento
So
ya para
now,
comenzar. Y termino.
uh,
¿Alguien aquí ha escuchado hablar del biochar
I
anteriormente?
am okay.
Levante la mano.
I don't know if you have heard
Muy
before
bien.
biochar. Please
Muy bien,
raise
muy
your
bien.
hand.
Para aquellos que no han tenido la
For those of
oportunidad de
you that
conocer
are
qué es el
not
biochar,
familiar
es
with
cuando
biochar,
estas dos
is
intervenciones que nos
when these
compartieron
two
en la casa, en
interventions
el campo,
that
en las
were shared
cadenas,
at
ya no
home, in
hay
the field, in the
solución para la
chains, when
gestión de
there
los
is
residuos.
no any
El biochar puede
solution
ser
for
una muy
waste
buena solución.
management.
¿Por qué? Porque el
Biochar
biochar,
could
a través
be
de un
a good
proceso que se llama
solution because
pirólisis,
through a
transforma
process
esos
that is called
residuos o esas
pyrolysis,
biomasas residuales que
transform
no tienen
these
un mercado
residual
secundario y que
biomass
pueden
that do
tener
not
una
have
vida
a place
adicional,
in
que
a
se pueden
secondary
convertir
market
en tres
to have an
subproductos, porque
additional
recordemos que la
life
materia
transforming
no se
in
destruye,
3
solamente se transforma.
byproducts. Let's remember
Y
that
la materia,
matter
las biomasas
is never
residuales se
destroyed,
transforman
only
en biochar,
transformed.
en gas de
And
síntesis y en
biomasses
bioaceite.
are transformed in
Aquí de
biochar,
esta
synthetic gas,
lámina, el
and
proceso
oil.
más
On this
importante y
slide, the
del
most
cual surge
important
el
process
biochar
and the
o más bien
source of
donde nos colgamos
biochar,
las
or
personas que
where
producimos
we
biochar es a través del proceso
hang
de
on to
fotosíntesis.
biochar, is
La
the
naturaleza hace el
photosynthesis.
proceso de
Nature other
captura el dióxido de carbono,
leads
libera el oxígeno y
photosynthesis,
el carbono ya
sequestrates
está en esa
carbon,
biomasa.
releases
Está en nosotros
oxygen, and
si la
carbon is in
transformamos,
the
la ocupamos
biomass.
y
It is
la
up to us if we
valorizamos.
transform it,
¿Qué hace el
use
proceso de
it, and
pirólisis? El
value it.
proceso de pirólisis
So
es una
pyrolysis
transformación a
process
altas
is
temperaturas de esta
a high
biomasa.
temperature
Son unos hornos
transformation of
grandes
biomasses.
donde
These
entra
very
la
big
biomasa
furnaces
y digamos
where
que arriba de
biomasses are
550
entered
grados
and
centígrados
above
se considera
550
pirólisis.
degrees
Abajo de esa
Celsius, it is
temperatura
where
se hace un
pyrolysis
carbón,
is
pero no se
considered.
considera
Below
pirólisis
this, it is
porque no
carbon,
se
but
fija
it's
ese
not
contenido de
pyrolysis
carbón.
because this
En esa
carbon
fijación del
content
contenido de
is not
carbón es
fixated.
donde
It is
está ese
through this
proceso
fixation
que nos va a
where
dar
this process
la
lies
permanencia
and will give us
del carbón, válgase
permanence
la redundancia.
of carbon.
¿Y por qué esto es importante?
So
Porque
why is
el
this
biochar
important?
contribuye a tres
Because
cosas muy
biochar
importantes.
contributes to
Una,
very important
remueve
three
dióxido de
things.
carbono de la
One,
atmósfera.
it
No por
removes
sí mismo, sino
CO2
los
from
procesos
the
que hace la
atmosphere,
naturaleza,
not by
pero al
itself, but
aprovechar, al
through the
revalorizar
nature
esos
process
recursos,
when
en vez de que se
reassessing
pudran,
these
se genere
resources.
metano, se quemen,
Instead
se
of
haga CO2 o se
leaving them
vayan a
to
los rellenos
rot,
sanitarios,
methane
nosotros los transformamos,
generation, burned or in landfills,
estabilizamos el
we
carbón
transform
y
them,
al
we
integrarlo en el suelo como
stabilize
un
carbon,
mejorador de
and
suelo
while
o en materiales de construcción,
reintegrating
podemos
it as a
asegurar,
soil
científicamente,
enhancer,
no lo estoy diciendo
we
yo, hay
can
muchísimos papers relacionados
scientifically
sobre la permanencia
secure.
del
It is
biochar, que
not
puede
me
ser de
saying,
100
it
años
is
hasta 1000 años, dependiendo la
science-based. It could
temperatura,
be
o sea, la
100 to
temperatura en la que se
1000
produjo
years,
y la
depending
temperatura
the
en la que se,
temperature it
digamos, se
was
secuestra ese
produced
carbono en el
and the
suelo.
temperature of
Si se pone en el
sequestration of
suelo,
this carbon
esto
in the
es más o
soil.
menos
So this
microscópicamente
will
cómo
be
es el
at a
biochar. Tiene una
microscopic
porosidad
level.
increíble.
It has an
Entonces, cuando
amazing
se
porosity.
ingresa al suelo,
So when it
cuando se
is
mezcla con los suelos,
integrated in the
que hay
soil,
que ser
blended,
cuidadosos también en qué
we
suelo se
must be
utiliza, cuáles son las
careful
condiciones
on
del suelo,
which
qué
soil
cantidad se
types
aplica.
to
Pero
introduce
si está un suelo
and the
degradado
amount it
y
is.
nosotros
If it is
aplicamos
a
biochar
degraded
y digamos si
soil
lo
and
activamos, ¿qué es
if
activar?
we
Lo mezclamos con composta, le
apply
ponemos microorganismos.
biochar blended
Esto
with
es un
compost or with
condominio de
microorganism, this
microorganismos y
will
de
be
materia
like
orgánica.
a
No
condominium
compite.
of
Y al ser tan poroso, lo
microorganisms
que
and
ayuda el
organic
biochar es
matter.
a
And while
reducir
being porous,
gradualmente el consumo de agua
gradually it
y a la
reduces
retención de
water
nutrientes, lo cual también
use
puede llevar
and
a consumir
nutrients
menos fertilizantes
retention that
químicos. El biochar
could
no es un
lead
fertilizante,
to
quiero hacer la
use
aclaración,
less
es un mejorador de
fertilizers.
suelos
It is
que
not
puede
a
ayudar a
fertilizer,
reducir el
it is a
consumo de
soil
fertilizantes químicos
enhancer that
gradualmente.
can lead to a
Hay que hacer
reduction of
diferentes
chemical
análisis del estado
fertilizers. You need to
del suelo,
conduct
cuál es
different
el cultivo que se
soil
está llevando, la
analysis
temperatura, etcétera.
regarding the
Pero una vez que
crop,
se
the
tiene, digamos,
temperatures,
esa
but once
ecuación,
you have
los expertos
all the
pueden
elements
hacer, o
of
sea, los
this
expertos me refiero a
equation,
los
the
agrónomos, a
experts,
a las
meaning
personas que están
agronomists or
más versadas
farmers,
en el
people with
biochar,
the
teniendo
knowledge
en
on
cuenta el pH,
biochar,
la acidez,
considering
el contenido
pH
de
or
cenizas y los nutrientes que
acidity,
existen en el suelo,
ashes
pueden hacer una
content,
recomendación.
nutrient
También es
contents in the
importante
soil could
considerar que
issue a
no todos los
recommendation.
biochares
Also,
son
it is
iguales.
important
Cada
that
biochar
not
va a
all
depender su
biochar
composición
is
o
equal.
caracterización de
It has,
acuerdo con la
each
materia
one has
prima
a
con la que fue
different
elaborada.
composition because
¿Y a qué
it
me refiero? Materia
was
prima son
produced
estas
from
biomasas residuales.
different
Puede ser madera, puede ser
raw input like
rastrojo
wood,
de maíz o los esquís, ¿no?
stubble,
Técnicamente,
or
semillas, se puede hacer.
seeds.
Hay que tener un pretratamiento de la biomasa. Si
There
no
has to
no es
be a
no es
pre-treatment
como
for
tan lineal la
biomass. It
producción
is
de biochar.
not
Sin embargo, se puede
such
lograr
an
aquí
ideal source for
en la mesa de
production,
registro.
but
Dejé
here
unas
in the
muestras de biochar que es de
registration
rastrojo de
table,
maíz, por si quieren
I
llevarse
left
algunas
some
bolsitas
samples.
para
If
que lo
you
vean, lo
would like to
sientan,
take
lo
some
huelan, que
little
tiene que
bags,
estar
you
sin
can
olor. Si
feel
tiene
it,
olor es que no está bien cocido
you
ese
can
biochar.
smell it. It has to be odorless. If it
Perdón.
has an
Estos son
odor,
algunos,
it means that it was
voy a
not
ser muy
properly
reiterativa
prepared.
y a lo mejor
I will
repetitiva
be
durante la
perhaps
presentación en los
repetitive and
beneficios y los
reiterative
retos
on the
del
benefits
biochar,
and
pero bueno,
challenges of
ya les mencioné que
biochar.
tiene la capacidad de
So
retención
I
del agua
share
y
that
de los
it
nutrientes
can
al
retain
evitar
water
la
and
lixiviación.
nutrients. It prevents
secuestro del carbono a largo
lixiviation.
plazo y que
It is
lo que se llama la
long-term carbon
permanencia. Otra
sequestration.
de las ventajas que tiene
Another
hacer dentro
word
de las
is
soluciones
permanence.
basadas en la
Another
naturaleza
advantage in
para la
nature-based
generación de créditos de
solutions
carbono
for
es
carbon
que el
credits
riesgo de reversa,
generation
¿y qué es
is
el riesgo
that
de reversa? Es
the
decir, que se vuelva a
reversing
liberar ese
risk
CO2 que está
that
capturado
this
es
CO2
muy poco.
will
¿Por
be
qué? Porque para
released
que se
is very
vuelva
low
a liberar
because for
ese
it to
CO2,
be
la única
released
manera es que se
again,
utilice como
this
combustible.
CO2 is
Entonces,
that
y
it is
dentro de las
used
metodologías
as
para la
fuel.
generación de créditos de carbono,
And for the
no está permitido
methodologies for
el
carbon
uso del biochar
credit
como combustible. Entonces, esa es una de las
generation,
ventajas que
it
tiene
is not permitted to use
contra
biochar
otras
as a fuel. So this is
tecnologías
one
que se
of
llaman
the
CDR, que es
advantage against
la
other
remoción de dióxido de
methodologies,
carbono de la
which
atmósfera.
are CDR,
Impulsa
which
tiene también
is
unas
carbon
ventajas
dioxide remotion technologies.
sociales,
It also
económicas
has
y
social,
ambientales,
economic,
que es
and
la
environmental
generación de empleos,
advantage,
la
which
mejora en la
is
salud dependiendo de las condiciones de la
job
biomasa. Si hay
generation,
una
health
biomasa acumulada, hay lugares
improvements.
donde
y
hay aserraderos,
There
donde
are
se
some
acumulan los residuos de madera, se
sawmills
acumula el
where
aserrín,
wood
se
residues
prende,
are
hay un riesgo de incendio, la
accumulated.
población que
There
regularmente
is the
son
risk of a
pues,
fire,
comunidades pequeñas,
and the
lo están
population
respirando
in
todo el
these
tiempo, es
mills
un
are
riesgo
small
real, ¿no? También
communities. They could be
principalmente son
smelling
ese
all
tipo
these
de
fumes.
riesgos de salud
So
o
these
cuando se
are the
pudra, cuando
health
está
risks,
en
or
los
when
rellenos
it is
sanitarios,
rotten, or when
los animales que se puedan generar
these
alrededor.
are in
Entonces,
landfills. There
se
could
generan nuevos
be
conocimientos porque para procesar
animals
biochar,
breeding around. So in
para
order to
procesar el
process
biochar se requiere de la
biochar,
adquisición
it is
de algunas
required to
habilidades y conocimientos adicionales. Un
learn a
ingeniero
few
industrial
skills.
conoce
An
las máquinas,
industrial
conoce todo,
engineer,
pero no
he's
sabe de
familiar with
pirólisis, entonces
machines, but maybe
puede
he
ir
doesn't
adquiriendo
know
esas
about
capacidades que después
pyrolysis. So
le van a
maybe they
permitir
can
a lo mejor a
learn
él
about these
acercarse a otra
skills that
industria, a lo
will
mejor a la gente de la comunidad de grupos
motivate them to
si
approach
no
some industry.
tradicionalmente, a veces
Members
es
of
difícil que
some
tengan
communities
alguna
also could
generación
do,
de
because
empleo como
otherwise
las
it could
mujeres
be
y los
difficult,
jóvenes.
or
Aquí
like job
pueden ir
generation
creciendo.
for
¿Por
women
qué?
and
Porque,
young
por ejemplo,
people.
en la
Here they can
logística,
grow
la
because
logística es
in the
clave para los
logistics
proyectos de biochar.
chains,
Los
this is
proyectos de biochar tienen
key
que
for
ser locales.
biochar
Son
projects
soluciones
because
locales
they
con un
have to
impacto
be
global. ¿Y
local.
por qué digo
These
que
are
con un
local
impacto global y
solutions
de
with a
verdad no es
global impact.
exageración?
And
Es
why I say this,
todos
and I
vivimos
am
en
not
este espacio.
exaggerating,
No
because we all
importa
live
dónde
in this
contaminemos, a
space.
todos
It
nos
doesn't
afecta.
matter
No
where
importa
we
dónde removamos
pollute, it
dióxido de
affects
carbono de
us.
la atmósfera,
It
a todos nos
doesn't matter
beneficia.
where we
Entonces,
remove
hacer esos proyectos locales tienen un impacto
carbon
global,
from the
¿no? Y
atmosphere.
además tienen
We all
la
benefit.
ventaja que
So
pertenecen a la
thus the global
categoría de los
impact. So
créditos de
they
carbón
belong to the
CDR,
category,
que
to the
son
CDR
créditos de
carbon
carbón
credits, which are carbon
éticos,
credits,
íntegros y con
which
un
are
nivel de
ethical
rigurosidad muy
and
fuerte
with
que
a
además de la
very
metodología y
strong
del
level
proceso de
of
MRB de
rigor
monitoreo
through
reporte
the
viene un tercero a hacer la
MRB
verificación de
monitor
que
and
realmente
report.
es
A
una biomasa
third party
residual, de que tenemos unas
verifies that
condiciones de
this is
trabajo sanas
residual
para
biomass, that we
para los
have
empleados que están
healthy
haciendo su
work
transformación,
conditions for
que las
employees,
emisiones que
that
nosotros
emissions
dijimos que
that
se
we
generaron desde que
said
tenemos la
that were
biomasa hasta que entregamos el
generated from
biochar están
since we
realmente
receive
o sea, están
the
calculadas de una
biomass
manera
until we
correcta
release
porque los proyectos
biochar
de biochar
are
para créditos de
properly
carbono son cero
calculated, because
negativos,
these
es decir,
projects for carbon
cualquier neto
credits
cero, mejor
need to
dicho,
be
cualquier
net
emisión que se
zero.
genere
Any
en la
emission
producción del biochar tiene que ser
generated in
descontada de las
biochar
toneladas de
production needs
CO2
to be
equivalentes.
discounted from the equivalent
¿Y cuántas toneladas de
carbon tons,
CO2
and how
equivalentes se pueden
many
generar por una
CO2
tonelada de
equivalent
biochar?
tons could be
Hasta 2
generated
o
with one
2.5.
biochar tons,
Por
up to
una
2
tonelada
or
de biochar, dependiendo la
2.5.
temperatura,
For
la
one
biomasa. Hay
biochar
biomasas
ton,
que tienen
depending
más
on the
lignina,
temperature,
más hemicelulosa, que tienen,
the
que tienen más
lignin
carga,
and
tienen más
cellulose
densidad. Esas
content
biomasas pueden
varies
generar
on
hasta
different
2.5
biomasses,
toneladas
and
de
there
CO2
could be
equivalente
up
por
to
una tonelada de biochar
2.5
producida.
CO2
Este es un dato también
equivalent
importante que
tons
que
per
no
one
compartí.
biochar
Por
ton,
cada tonelada
and
de
per
biomasa se
one
genera
ton
aproximadamente
of
un
biomass,
30% de
there is
biochar, un
approximately 30%
30%
of
de gas de
biochar,
síntesis 30% synthesis gas, and 30% bio oil. It's not always on the same share, the bio oil, because there are some biomasses that generate less bio oil, but always synthetic gas, and most of the systems for pyrolysis are self-sustainable. They are fired up to preheat the furnace, and once the biomass transformation begins, they are sustainable because the same synthetic gas keeps them fired. If there is an excess of synthetic gas, then this excess can be sent to the dryer for biomasses that have over 20% moisture. They need to be dried. And if still there is excess, or you don't want it to dry, because if you are using corn stubble that is dry enough, then you can generate power through pyrolysis, power as in electricity. And like everything, it has its ups and downs, pros and cons, and we are no exception. We have challenges. One is variability in effectiveness, meaning that this will rely on the quality of raw material. Unfortunately, biochar is millennial. Its origin, the first documented was in Brazil, and it was produced through time. This is a new industry. It is 10 years old. It is not standardized. It has grown on pyrolysis technology and quality standard, on pyrolysis processes and how to keep logs, but still there is a lot of variation in production, and depending on so many things, biomass and the people feeding the system. If it is a cold day, if it is a hotter day, so there are different challenges to improve it, and also in the application, because biochar is thought about the end use, the particle size, where are you going to apply it, if it is a perennial crop, if it is for cement, if it is for concrete, if it is for a seasonal crop. So with that in mind, you decide on the particle size, perhaps the pyrolysis temperature, and the application method, if it is granulated, if it is a pellet of it can be applied as it was obtained from the pyrolysis plant. The challenge is availability of the biomass along with high production costs. And when I mean high production costs, the initial investment cost for a biochar factory is really high, because you need to install pyrolysis machines, and something that you need secure is the supply of biomass at least for 10 to 15 years, because you will not make an investment of $3-4 million, and by year 4 you run out of biomass. So investors, when they assess feasibility of biochar projects, the first thing they ask is you have yearly agreements for biomass supply for how long, and anybody could lose an agreement, but at least there is a guarantee of the interest and the final use of biochar. Quality protocols are required, and right now they are going on a standardization process. You require a strict monitoring to make sure that you will not harm if it is applied in the field or in construction materials. They will maintain quality. And also something that I think is complicated, and it is a constant, and it is not only regenerative agriculture or carbon agriculture, but it is the adoption by farmers. It doesn't matter how much we tell them that they will reduce their input and and water, gas, they will increase their yield, their soils, health will improve. They need to see it. They won't believe until they see it, so we must invest in transference of knowledge, technology, with demonstration plots at least 2-3 years, that to show that when you apply something black, the plant will not die, but on the second year, the plant will use less water. The third year, everything's okay, but by the fourth year, if it is a drought period, the plants will continue to bloom. But this is only through peer-to-peer knowledge transference. And without a specific order, here I am representing the Latin American Institute of Biochar. We are advocating for biochar adoption in Latin America. The countries are not in a specific order. They are just there to mention that there are some projects there in each country. And the conclusion is that it improves the soil quality. This will be the main takeaway on biochar for recarbonization of soils and decarbonization of agri-food systems, is that this product improves the health of the soil, sequestrates carbon in a sustainable way, reduces agrochemical products, reduces greenhouse gases emissions, the use of agricultural inputs, and for the social and economical sector, it contributes to 12 to 17 Sustainable Development Goals from UN. Thank you very much.
Muchísimas gracias por su presentación.
Thank you very much for your
La
presentation.
ronda de preguntas y respuestas.
We will begin the Q&A
quisiera-
session.
Rogarles de manera encarecida que hagamos una buena administración de los tiempos para poder cubrir las preguntas que vienen a continuación. Doctora Vero Pérez, el ICA institucionalmente y usted personalmente han posicionado el concepto de bioeconomía como una fórmula de solución estructural para la crisis climática actual. Le preguntamos cuáles son los próximos pasos en esta dirección, tanto aquí en México como en la región.
Voy a ser muy breve. Desde ICA, como dice usted, lo estamos promocionando. Creemos que la bioeconomía es una solución. Estamos trabajando a través de 2 redes, la Red Mexicana de Bioeconomía Circular, en el caso de México, unida a la Red Latinoamericana de Bioeconomía, para promocionar con los gobiernos, llevarles a los gobiernos las cualidades, las ventajas, las bondades que tiene la bioeconomía y crear estrategias, crear políticas que hagan pues toda una estrategia en pro de la agricultura, en beneficio de los agricultores, en beneficio de los ganaderos, de crear estructuras de bioeconomía que permitan mejorar las condiciones de producción y mejorar las condiciones climáticas.
Muchísimas gracias. Doctora Juliana Morales, hemos visto con mucho interés además la gran labor en materia de investigación que están realizando a partir de generar dentro de la cadena de valor probablemente lo que es el último eslabón, el que faltaba, que es el reciclaje. Quisiera preguntarle, ¿cuál es el principal reto que tienen ustedes, los científicos, académicos, estudiosos, investigadores, para trasladar este nuevo conocimiento para su aplicación a nivel social, a nivel económico? A partir de una inquietud que precisamente tenemos nosotros acá en CIMIT, que toma hasta 10 años para que el productor se beneficie de la investigación, de las mejoras a nivel de generación de ciencia y tecnología que hacemos acá. Ese es el gran desafío permanente. ¿Qué están haciendo ustedes al respecto?
Sí, pues qué bueno que lo pregunta y que lo menciona, y efectivamente ese reto que tenemos. En muchas de nuestras instituciones no existen los mecanismos para realizar esa transferencia de tecnología. Al menos en los tecnológicos del país, los tecnológicos federales, que dependen de una dirección general, el Tecnológico Nacional de México, aquí en México, no tenemos una oficina sólida, fuerte, con experiencia en estos procesos de transferencia tecnológica. Y bueno, ese es el principal reto, porque ya hay mucho conocimiento generado, pero nuestro deseo, nuestra inquietud es ahora transferirlo, pero también para ello necesitamos evaluar primero el potencial comercial que tienen estos procesos desde el punto de vista económico, y no hay recursos. Lamentablemente, también el CONACYT ofrecía este tipo de apoyos para determinar el valor comercial de tecnología o conocimiento que pudiéramos hacer, y pues no se tiene. El otro reto es que no tenemos suficientes plantas piloto donde pudiéramos ya escalar los resultados del laboratorio, escalarlos a nivel planta piloto, que nos diera ya una estimación de qué tan viable o qué no es ese proceso, ¿no? Y el siguiente reto, pues es lo que mencionaban, medir las emisiones, en cuánto estamos decarbonizando, ¿verdad? Esa parte de los residuos, ¿no? Entonces creo que esos serían los principales retos en este momento.
Muchas gracias, doctora. Señora Luisa Marín, quisiera hacer una pregunta muy concreta. ¿De qué manera instituciones como CIMIT, ICA y el FIRA podrían apoyar a la masificación del acceso y el uso y la producción de biochar como una solución viable a la problemática que nos enfrasca hoy?
Ya. Muchas gracias por la pregunta. CIMIT, desde su alcance, el extensionismo que tiene en campo para poder poner esas plataformas experimentales para poder demostrar las plataformas experimentales y el alcance que tiene para llegar a productores, a pequeños productores, con la confianza que transmite el CIMIT, poder invitarlos a que, como decían hace rato, ese pedacito, ¿no? Ir ganando pedacitos para poder hacer esas demostraciones ya en campo para que se vaya haciendo esa adopción. Con el ICA, con el alcance regional que tiene y con esta red tan grande que puede subir a las políticas públicas, porque hay ejemplos en otros países, en los países nórdicos. Dinamarca acaba de sacar una estrategia de biochar ya a nivel país. Suecia tiene algo similar, tienen un impuesto para la agricultura, para el carbón. Entonces, hay otros ejemplos. En Estados Unidos tienen un estímulo, no sé cuál sea la palabra correcta, un estímulo por parte del Departamento de Agricultura para que los agricultores compren biochar, apliquen biochar en sus parcelas, y ellos le pagan al productor de biochar. Están creando esas cadenas y tienen que ser también locales. Y por supuesto, FIRA, pues con la parte del financiamiento, que puede ayudar a esas soluciones locales para algunas cadenas muy bien identificadas de proveedores de algunos residuos que en este momento no tienen un mercado secundario que se puedan gestionar. Y además, a través de FIRA también se puede hacer la red de distribución del biochar como un biofertilizante, si se activa con microorganismos o si se pone con algún tipo de composta. Así lo veo.
Muchas gracias. Muy, muy amable, Luisa. Tengo una pregunta para nuestras tres panelistas que viene precisamente de alguien que nos acompaña esta tarde acá, que es el doctor Pedro Maldonado. Y dice concretamente: si la ciencia ya conoce el impacto de los bienes de consumo y el efecto de toda la logística, desde producción hasta el consumo, ¿qué propone para que la industria y la agroindustria haga tome acciones sobre la contaminación, el desperdicio y consumo de energía fósil? Esto va de la mano con la pregunta, ¿cómo influir en los consumidores para aportar en las soluciones propuestas por la ciencia? Doctora.
Hace un rato, perdón, decía Luisa algo bien importante. Ya hay estrategias en Europa, ya hay normativas en Europa. Creo que lo que se debería hacer es una normativa clara alrededor de todo este problema de gases efectos invernaderos, como que fomenten el desarrollo de la bioeconomía, el desarrollo de la agricultura regenerativa, desde una política que marque directrices hacia dónde se debe de ir en estos temas y que pueda tener también un beneficio, que venga de la mano de un beneficio para los productores que lo estén haciendo bien. Creo que en el caso del consumidor es informar al consumidor. La mayoría de los consumidores no sabemos que estamos aportando negativamente a la generación de gases efectos invernaderos por dejarnos de comer una manzana o por tener mayor cantidad de basura, o simplemente no sabemos que por todos estos paquetes que recibimos diariamente de Amazon, de cualquiera de estas empresas, estamos generando un efecto negativo en el medio ambiente. Entonces es ir de la mano con la política para fomentar estrategias de bioeconomía, de economía circular, de agricultura regenerativa, con toda esta parte de generación de conocimiento al consumidor. Y creo que es de darle el conocimiento, ¿no? No solamente decirle, no lo hagas, no se puede, sino es, no lo hagamos por estas circunstancias.
Sí, gracias por la pregunta muy importante. ¿Cómo le hacemos? Bien, en el caso de cómo aplicar ese conocimiento que ya hay en todas las universidades y centros de investigación, es conveniente las alianzas, lo mencionó ahorita nuestra panelista anterior, Patti. Es urgente establecer alianzas entre el sector industrial y la academia. Creo que ahí reside, porque muchos de ese conocimiento que tenemos en las universidades, ellos cuentan con la capacidad precisamente para identificar el potencial y para convertirlo en una innovación. Pero también desde las oficinas de transferencia, que bueno, en muchas universidades sí las hay, en los tecnológicos no, pero las universidades como la Autónoma de Nuevo León, la de Chihuahua, la UAM, el Politécnico, pues sí cuentan con ello. Entonces es cuestión de elaborar esos desarrollos tecnológicos como paquetes tecnológicos y ofrecerlos también al sector industrial. Por otro lado, con respecto a políticas, es importante mencionar que al final de la administración anterior se estableció un grupo de trabajo multisectorial que coordinaba la Semarnat para establecer las bases para instalar el Programa Nacional de Pérdidas y Desperdicios de Alimentos en México. Desafortunadamente, como muchas iniciativas, en el 2017 se quedó en la charola y no se retomó. Estuve hace 2 semanas en un panel, en un curso de capacitación organizado por el Comité de Pérdidas y Desperdicios del Grupo G20 en Brasil y presentaron ejemplos de Chile, Uruguay, Ecuador, Argentina, que tienen ya su programa nacional de reducción de pérdidas y desperdicios. Entonces, México se encuentra sumamente atrasado en este tema. Ojalá que con la nueva administración desde la Secretaría de Recursos Naturales y Medio Ambiente, la Semarnat, ojalá y se retome este tema, porque ahí están las bases, ahí está todo el conocimiento y solo es necesario que se impulse desde el gobierno, es necesario trabajar en ello. Y bueno, nosotros hemos trabajado y seguimos trabajando desde cada uno de los estados donde nos encontramos los profesores en realizar campañas de sensibilización, de concienciación sobre el tema. El 29 de septiembre fue instituido en el año 2020 o 22, no recuerdo bien, como el Día Internacional de la Concienciación sobre el Desperdicio de Alimentos. Entonces aprovechamos esa semana para hacerlo. Trabajamos también en conjunto con My World México, que se encarga de promover los ODS la segunda o tercera semana de septiembre. También trabajamos con ello y en cada estado realizamos actividades dirigidas precisamente al público en general sobre la importancia de esto. Pero debe haber un lenguaje común desde todos los niveles de gobierno, tanto del federal, el estatal y el municipal, que se hable, así como se habla de salud, de diabetes, así debe de hablarse de sistemas alimentarios sostenibles o el desperdicio de alimentos. Gracias.
Pues ya nada más para complementar un poco lo que compartieron Verónica y Juliana, es la educación en las escuelas, o sea, implementarlo, empezar desde chiquitos. Yo pertenezco a la generación que no se hablaba de ecología ni de ahorro, lo más que había era ciérrale a la llave del agua y después empiezan, pero no es suficiente. Hay que reforzar, reforzar, reforzar y a lo mejor a los niveles secundaria y preparatoria, invitarlos a brigadas con un poco más de conciencia o de recolección de basura o algo que nos duela un poco lo que estamos haciendo. Y las industrias, si los incentivos no los invitan a descarbonizar o a tener mejores prácticas, pues a lo mejor las sanciones los invitan.
Muchísimas gracias. Solamente me resta agradecer a Verónica, Juliana, Luisa, por su brillante participación esta tarde, por tu cumpleaños, y a todas ustedes profundamente agradecidos por su participación. Muy buenas tardes.
Vaya con el último panel, rico e inspirador como pocos. Vamos a ir cerrando el día. Sé que esto se va poniendo cada vez más interesante, pero también sé que ya a todos nos empieza a premiar el hambre y el cansancio. Entonces, vamos a ir cerrando ya el día y para ello voy a invitar que nos acompañe el ingeniero Ayala y le voy a pedir algo imposible, ¿por qué no? Y es que nos regale una reflexión sobre el día de hoy.
Bueno, pues buenas tardes y buenas noches. Ya nos agarró aquí el final de la jornada. Voy a ser muy breve, dada la hora y dado también este momento previo a compartir con todos ustedes los sagrados alimentos. Y sí, básicamente es una reflexión, un par de reflexiones muy, muy concretas. A partir de lo que estuvimos escuchando durante estas casi 6 horas, poco más de 6 horas, en donde pues los distintos ponentes nos presentaron desde conceptos básicos con definiciones basadas en resultados hasta acciones concretas de buenas prácticas basadas en la ciencia, en la tecnología y en la innovación que ya se están implementando, lo cual es una grata sorpresa para muchos, pero es una realidad. Entonces, eso incluso nos muestran datos, nos han mostrado evidencias de datos que tienen que ver con relaciones beneficio-costo, con indicadores, nuevos indicadores de sustentabilidad para que las métricas que se requieren precisamente tengan esa confiabilidad y nos muestren dónde estamos parados y de tal manera que con eso pues también se testifique sobre estos ecobeneficios que tiene la transformación de los sistemas agroalimentarios. ¿Qué nos hace falta? Ya lo mencionaron aquí de distinta manera y yo lo resumiría en lo siguiente, parafraseando alguna vez a algún colega investigador que escuché: nadie sabe tanto como todos juntos y nadie puede tanto como todos juntos, lo cual me transmite ese optimismo, convencido de que sí podemos avanzar hacia una agricultura con más reducida, en bajas emisiones, una agricultura regenerativa vinculada con la bioeconomía, de tal manera que nos permita realmente avanzar hacia una seguridad alimentaria, la cual sea, que contribuya también a reducir la pobreza, a la paz social también en nuestras regiones y que finalmente nos ayude a tener un mejor futuro. Sí, hay inquietudes, hay dudas. Yo los invito a que el día de mañana nos acompañen para que juntos veamos y encontremos esos huecos que faltan en esta ecuación para poder realmente avanzar con acciones concretas que nos permitan la recarbonización de los suelos y la descarbonización de los sistemas agroalimentarios. Temas como financiamiento, mercados verdes, bonos de carbono, políticas públicas, son temas que abordaremos el día de mañana. Los invito a que nos acompañen y no me queda más que agradecerles a cada uno de ustedes que estuvieron presencialmente acompañándonos y también de manera virtual por su presencia, su interés. Muchas gracias. Que tengan muy buen día. Buena tarde.
Pues ahora sí, de esta forma concluimos este primer día de actividades del foro sobre recarbonización de los suelos agrarios y descarbonización de los sistemas agroalimentarios. Agradecemos a pues, los participantes, los diferentes panelistas, ponentes, conferencistas, moderadores que hemos tenido el día de hoy. Compartiendo tanto conocimiento y tantos importantes temas y retos que tenemos que abordar entre todos. Agradecemos, por supuesto, a el equipo de intérpretes, que aunque no los hemos visto acá entre nosotros, pero han hecho un trabajo estupendo durante estas 6 horas. Yo agradezco en lo personal a este equipo maravilloso de compañeros que está tras bambalinas y ustedes no los ven, pero han estado haciendo que todo esto haya sido posible el día de hoy. Público virtual, gracias, ha sido multitudinario realmente su presencia y su acompañamiento. Lo hemos podido sentir, ese calorcito de su compañía y no solo por el gasto energético. Pero los emplazamos a que mañana se conecten otra vez con nosotros. Tendremos diferentes temas distintos a los de hoy, pero a su vez complementarios. Y por último, público acá presente, pues les agradecemos obviamente también su presencia. Los invitamos a que mañana también nos acompañen nuevamente. Aquellos que repitan, que regresen, ya tienen sus gafetes, pero sí háganos favor de registrar su firma al ingreso también el día de mañana. Y ahora, 2 avisos que les van a interesar. Les pedimos que nos acompañen en primer lugar para la comida más que merecida. Mis compañeros acá a la salida del auditorio les pueden indicar para que ya vayamos todos juntos. Va a ser en el área de barbecue y una vez terminada la comida, a las 4:30 tenemos programada una visita de campo que se ha organizado acá desde CIMIT. Va a estar a cargo del doctor Simón Fonteyne, si no estoy equivocada. Es una visita a la plataforma de investigación sustentable de larga duración. Esta visita tiene una duración de media hora, 30 minutos. A las 4:30 en la entrada del área donde vamos a estar comiendo nos van a esperar un par de camionetitas para llevarnos, así que los invitamos a que nos acompañen. Dicho esto, gracias a todos.